Today's video is a compilation of the science passages from the SAT reading sections of practice test 1 through practice test 10. So there will be a total of 20 science passages contained in this video, along with answer explanations for each question contained in each passage. So as I go through, I will read the passage out loud, and then I will dive into answer explanations for each question on every passage. So be sure to pay attention to both how I get to the correct answer and why the correct answer is correct, because understanding that process of how to get to that correct answer is very important in improving on the SAT reading section. We also have videos out that are compilations of the literature passages from SAT practice tests 1 through 10, the social science passages from practice tests 1 through 10, the history passages from 1 through 10 as well. So you can find those videos in a playlist at the end of this video if you're looking for those as well. So hopefully this video will help you become more comfortable with approaching the science passages on the SAT reading section, as well as answering the questions about those science passages. So make sure to like, share, and subscribe. There's also a 90-day SAT prep course you can find on our channel. It is under the playlist, so if you're looking to prep for the SAT, I'm very proud to say I believe that would be helpful to you as well, so you can find that as well on our channel. So with that, let's go ahead and get started with the science passages from the reading section of SAT practice test 1. All right, let's get started with passage 3. So this passage is adopted from J.D. Watson and F.H.C. Crick, Genetical Implications of the Structure of Deoxyribonucleic Acid, copyright 1953 by Nature Publishing Group. Watson and Crick deduced the structure of DNA using evidence from Rosalind Franklin and R.G. Gosling's X-ray crystallography diagrams of DNA and from Erwin Chargaff's data on the base composition of DNA. The chemical formula of deoxyribonucleic acid, DNA, is now well established. The molecule is a very long chain, the backbone of which consists of a regular alternation of sugar and phosphate groups. To each sugar is attached a nitrogenous base, which can be of 4 different types. 2 of the possible bases, adenine and guanine, are purines, and the other 2, thymine and cytosine, are pyrimidines. So far as is known, the sequence of bases along the chain is irregular. The monomer unit, consisting of a phosphate, sugar, and base, is known as a nucleotide. The first feature of our structure, which is of biological interest, is that it consists not of one chain, but of 2. These 2 chains are both coiled around a common fiber axis. It has often been assumed that since there was only one chain in the chemical formula, there would be only one in the structural unit. However, the density taken with the X-ray evidence suggests very strongly that there are 2. The other biologically important feature is the manner in which the 2 chains are held together. This is done by hydrogen bonds between the bases. The bases are joined together in pairs, a single base from one chain being hydrogen bonded to a single base from the other. The important part is that only certain pairs of bases will fit into the structure. One member of a pair must be a purine and the other a pyrimidine in order to bridge between the 2 chains. If a pair consisted of 2 purines, for example, there would not be room for it. We believe that the bases will be present almost entirely in their most probable form. If this is true, the conditions for forming hydrogen bonds are more restrictive, and the only pairs of bases possible are adenine with thymine and guanine with cytosine. Adenine, for example, can occur on either chain, but when it does, its partner on the other chain must always be thymine. The phosphate sugar backbone of our model is completely regular, but any sequence of the pairs of bases can fit into the structure. It follows that in a long molecule, many different permutations are possible, and it therefore seems likely that the precise sequence of bases is the code which carries the genetical information. If the actual order of the bases on one of the pairs of chains were given, one could write down the exact order of the bases on the other one because of the specific pairing. Thus, one chain is, as it were, the complement of the other, and it is this feature which suggests how the deoxyribonucleic acid molecule might duplicate itself. Alright, and then we are given a table. Alright, so let's go ahead and let's get started with our questions then. Alright, so we've got question 22. The authors use the word backbone in lines 3 and 39 to indicate that, well, let's go ahead and take a look of lines 339, the word backbone. Alright, what is it indicating? This molecule is a very long chain, the backbone of which consists of a regular alternation, which is a repeating pattern, of sugar and phosphate groups. Okay, so we have a backbone of sugar and phosphate groups that are alternating. Next was line 39. The phosphate sugar backbone. Okay, so once again, this phosphate sugar backbone where they're alternating of our model is completely regular, but any sequence of the pairs of bases can fit in the structure. So our backbone is sugar and phosphate and it's alternating. So let's look at our options. A, only very long chains of DNA can be taken from an organism with a spinal column. No, okay, the backbone here is not referring to a spinal column. B, the main structure of a chain in a DNA molecule is composed of repeating units. Yes, that alternating sugar and phosphate, right, that forms our backbone. C, a chain in a DNA molecule consists entirely of phosphates or of sugars? No, it includes bases. D, nitrogenous bases form the main structural unit of DNA. No. What form the main structural unit of DNA is a combination of nitrogenous bases and sugars and phosphates, right? Or I'm sorry, the main structure of the chain in a DNA molecule is the sugars phosphates, really. All right, so a student claims that nitrogenous bases pair randomly with each other. Which of the following statements in the passage contradicts the student's claims? All right, well, here what we're looking for is where we talk about how pyrimidines must bond with purines. So I remember that was about late 20s, I believe, towards the end of this paragraph right here. We have one member of a pair must be a purine and the other must be a pyrimidine in order to bridge between the two chains. So that's going to be 27 to 29 is where I'm looking for my evidence there. Right, we need one pyrimidine and we need one purine. So that's going to be answer choice D. Right, because that shows how they don't pair randomly. You have to have a pyrimidine with a purine. All right, in the second paragraph, lines 12 through 19, what do the authors claim to be a feature of biological interest? Okay, well, let's go to lines 12 through 9 and see what the authors say about a feature being of biological interest. The first feature of our structure, which is of biological interest, so they're really being very direct, is that it consists not of one chain, but of two. Okay, so that's really obvious. That biological interest then is the DNA being two chains. Okay, and that's answer choice D we see. Not the X-ray evidence, not the common fiber use. The chemical formula of DNA is also incorrect. DNA consisting of two chains, it was very direct in saying that's the first feature of biological interest. So 24, it has to be answer choice D. All right, question 25. The author's main purpose of including the information about X-ray evidence and density is to what? Well, let's go take a look about where we talk about X-ray evidence and density and see what the purpose of including that is. So X-ray evidence and density. I remember X-ray evidence and density was somewhere in the sort of the beginning. Let's see where it exactly is, right here. The density taken with the X-ray evidence, this is in lines 18 and 19, suggests very strongly that there are two. Okay, so we're talking about two sugar phosphate backbones, right? Or two chains of DNA. Okay. All right, so this is really providing support for the author's claim about the number of chains of DNA in that molecule. So that's going to be answer choice C for 25, right? They talked about how there were two chains based on that X-ray evidence and density, as I showed you with those lines 18 and 19 up there. As far as A, establishing that DNA is the genic molecule, we didn't talk about that. We were really just talking about the two chains. B, presenting an alternate hypothesis about the composition of a nucleotide, no. And D, confirming the relationship between the density of DNA and the known chemical formula. We don't discuss the chemical formula of DNA there. 26, based on the passage, the author's statement, if a pair consisted of two purines, for example, there would not be room for it, in lines 29 through 30, implies that a pair what? Well, that's going to be any pair of purines would be larger than the space between a sugar and phosphate group. Let's see here. All right, so that is going to be incorrect, right? We're talking about the space implies that a pair of purines would be larger than the space between a sugar and a phosphate group. No. Right? It's not larger than the space between a sugar and a phosphate group. It's larger than the space between those backbones. So that's incorrect. A pair of purines would be larger than a pair consisting of a purine and a pyrimidine. That one right there is going to be correct, right? If we had two purines, then they're not going to fit, right? It talked about how a purine and a pyrimidine, they fit kind of like this, right? One of them fits like that, one of them fits like that. So if we were to have two purines, then we would have it would be too large, we see, because it won't fit into each other, right? So it'd be larger than that pair consisting of a purine and a pyrimidine, right? So that's going to be answer choice B. A pair of pyrimidines would be larger than a pair of purines. We don't discuss the differences between their sizes. And D, consisting of a purine and a pyrimidine, would be larger than a pair of pyrimidines. No, that's false. All right, and then 27, the author's use of the words exact, specific, and complement in lines 47 to 49 in the final paragraph functions mainly to do what? Well, let's go take a look at that. If the actual order of the bases of one pair of chains were given, one could write down the exact order of the bases on the other because of the specific pairing. So this is really stressing that they are complements of each other, the two strands of DNA. Right, those two strands or those two chains of DNA. All right, so it functions mainly to do what? Well, let's take a look at our answer choices. We have A, confirm the nucleotide sequences are known for most molecules of DNA. No, we're really talking about how you can get one strand from the other strand. B, counter the claim that the sequences of pairs can occur in any order. No, sequences of bases along one chain can occur in any order. They just can't along both chains. C, support the claim that the phosphate sugar backbone of the author's model is completely regular. The the phosphate we're not really talking about the phosphate backbone here. We're talking about the in-betweens of those backbones, so what goes in these spaces. Emphasizing how one chain of DNA may serve as a template to be copied during DNA replication, yes, because we're talking about how there is specific pairing between the two, right? Guanines have to pair with cytosines and adenines have to pair with thymines. So based on the table in the passage, which choice gives the correct percentages of the purines in yeast DNA? Well, let's go back and find what our purines are real quick. We see that two of the possible bases, adenine and guanine, are purines. Okay, so adenine and guanine are purines, and our question was asking for the purines in yeast DNA. So adenine and guanine in yeast DNA. We see that that's going to be 31.3 and 18.7. So we got to go find our answers there. 31.3 and 18.7, and that's going to be answer choice C for question 28. All right, question 29. Do the data in the table support the author's proposed pairing of bases in DNA? All right, well, the author's proposed pairing of bases is adenine with thymine, so there should be roughly equal amounts of those, and guanine and cytosine should have roughly equal amounts. And I see that that is the pattern, right? We have roughly equal amounts of adenine and thymine, roughly equal amounts of cytosine and guanine. So yes, it does. Okay, so I can get rid of any answer choices with no there, so I can get rid of C and D. So it's going to be yes, because for each organism, the percent of adenine is closest to the percent of thymine, and the percent of guanine is closest to the percent of cytosine. So yes, my answer for 29 then is going to be answer choice A. All right, question 30. According to the table, which of the following pairs of base percentages in sea urchin DNA provides evidence in support of your answer to the previous question? So I'm looking for adenine and guanine being the same, or for thymine and cytosine being the same. I see that these answers are all different, so they can't be correct, and my answer has to be A. And I can go ahead and support that real quick with the sea urchin DNA. Sea urchin DNA, we see we have guanine and our cytosine are both very similar. So that gives us our answer for 50 is going to be, or I'm sorry, 30 is going to be A. 31, based on the table, is the percentage of adenine in each organism's DNA the same, or does it vary, and which statement made by the author is most consistent with the data? Well, we saw that it varies, right? And I'll go back and quick show you that. Let's see, yep, we see it varies. We see we have on the high end, we have 30s, we also have 32, and we have 29, we have 23.6 as well, so it does vary. All right, now we've got which statement made by the authors is most consistent with that. Well, we see that it varies. And as far as which lines then, so as far as the lines go, let's just go ahead and find where we talk about variance. That's going to be roughly somewhere around right here. So we have the phosphate sugar backbone of our model is completely regular, but any sequence of bases can fit. It follows that in a long molecule, many different permutations are possible, so many different arrangements are possible. Therefore, it seems likely the precise sequence of bases of the code which carries the genetic information. So the key part there is many different permutations are possible. That is supported by the differences in the number of guanines and cytosines. So, or I'm sorry, the difference in thymines and guanines and things like that. Answer there is D, not C. I circled the wrong one. So answer for 31 is going to be D then, and we can move on to our next. All right, let's get into passage 5, so our last passage. So we have a split up between passage 1 and passage 2 here. So I'm going to read passage 1, answer the questions that are specific to that only. Then I'll read passage 2, answer the questions that are specific to that only. And then finally, the questions that relate to both passages. So let's go ahead and get started with passage 1. Passage 1 is adapted from Michael Slezak, Space Mining, the Next Gold Rush, copyright 2013 by New Scientist. Follow the money and you will end up in space. That's the message from a first-of-its-kind forum on mining beyond Earth. Convened in Sydney by the Australian Centre for Space Engineering Research, the event brought together mining companies, robotics experts, lunar scientists, and government agencies that are all working to make space mining a reality. The forum comes hot on the heels of the 2012 unveiling of 2 private asteroid mining firms. Planetary Resources of Washington says it will launch its first prospecting telescopes in 2 years, while Deep Space Industries of Virginia hopes to be harvesting metals from asteroids by 2020. Another commercial venture that sprung up in 2012, Golden Spike of Colorado, will be offering trips to the moon, including to potential lunar miners. Within a few decades, these firms may be meeting earthly demands for precious metals such as platinum and gold and the rare earth elements vital for personal electronics such as yttrium and lanthanum. But like the gold rush pioneers who transformed the western United States, the first space miners won't just enrich themselves, they also hope to build an off-planet economy free from any bonds within Earth, in which the materials extracted and processed from the moon and asteroids are delivered for space-based projects. In this scenario, water mined from other worlds could become the most desired commodity. In the desert, what's worth more, a kilogram of gold or a kilogram of water? Asked Chris Sackney of Honeybee Robotics in New York. Gold is useless. Water will let you live. Water ice from the moon's poles could be sent to astronauts on the International Space Station for drinking or as a radiation shield. Splitting water into oxygen and hydrogen makes spacecraft fuel, so ice-rich asteroids could become interplanetary refueling stations. Companies are eyeing the iron, silicon, and aluminum in lunar soil and asteroids, which could be used in 3D printers to make spare parts or machinery. Others want to turn space dirt into concrete for landing pads, shelters, and roads. All right, let's get into passage 1 then. We got in lines 9 through 17, the author of passage 1 mentions several companies primarily to what? Well, if we look at lines 9 through 17, he's saying that the forum comes on the heels of the 2012 unveiling of 2 private asteroid mining firms. It says they'll be launching their first telescope in 2 years, harvesting metals from asteroids by 2020, talking about trips to the moon for potential lunar miners. So what we're really doing there is we're providing evidence of that growing interest in that space mining, right? We're talking about multiple different mining companies that are interested in space mining, right? Space mining for precious metals and things like that. So those were what all of those examples were. We're not noting any technological advances that are making it possible because we didn't state any. We're not emphasizing large profits because we didn't talk about anything monetary. We're not highlighting the diverse ways to carry out space mining operations because we didn't discuss any diverse ways. So we can get rid of D there. All right, question 43. The author of passage 1 indicates that space mining could have which positive effect? Well, the big thing that he states is that we have materials that are important to Earth's economy that space mining could yield, right? And the next question, I'm assuming, is probably an evidence question, but I'll go ahead and support this answer anyway. And if we were to look up to lines, where is it? Let's see here. Right here. At 18, within a few decades, these firms may be meeting earthly demands for precious metals such as platinum and gold and the rare earth elements vital for personal electronics such as yttrium and lanthanum. So that's from, this is 18 to 23. We're talking about these earth metals that we need for personal electronics such as yttrium and lanthanum, as well as precious metals that we want. So that's where we're really talking about yielding those important materials to Earth's economy. So that's going to be in lines 18 to 22 right there. So 44 is going to be answer choice A. All right, that was what we circled for our evidence for 43, and that's what we're asked for in 44. So as used in line 19, demands most nearly means what? Well, let's go to line 19 and come up with our own answer choice first. All right, so we have, within a few decades, these firms may be meeting the earthly demands for precious metals. So right here, in the scenario, meeting the earthly demands is really meeting the earthly, let's come up with a good one here. Meeting the earthly, let's see, this is a tough one. Within a few decades, these firms may be meeting the earthly demands for precious metals. Really, in this case, I'd say desires is probably a good one for demands there. Desires for precious metals. And we do have that as an answer choice, yep. So that one right there is going to be D. We're really talking about how we want these precious metals and we also want/need these yttrium and these things for personal electronics. So really desires is the best one there. Not claims because no one's making claims to it. Not inquiries because inquiries is really just kind of raising questions or looking into it a little bit, but we're talking about concrete desires here, not offers. These are big time desires. These are desires that we want, things that we demand. So our answer for 45 there is going to be D. All right, question 46. What function does the discussion of water in lines 35 to 40 serve in passage 1? Well, let's go take a look, right? We've got lines 35 to 40, I believe it said. Yep. Okay. So what's our context before it? Well, before it, we talk about how water's mined from other worlds could become the most desired commodity because water's worth more than gold in space, right? And in the desert, as an example, gold's useless, water lets you live. Now we're talking about water, ice from the moon's poles could be sent to astronauts on the International Space Station for drinking or as a radiation shield. So we're illustrating that idea that water is more important than gold in space. Splitting water into oxygen and hydrogen makes spacecraft fuel, so ice-rich asteroids could become interplanetary refueling stations. So we're really just illustrating our idea that we stated in this paragraph right here about gold being worth less than water is in space because water is very necessary and needed in space and it's scarce in supply. So we're really illustrating that idea that came before it there. So I'm going to see if there's an answer choice that says that. A says it continues an extended comparison that begins in the previous paragraph. No, we're not continuing a comparison. B, it provides an unexpected answer to a question raised. We're not providing any unexpected answer to any question. C, it offers hypothetical examples supporting a claim in the previous paragraph. Yes, we are illustrating or supporting that claim in that previous paragraph by offering up these examples of where water is worth more than gold. So that's really the big idea there in 46 would be C. D examines possible outcomes of a proposal put forth. We're not examining outcomes, we're just providing hypothetical examples where water is worth more than gold. 47, the passage 2. All right, so we got to go to passage 2 and read that first. The motivation for deep space travel is shifting from discovery to economics. The past year has seen a flurry of proposals aimed at bringing celestial riches down to Earth. No doubt this will make a few billionaires even wealthier, but we all stand to gain. The mineral bounty and spin-off technologies can enrich us all. But before miners start firing up their rockets, we should pause for thought. At first glance, space mining seems to sidestep most environmental concerns. There is probably no life on asteroids and thus no habitats to trash, but its consequences both here on Earth and in space merit careful consideration. Part of this is about principles. Some will argue that space's magnificent desolation is not ours to despoil, just as they argue that our own planet's poles should remain pristine. Others will suggest that glutting ourselves on space's riches is not an acceptable alternative to developing more sustainable ways of earthly life. History suggests that those will be hard lines to hold, and it may be difficult to persuade the public that such barren environments are worth preserving. After all, they exist in vast abundance, and even fewer people will experience them than have walked through Antarctica's icy landscapes. There's also the emerging off-world economy to consider. The resources that are valuable in orbit and beyond may be very different to those we prize on Earth. Questions of their stewardship have barely been broached, and the relevant legal and regulatory framework is fragmentary, to put it mildly. Space miners, like their earthly counterparts, are often reluctant to engage with such questions. One speaker at last week's space mining forum in Sydney, Australia, concluded with a plea that regulation should be avoided, but miners have much to gain from a broad agreement on the for-profit exploitation of space. Without consensus, claims will be disputed, investments risky, and the gains made insecure. It is in all our best long-term interest to seek one out. All right. The central claim of passage 2 is that space mining has a positive potential, but what? Well, really what we're talking about in passage 2, as far as space mining, is that it has positive potential, but that there are ramifications that we need to consider, right? There are effects that need to be thoughtfully considered before it becomes a reality. So those things include things like public policy, right? How is this going to be regulated? How is this going to be made so that there's property rights in space, right? There's not much laws, it's said. So we're really talking about it has a lot of potential that's good for the world as far as economics go, but we need to really think more about it and thoughtfully consider it before it becomes a reality because there aren't enough laws on the books for it. A, it will end up encouraging humanity's reckless treatment of the environment. We never say it will encourage that treatment. We say that it's possible, but we're not saying for sure it will. C, such potential may not include replenishing key resources that are disappearing on Earth. No, we say that it's possible that it could include replenishing key resources that are disappearing on Earth. D, experts disagree about the commercial viability of the discoveries it yields. No, experts do not disagree about that. They all agree that it could be very commercially viable. As used in line 68, hold most nearly means what? Well, let's go take a look at what line 68 has to say, and let's come up with our own word for hold. All right, so we've got history suggests that these will be hard lines to hold, and it may be difficult to persuade the public that such barren environments are worth preserving. So right here, I would say maintain is probably the best word if I was to come up with one, right? These will be hard lines to maintain or to hold, right? To keep these lines up, to maintain these lines between developing a space-built economy and having it be sustainable. So that's really what I would say there is maintain for hold. And we see that we do have that as an answer choice. So that one right there, 48, is going to be A. B, grip, no, because we're talking about holding or maintaining our lines here. We don't grip a line. Restraining a line, we also don't do that. Withstanding a line, we also don't do that. All right, now we've got 49, which statement best describes the relationship between the passage. All right, well, if we're really to think about the passage 1 is really full force for space explanation. So I'm going to write P1 for passage 1. We are really for space exploration, and we are positive towards it. Now, passage 2, it's positive towards it, but it's reserved, right? We think, okay, this is going to be good for the economy, but there's some problems with it right now, right? So he's kind of reserved about it at the moment. He says that there aren't enough laws on the books to protect property up there and profits, and he says that there's still some things that should be considered environmentally. So he has some reservations about the things argued for in passage 1. So let's take a look at our proposals here. We have A, passage 2 refutes the central claim advanced in passage 1. We're not refuting the claim that it's positive, right? We're agreeing with that. 2, passage 2 illustrates the phenomenon described in more general terms. We're not illustrating a phenomenon described in general terms. Passage 2 argues against the practicality. We're not arguing against the practicality of the proposals. We're just reserved about we're not against the practicality of the proposals. He acknowledges that it can be positive economically. So we're not arguing against the practicality of it, but we're just reserved about the developments, right? We want to take a little bit more time and not rush into things. So our answer there is going to be D. All right, 50. The author of passage 2 would most likely respond to the discussions of the future of space mining in lines 18 to 28, passage 1, by claiming that such a future is what? All right, well, let's go ahead and go back to those lines. So we've got 18 to 28, passage 1. How is passage 2's author going to respond to that? Well, we've got within a few decades, so we're starting right here. These firms may be meeting earthly demands for precious metals such as platinum and gold and the rare earth elements vital for personal electronics such as yttrium and lanthanum. But like the gold rush pioneers who transformed the western United States, the first space miners won't just enrich themselves. They also hope to build an off-planet economy free of any bonds with Earth, in which the materials extracted and processed from the moon and asteroids are delivered for space-based projects. Okay, here's what passage 2 really has to say about that. He's reserved about it, and he thinks that there needs to be more policy involved in it in order to protect the property rights up there and profit and investments, really, is what we're talking about there. I'm guessing next question's evidence if I had to guess for this one, and it is. All right, so we have passage 2 would most likely respond by saying that C is incorrect because he never talks about technologies that do not exist. D seems certain to affect Earth's economy in a negative way. No, he agrees it would benefit it positively. A is inconsistent with the sustainable use of space resources. No, he doesn't argue that it's unsustainable for sure. He doesn't argue for sure that it's unsustainable. And then B will be difficult to bring about in the absence of regulations, and that one will be correct there. He argues for regulations to protect property and profit and investments up there. So which choice is going to give us this one? I believe that sometimes it can be helpful to take a look at words here, and something like insecure jumps out to me. So I'm going to start with 85 to 87, because I'm guessing it talks about property rights and profits being insecure. All right, so we've got without consensus, claims will be disputed, investments risky, and the gains made insecure. Okay, that's really talking about how we need that. That consensus is referring to the policy that we need and the rules basically for the space miners. So without that consensus on policy, claims will be disputed, investments risky, and the gains made insecure. So that's 85 to 87. 85 to 87, and that will be my evidence then, because that evidence there is showing how it will be difficult to bring about in the absence of regulations, such a future where space mining is really at the forefront of our economy. All right, now we have 52. Which point about the resources that will be highly valued in space is implicit in passage 2 and implicit in passage 1 and explicit in passage 2? Well, in passage 2, we explicitly say that those materials that we mine for or take from space will be different from those in Earth. So 52, really A is going to be our best answer there. What we take from space is going to be different from those resources that are valuable on Earth, right? So for example, we say directly, and I'll go ahead and find it up here real quick. We say there's also an emerging off-world economy to consider. The resources that are valuable in orbit and beyond may be very different from those we prize on Earth. So that's us explicitly stating that those valuable in space will be different from that on Earth. And if we look over here in passage 1, we really just talk about implicitly that water would be maybe more desirable than gold in space. So that's more implicit, whereas in passage 2 we are explicit with that. So that takes us through all of our answers for that 5th passage and for SAT practice test 1. Okay, passage 3, we'll go ahead and it's a 2-passage one, so we're going to read the first passage, answer the questions on the first passage, then read the second passage, then answer the questions on the second passage, and then after that we'll go ahead and answer the questions on both, because that's the strategy I recommend and that's the strategy I use as well. Okay, so with that, let's go and get started. We have passage 1 is adopted from Nicholas Carr, author Nicholas Carr. The web shatters focus, rewires brains, copyright 2010 by Condé Nast. Okay, I see my second passage is from Steven Pinker, Mind Over Mass Media. That one's in the New York Times, okay? But we're focusing on the first one, so we have rewires brains, right? Web shatters focus. Okay, passage 1. The mental consequences of our online info crunching are not universally bad. Certain cognitive skills are strengthened by our use of computers and the net. These tend to involve more primitive mental functions such as hand-eye coordination, reflex response, and the processing of visual cues. One much-cited study of video gaming revealed that after just 10 days of playing action games on computers, a group of young people had significantly boosted the speed with which they could shift their visual focus between various images and tasks. It's likely that web browsing also strengthens brain's functions related to fast-paced problem solving, particularly when it requires spotting patterns in a welter of data. A British study of the way women search for medical information online indicated that an experienced internet user can, at least in some cases, assess the trustworthiness and probable value of a web page in a matter of seconds. The more we practice surfing and scanning, the more adept our brains become at those tasks. But it would be a serious mistake not to look narrowly at such benefits and conclude that the web is making us smarter. In a science article published in early 2009, prominent developmental psychologist Patricia Greenfeld reviewed more than 40 studies of the effects of various types of media on intelligence and learning ability. She concluded that every medium develops some cognitive skills at the expense of others. Our growing use of the net and other screen-based technologies, she wrote, has led to the widespread and sophisticated development of visual spatial skills. But those gains go hand in hand with a weakening of our capacity for the kind of deep processing that underpins mindful knowledge acquisition, inductive analysis, critical thinking, imagination, and reflection. We know that the human brain is highly plastic. Neurons and synapses change as circumstances change. When we adapt to a new cultural phenomenon, including the use of a new medium, we end up with a different brain, says Michael Merzenich, pioneer of the field of neuroplasticity. That means our online habits continue to reverberate in the workings of our brain cells, even when we're not at a computer. We're exercising the neural circuits devoted to skimming and multitasking while ignoring those used for reading and deep thinking. Okay, the author of passage 1 indicates which of the following about the use of screen-based technologies. Well, we know that he's really talking about how screen-based technologies, right? In this case, it doesn't say main focus, so we just have to find which one's true here. As far as it should be thoroughly studied, he doesn't make that claim. It makes brains increasingly rigid. He doesn't make that claim. It has some positive effects. He does make that claim in passage 1. Not that it should be widely encouraged. He does not make that claim either. Which choice provides the best evidence? Okay, best evidence here, that's really going to be in the beginning where we talk about, looks like right here, right? We have certain cognitive skills are strengthened by our use of the computers and the net. So that's in lines 3 to 4. That's showing that there are positive effects there. So I'm going to look for something that says lines 3 to 4. If we have that, I see I do have that as an answer choice. So my answer then would be A for number 23. Next up, I've got question 24. The author of passage 1 indicates that becoming adept at using the internet can do what? Well, we know that in passage 1, he discusses how using the internet is going to make people's skills as far as processing information quicker, but at the same time, it's going to make our ability to think deeply and analyze things as far as a creative way. It's going to make that lessen, right? It's going to undermine that. So we're going to look for an answer choice that says one of those two things. We have option A, make people complacent about their health. No. B, undermine the ability to think deeply. We do make that claim. So our answer there would be B. Okay, not increase people's social contacts, not improve self-confidence. Our answer there would be B. That is the only claim that is supported by the text. As used in line 40, plastic means what? Well, let's go take a look at line 40 and the word plastic. So we know that the human brain is highly plastic. Neurons and synapses change as circumstances change. Okay, so we know in this case plastic is meaning that it is changeable or malleable. I'm looking at either of those as an answer choice. Creative would be an incorrect answer. Same with artificial. Same with malleable. That is correct, right? Malleable means changeable. So our answer there would be C. Sculptural, absolutely not. Okay, answer here is malleable or changeable. Okay, if you don't know what malleable means, basically just means it's changeable. So answer there for 25 would be C. At this point, we go and move on. We got 26. We see it refers to passage 2, so we go read passage 2. Critics of new media sometimes use science itself to press their case, citing research that shows how experience can change the brain, but cognitive neuroscientists roll their eyes at such talk. Yes, every time we learn a fact or skill, the writing of the brain changes, or the wiring of the brain changes. It's not as if the information is stored in the pancreas, but the existence of neuroplasticity does not mean the brain is a blob of clay pounded into shape by experience. Experience does not revamp the basic information processing capacities of the brain. Speed reading programs have long claimed to do just that, but the verdict was rendered by Woody Allen after he read Leo Tolstoy's famously long War and Peace in one sitting. It was about Russia. Genuine multitasking, too, has been exposed as a myth, not just by laboratory studies, but by the familiar sight of an SUV undulating between lanes as the driver cuts deals on his cell phone. Moreover, the effects of experience are highly specific to experience themselves. If you train people to do one thing, recognize shapes, solve math, find hidden words, they get better at doing that thing, but almost nothing else. Music doesn't make you better at math. Conjugating Latin doesn't make you more logical. Brain training games don't make you smarter. Accomplished people don't bulk up their brains with intellectual calisthenics. They immerse themselves in their fields. Novelists read lots of novels. Scientists read lots of science. The effect of consuming electronic media are likely to be far more limited than the panic implies. Media critics write as if the brain takes on the qualities of whatever it consumes, the informational equivalent of you are what you eat. As with ancient people who have believed Eating fierce animals made them fierce. They assume watching quick cuts and rock videos turns your mental life into quick cuts, or reading bullet points and online posting turns your brain into bullet points and online postings. At this point, we answer questions on passage 2. Passage 2 refers to the novel War and Peace by Woody Allen to suggest what? That he didn't like his writing style? Absolutely not. That's incorrect. Could not comprehend the novel by speed reading it. Yes, right? We talked about how Woody Allen said it was about Russia. Obviously, it's about a lot more than Russia. Obviously, it's showing he cannot comprehend that entire novel, War and Peace, in one sitting by speed reading it. Okay, so our answer there would be answer choice B. At this point, we go ahead and move on. We got question 27. According to the author of passage 2, what do novelists and scientists have in common? Okay, we talk about how they immerse themselves in their fields. Okay, that's pretty much a direct quote. They immerse themselves in their fields, so it's not about taking risks. It's not about them being eager to improve their minds. It's not about them being curious about other subjects, okay? It is about them becoming absorbed in their fields, right? We talk about that. That's pretty much a direct quote of them really immersing themselves in those fields, right? So our answer there would be D for 27. At this point, we move on to 28. We have the analogy in the final sentence of passage 2 has primarily which effect? Well, if we were going to take a look at that, let's go and take a look at the analogy in passage 2. It says it's at the end. Okay, I highlighted that here. We have, as with ancient animals, eating fierce animals makes them fierce. People think that watching quick cuts and rock videos or reading bullet points makes it so your brain can only process those things. Okay, what that's doing is that's criticizing that other group that makes those statements. So criticizing those other people who are maybe neuroscientists or whoever that are making those statements. Where you're really being critical of a particular group, that group that's making those statements. Okay, we're not alluding to the past to evoke a nostalgic response. We're not employing humor. Okay, to soften the severe opinion of human behavior, and we're not using ornate language to illustrate a difficult concept either. We are criticizing that view of that particular group who advocates that sort of approach where you are what you eat, that you are what you eat approach. Okay, at this point we got 29. The main purpose of the passage is to do what? Okay, in this case, each passage, obviously, so we're referring to both passages. Both passages, what are they doing? Well, in this case, both passages, they're making their own argument or making their own case on this subject. Okay, so they're not comparing brain function in those who play games on the internet and those who browse it. Okay, that would be way off topic. That's not even close to the correct answer. B, reporting on the problem-solving skills of individuals with varying levels of internet experience. We don't talk about varying levels of internet experience. Taking a position on increasing financial support. We don't talk about increasing financial support for studies. And then making an argument about the effects of electronic media use on the brain. Yes, that's correct. Both passages make that case there. So now we got question 30. We see we're talking about the relationship between the two passages. What's best describing that relationship between the two? Okay, well, what do we know about passage 1? We know that passage 1 is taking a stance that is contrasted or criticized by passage 2. We know passage 2 really comes at the author of passage 1 saying your conclusions are incorrect. So we're going to look for an answer choice that says that. Passage 2 relates to the first-hand experiences that contrast with the clinical approach in passage 1. No, we don't really have clinical approach in passage 1, so that's wrong. Passage 2 critiques or criticizes the conclusion drawn from the research in passage 1. Yes, okay, we're going straight at that author of passage 1. Passage 2 is saying, nope, you're wrong, you're completely wrong, here's why. Okay, so our answer there would be B. Option C, passage 2 takes a high-level view of a result that passage 1 examines in depth. No. Passage 2 predicts the negative reactions that the findings discussed in passage 1 might produce. We're not predicting any negative reactions. Our answer is B for number 30. At this point, we got question 31. Which of the following points would the authors of both passages most likely agree? Okay, so we got pretty much, we just have to go through here. Okay, there's not really any way to predict this one. So as we go through, we'll just find what one both the authors would agree. Computer savvy children tend to demonstrate better hand-eye coordination than do their parents. Okay, no, we don't talk about the relationship between kids and their parents here and how that deals with computer savviness. Option B, those who criticize consumers of electronic media tend to overreact in their criticism. We don't talk about the level of their overreaction or underreaction, so that's incorrect. C, improved visual spatial skills do not generalize to improved skills in other areas. Yes, both of them say that doing one thing does not improve your ability to do another. So our answer there would be C for number 31. At this point now we've got question 32. Which choice provides the best evidence that the author of passage 2 would agree to some extent with the claim attributed to Michael Merzinch in lines 41 to 43 of passage 1? Best evidence the author of passage 2 would agree to some extent with that claim. So we got to go find that claim real quick. So that's 41 to 43. So let's go take a look at that. We see that it is when we adapt to a new cultural phenomenon, including the use of a new medium, we end up with a different brain. Okay, obviously passage 2 would agree with that. Okay, in this case, we're asked for the evidence. I remember that we say the word, I believe that we say the word yes when we talk about Him saying yes, obviously it changes. So it looks like that was 54. I see I have it highlighted. Yes, every time we learn a factor skill, the wiring of the brain changes. So he's saying obviously he would agree with that there. So our answer there would be 54 to 56. Okay, so our answer there is going to be B for number 32. At this point, we go ahead and move on. We got our next. We got this passage adopted from Geoffrey Giller. Long a mystery, how 500-meter high undersea waveforms is revealed. We got this copyright 2014. This is obviously going to be a science section. Scientific American is where it's published. Some of the largest ocean waves in the world are nearly impossible to see. Unlike other large waves, these rollers, called internal waves, do not ride the ocean surface. Instead, they move underwater, undetectable, without the use of satellite imagery or sophisticated monitoring equipment. Despite their hidden nature, internal waves are fundamental parts of ocean water dynamics, transferring heat to the ocean depths and bringing up colder water from below. They can reach staggering heights, some as tall as skyscrapers. Because these waves are involved in ocean mixing and thus the transfer of heat, understanding them is crucial to global climate modeling, says Tom Peacock, a researcher at MIT. Most models fail to take internal waves into account. If we want to have more and more accurate climate models, we have to be able to capture processes such as these. Peacock and his colleagues tried to do just that. Their study, published in November in Geophysical Research Letters, focused on internal waves generated in the Luzon Strait, which separates Taiwan and the Philippines. Internal waves in this region, thought to be some of the largest in the world, can reach heights of about 500 meters high. That's the same height as the Freedom Tower that's just been built in New York. Although scientists knew of this phenomenon in the South China Sea and beyond, they didn't know how internal waves were formed. To find out, Peacock and a team of researchers from MIT and the Woods Hole Oceanographic Institution worked with France's National Center for Scientific Research using a giant facility there called the Coriolis platform. The rotating platform, about 15 meters, 49.2 feet in diameter, turns at variable speeds and can simulate Earth's rotation. It also has walls, which means scientists can fill it with water and create accurate large-scale simulations of various oceanographic scenarios. Peacock and his team built a carbon fiber resin scale model of Luzon Strait, including the islands and surrounding ocean floor topography. They then filled the platform with water of varying salinity to replicate the different densities found at the strait, with denser, saltier water below and lighter, less briny water above. Small particles were added to the solution, illuminated with lights from below in order to track how the liquid moved. Finally, they recreated tides using two large plungers to see how internal waves themselves formed. The Luzon Strait's underwater topography, with a distinct double-ridge shape, turns out to be responsible for generating the underwater waves. As the tide rises and falls, the water moves through the strait. Colder and denser water is pushed up over the ridges into warmer, less dense layers above it. This action results in the bumps of colder water trailed by warmer water that generated an internal wave. As these waves move toward land, they become steeper, much the same way waves at the beach become taller before they hit the shore until they break on a continental shelf. The researchers were also able to devise a mathematical model that describes the movement and formation of these waves. Whereas the model is specific to the Luzon Strait, it can still help researchers understand how internal waves are generated in other places around the world. Eventually, this information will be incorporated into global climate models, making them more accurate. It's very clear within the context of these global climate models that internal waves play a role in driving ocean circulations. Okay, at this point, we go ahead and answer our questions. First paragraph serves mainly to do what? Okay, we know in our first paragraph, let me just switch over to my pen here. Okay, we know in our first paragraph that we're really just describing this scientific phenomenon here. So we're talking about how we've got, obviously we have large waves, we're describing these internal waves. We're not talking about our study yet, just focusing on describing internal waves there. So I'm looking for an answer choice that talks about that. First paragraph serves mainly option A, explain how a scientific device is used. No. Note a common misconception. No. Describe a natural phenomenon. Yes. Internal waves. And address its importance. Yes, that's what we're doing there. We talk about how its importance being the ability to develop better climate models. Okay, so our answer there would be C. Yeah, so C would be our best answer for 43. 44, as used in line 19, captures most close in meaning to what? Well, let's go take a look in line 19, come up with our best answer choice first. That way we don't get swayed by our answers. So we have to be able to capture processes such as this. In this case, we're talking about these internal waves and capturing these models. Okay, so we want to have more and more climate models. We have to be able to capture processes, the process of generating these internal waves. That would mean recording processes like this, right? Having access to that data, in which case we have to record it because we don't have it yet. So our answer there would be B, we want to record it. That's what that capture means there, not secure and not absorb. Our answer would be B for 44. Now we got 45. According to Peacock, the ability to monitor internal waves is significant primarily because of what? Okay, monitoring these internal waves is significant because it's going to allow us to have better climate models. Okay, that's his main argument here. We need to have this data so we can make better climate models. So we have option D, the study of such waves will inform the development of key scientific models. Yes. We'll go ahead and go over why A and through C are wrong real quick. It will allow scientists to verify maximum height of such waves. We never make that argument. B, it will allow researchers to shift their focus to improving the quality of satellite images. We never make that argument. C, the study of wave patterns will enable regions to predict and prevent coastal damage. We never talk about coastal damage, therefore C is incorrect as well. 46, we need evidence there. Okay, that's going to be where we talk about those climate models. I'm going to quick check. Doesn't look like we have the word models anywhere here, so I'm just going to kind of have to go through. I believe it was towards the beginning that we started talking about that, but it also wasn't in like the first couple lines. It's going to be more towards, I might have highlighted it right here, okay? When most models fail to take internal waves into account, if we want to have more and better, I'll put it in blue so you can see, if we want to have more and more accurate climate models, we have to be able to capture processes like these. So that's going to be in lines, looks like 17 to 19 would be what I'm looking at there for my evidence. So I'm going to see if I have that. I see that I do, so my answer then for 46 would be answer choice C. All right, so at this point we go ahead and move on. We got question 47. We're doing pretty good on time. As using line 65, devise most nearly means what? Okay, at this point we got to go to line 65 and see what devise most nearly means. Okay, line 65, the researchers were able to devise a mathematical model that describes the movement and formation of these waves. In this case, that means create, because they didn't have one before, so them devising a mathematical model would mean to create a mathematical model. So our answer then would be A for number 47. Okay, now we got question 48. We've got, based on the information in the passage, it can be reasonably inferred that all internal waves, what? So we have option A, reaching the approximately the same height, even though the locations and depths vary. No. We know that topography is going to influence this. We have option B, may be caused by similar factors, but are influenced by the distinct topographies of different regions. Yes. Okay, we are asked for evidence in the next question, so I can also go ahead and give you that. That's going to be where we talk about how, towards the end, that model is distinct to that strait, that Luzon Strait, or that Luzon Strait. Okay, so we have the model being specific to the Luzon Strait. It can still help us understand how internal waves are generated in places around the world. Okay, so we want to talk about this mathematical model being specific to that Luzon Strait. We want to talk about how the model is specific to the Luzon Strait, which we do there. It can still help researchers understand how internal waves are generated in places around the world. So I'd be looking right around 65 to 70. As long as I have, I'm going to see what I got as my options real quick. So I'm looking for 65 to 70. I see we don't include 65, but we do have 67 to 70. So right there then for 49, that includes enough of what we need. Okay, 61 to 64 didn't have anything. The other ones aren't either. It's really going to be that 67 to 70 because that talks about that model being specific to the Luzon Strait, which is it because of that distinct topography. Okay, so our answer would be B for 48 and then D for 49. That's the best pair there. So we got, let's see here. So now we've got question 50. So we can go ahead and move on to question 50. Okay, it's going to be about the graph. Isotherm displays an increase in depth below the surface during the period 1912. Which isotherm displays an increase in the depth below the surface during the period 1912 to 2024. So an increase in depth below the surface during 1912 and 2024. All right, we got 1912, we got 2024. Which one shows a decrease? I believe it said there are two with increases, so I'm going to assume it said decrease. I see that that is going to be from my dashed line, which I see is going to be that 13 degrees Celsius. So I'll quick double check it said decrease, and if it did, my answer is going to be 13. I see it does, oh, it says an increase, which isotherm displays an increase in depth below the surface during the period 1912 to 2024. Increase in depth below the surface. Okay, an increase in depth below the surface in this case is going to be that decreased slope or that downward slope. So our answer there would still be 13 degrees Celsius. So my answer for then for 50 is going to be D. Okay, now I got question 51. Which concept is supported by the passage and by the information in the graph? Okay, I see in my graph, I'm just going to quick take a look at it. I see there's time periods where I see a significant drop in the depth of these temperatures. So I have temperatures that are typically higher dropping down. So we're going to have then the movement of water basically going to a lower depth. Okay, so we have then what is normally warmer water. Okay, this is normally 13 degrees Celsius. Okay, we now only have it being 11 degrees Celsius. So then we have the movement of warmer water down below. Okay, so I'm looking for something that talks about that. So we have internal waves cause water varying salinity mix. No. Internal waves push denser water above layers less dense. We want to talk about temperature here. Internal waves push bands of cold water above bands of warmer water. Yes, that would be my correct answer. I'm sorry, no it's not. Okay, that says internal waves push bands of cold water above bands of warmer water. That's not what we're talking about. In this case, that would be a reversed relationship, I believe. We have internal waves are pushing bands of cold water. Let me take a look here. We have internal waves are pushing bands of this warmer water down to where it's normally cold. So that would be a reversed relationship. So answer C is incorrect. And now we've got answer choice D. Internal waves do not rise to break the ocean surface. Yes, okay, we see that we have nowhere do we break the ocean surface up here. Okay, this is the ocean surface, and this blue line going across, we never break that, so our answer then is going to have to be D. Okay, well, that's supported by the passage because the passage also says that it's internal waves as well. Now we got 52. How does the graph support the author's point that internal waves affect ocean water dynamics? How does the graph support author's point internal waves affect ocean water dynamics? Okay, this right here is where we're going to talk about that relationship between the two. Okay, we're going to talk about how there's warm water, cold water, and how they have that dip in that graph. So we have option choice A. Option choice A says it demonstrates that wave movement forces warmer water down to depths that are typically colder. Yes, I'll show you why that's correct. It is correct, and I'll go ahead and quick show you that in the graph as well. Okay, we have the movement of warmer water, right, 13 degrees Celsius. I'm going to put it in green so you can see it better. We have the movement of this warmer water, this 13 degrees Celsius, down to where normally, and I'll put it in blue, normally we have this 11 degrees Celsius, or this colder water. So the movement of warmer water down to the depths where typically colder water is, which is what answer choice A says, warmer water down to the depths that are typically colder. Okay, so that's... All right, let's get started with passage 3. So questions 21 through 30 are based on the following passage. This passage is adopted from Thor Hansen. It's titled Feathers, copyright 2011 by Thor Hansen. Scientists have long debated how the ancestors of birds evolved the ability to fly. The ground-up theory assumes they were fleet-footed ground dwellers that captured prey by leaping and flapping their upper limbs. The tree-down theory assumes they were tree climbers that leapt and glided among branches. At field sites around the world, Ken Dial saw a pattern in how young pheasants, quail, tinamous, and other ground birds ran along their parents. They jumped up like popcorn, he said, describing how they would flap their half-formed wings and take short hops into the air. So when a group of graduate students challenged him to come up with new data on the age-old ground-up, tree-down debate, he designed a project to see what clues might lie in how baby game birds learn to fly. Ken settled on the chukar partridge as a model species, but he might not have made his discovery without a key piece of advice from the local rancher in Montana who was supplying him with birds. When the cowboy stopped by to see how things were going, Ken showed him his nice, tidy laboratory setup and explained how the birds' first hops and flights would be measured. The rancher was incredulous. He took one look and said, in pretty colorful language, "What are those birds doing on the ground? They hate to be on the ground. Give them something to climb on." At first it seemed unnatural. Ground birds don't like the ground, but as he thought about it, Ken realized that all the species he'd watched in the wild preferred to rest on ledges, low branches, or other elevated perches where they were safe from predators. They really only use the ground for feeding and traveling, so he brought in some hay bales from the chukars to perch on, and then left his son in charge of feeding and data collection while he went away on a short work trip. Barely a teenager at the time, young Terry Dial was visibly upset when his father got back. I asked him how it went, Ken recalled, and he said, "Terrible, the birds are cheating. Instead of flying up to their perches, the baby chukars were using their legs. Time and time again, Terry had watched them run right up to the side of the hay bale, flapping all the while. Ken dashed out to see for himself, and that was the aha moment. The birds were using their wings and legs cooperatively. He told me, and that this single observation opened up a world of possibilities." Working together with Terry, who has since gone on to study animal locomotion, Ken came up with a series of ingenious experiments, filming the birds as they raced up textured ramps tilted at increasing angles. As the incline increased, the partridges began to flap, but they angled their wings differently from birds in flight. They aimed their flapping down and backward, using the force not for lift, but to keep their feet firmly pressed against the ramp. It's like the spoiler on the back of a race car, he explained, which is a very apt analogy. In Formula One racing, spoilers are big aerodynamic fins that push the cars downward as they speed along, increasing traction and handling. The birds were doing the very same thing with their wings to help them scramble up otherwise impossible slopes. Ken called the technique war for wing-assisted incline running, and went on to document it in a wide range of species. It not only allowed young birds to climb vertical surfaces within the first few weeks of life, but also gave adults an energy-efficient alternative to flying. In the chukar experiments, adults regularly used war to ascend ramps steeper than 90 degrees, essentially running up the wall and onto the ceiling. In an evolutionary context, war takes on surprising explanatory powers. With one fell swoop, the Dials came up with a viable origin for the flapping flight stroke of birds, something gliding animals don't do and thus a shortcoming of the tree-down theory and an aerodynamic function for half-formed wings, one of the main drawbacks to the ground-up hypothesis. Alright, so now let's get into the questions. We got which choice best reflects the overall structure or the overall sequence of events in the passage. Alright, well, we want to come up with our own answer choice first, so let's go ahead and take a look at the passage and see what kind of occurs in sequence here. So we start out with this challenge to formulate this, to gather this new data on the Earth versus, on this ground versus tree theory, basically, right? The tree down theory versus the ground up hypothesis. That leads him to formulate his own experiment using these birds. That experiment then he decides to adapt based on information from the rancher, after he only gets into very, very early stages of it. And that causes him to create these new experiments in which he takes the results from that experiment and applies it to that evolutionary theory. Okay, so we're going to look for an answer choice that has that. So we have A, an experiment is proposed but proves unworkable. It never proved unworkable, so A is incorrect. B, a new discovery leads to reconsideration of a theory, that's not what we start with, so that's not the sequence of events. That's what we kind of end with. C, an anomaly is observed and it's simulated experimentally. There's no anomaly observed. Also, the results aren't really compared with previous findings, and the hypothesis isn't novel. Okay, so we can get rid of C for sure. D, an unexpected finding arises during the early phases of a study. Yes, that unexpected finding is that they prefer to stay on those ledges, right, and that they aren't hopping on them. They're kind of pushing down with their wings to move, kind of like climbing on the side of a wall and then onto the ceiling, it says. And then we have the studies modified in response to that finding, which it is. We now transition to them climbing up steep angles, and then those results are interpreted and evaluated for that evolutionary perspective. So D is our answer for 21. 22, as used in line 7, challenge most nearly means. Well, we can go ahead and go to line 7 and come up with our own answer choice for what challenge must most nearly mean. That way we're not swayed by the answer choices or stuck between two. All right, so when a group of graduate students challenged him to come up with new data on the age-old ground-up tree-down debate, he designed a project to see what clues might lie in how baby game birds learn to fly. Okay, in this case, these graduate students are challenging him or daring him, right? So they dared him to come up with a new data on this age-old ground-up tree-down debate. Okay, so they're not just asking him to, but they're really challenging him or daring him to. Like, hey, this is an interesting debate. Can you come up with something on this? We really dare you to, because we think that'd be cool. They're challenging him and they're daring him to do that. So let's see if dared is an answer choice. And it is. Okay, they're not requiring him to do it. They aren't saying you have to. They're simply challenging or daring him to. They're not disputing with him. And they're also not competing with him. They're not running a simultaneous experiment to go against his. So neither B, C, or D would be correct there. Which statement best captured Ken Dial's central assumption in setting up his research? Well, that central assumption, we know that that's the acquisition of flight in young birds, shedding light on the acquisition of flight in their evolutionary ancestors, right? And if we wanted to go back, I can go ahead and show you how I know that that's my answer, right? That's going to be right here, okay? When we talk about him being challenged to come up with new data for this ground up versus tree down debate, that age-old question, he designs his project, right? That initial assumption that he's making that his experiment lies on is that there's going to be clues in how baby game birds learn to fly that will apply to this age-old question. Okay, so if there's an evidence question after that, that'd be 6 to 11. And there is an evidence question after that, so that's going to be B, 6 through 11. Right, that's not talking about any tendency of certain young birds to jump erratically. Okay, we never talk about that. C, young birds in a controlled research setting are less likely than birds in the wild. We don't compare them to those in the wild versus those in a research setting. D, ground dwelling and tree climbing predecessors to birds evolved in parallel. We don't make that assumption either, or at least that assumption isn't driving our research. All right, 25, in the second paragraph, lines 12 to 32, the incident involving the local rancher mainly serves to what? Well, we know that when we talk about that local rancher, what that does is that changes what our experiment's going to end up being, right? Because now we place these hay bales in there, and that really changes our experimental setup and ultimately what our results are and how we apply that to that evolutionary theory, right? So if we go and we take a look at those lines, which we'll go ahead and do real quick, we see that we talk about how it causes us to now put things that they can climb on, right? Give them something to climb on. We put in those hay bales, and then we start taking data with this new experimental design. All right, so now let's just go ahead and run it back down here to 25. So as far as which answer choice is going to be correct, let's look at our options. We have A, reveal Ken Dial's motivation for undertaking his project. No, we're not revealing his motivation. Underscore certain differences between field research and laboratory research. We're not doing that either because we don't discuss the difference between the two. C, show how an unanticipated piece of information influenced Ken Dial's research. Yes, right? We're talking about how this rancher's perspective is influencing his research because it caused him to remember how in the wild they like to be on branches and such. Okay, it's not introducing any key contributor to the tree down theory either. So C is our answer for 25. 26, after Ken Dial had his aha moment, what did he do? Well, let's go figure out what he did after that aha moment. Okay, it said it was line 41. We see we have his aha moment. The birds were using their wings and legs cooperatively, and this opened up a world of possibilities. After that, he came up with ingenious experiments where he filmed them racing up textured ramps at increasing angles. Okay, so we're looking at increasing angles and textured ramps as our follow-up experiment to that aha moment. So we have A, tried to train birds to fly to their perches. He doesn't try to train them. B, studied videos to determine why the birds no longer hop. That's not the videos that he studied. He studied them going up steeper inclines. C, observed how birds dealt with gradually steeper inclines. Yes, that's what our evidence said, and that's what the passage says. We're not consulting other researchers who studied those same species either, so D is incorrect there. All right, 27. The passage identifies which of the following is a factor that facilitated their traction on steep ramps. That's going to be that downward force that he compared to the spoiler of a car, okay? And how did they get that downward force? Well, not the speed with which they climb. They got it by the position of their flapping wings, okay? So that position of their flapping wings created that downward force that gave them that traction. All right, it's not the alternation of wing and foot movement because we know that was cooperative, and their continual hopping motions is also incorrect because we know it was the flapping motion of their wings. All right, now we got question 28 in line 61. Document most nearly means what? Well, let's go to line 61 and let's come up with our own answer choice first. All right, so we got line 61, document. Ken called the technique war for wing-assisted incline running and went on to document it. So document it in a wide range of species. Okay, in this case, document would mean something like record, or observe would be the two best there. Because he's documenting it in a wide range of species, he's observing it in a wide range of species, or he's recording it in a wide range of species. So observe or record is really what I'm looking for there. We see in line 61, document most nearly means we don't have observe, but we do have record. So record there will be our answer. Okay, we're not portraying anything, we're not publishing anything, or processing anything. We're really just recording or documenting that difference. All right, question 29. What can be reasonably inferred about gliding animals from the passage? Well, we know we talk about gliding animals at the end, and we say that they don't use this flight flapping stroke. Okay, we have with one fell swoop, the dials came up with a viable origin for the flight flapping stroke of birds, something gliding animals don't do, and thus a shortcoming. My screen isn't working. I can't tell if it's doing that on yours as well, but we see that we have here a viable origin for the flight stroke of birds, something gliding animals don't do. So gliding animals don't use that flight flapping stroke. Okay, so that's going to be what they don't do. All right, and that's an inference we can make because it says it, right? It has evidence to support it. I can't tell if my screen's messing up right now. I don't know if it's doing that on yours as well. If it is, I'm sorry about that. Let's look at our answer choices. We have A, their young tend to hop along beside them. That's not what it's saying. B, their method of locomotion is similar to that. Ground birds, it's saying it's not similar. C, they use the ground for feeding more than perching. We're not making that inference. But D, we have they do not use a flapping stroke to aid in climbing slopes. Yes, that's supported by the text that they don't use that flapping stroke. And that was in lines 72 to 74. Okay, we could go back up and I can show you that was lines 72 to 74 because I just talked about it. Okay, right here. We got 72. Something gliding animals don't do down to 74 right here. So 72 to 74. All right, so that's going to be 72 to 74, which is answer choice D. All right, now let's go ahead and move on to passage. All right, let's get started with the fifth passage. So questions 42 to 52 are based on the following passage and supplementary material. This passage is adopted from Richard J. Sharp and Liza Hayden. Honey bee colony collapse disorder is possibly caused by a dietary pyrethrum deficiency. Copyright 2009 by Elsevier Ltd. Colony collapse disorder is characterized by the disappearance of adult worker bees from hives. Honeybees are hosts to the pathogenic large ectoparasite mite Varroa destructor, Varromites. These mites feed on bee hemolymph, blood, and can kill bees directly or by increasing their susceptibility to secondary infection with fungi, bacteria, or viruses. Little is known about the natural defenses that keep the mite infections under control. Pyrethriums are a group of flowering plants which include Chrysanthemum coccineum, Chrysanthemum cineritifolium, Chrysanthemum marshalli, and related species. These plants produce potent insecticides with anti-mite activity. The naturally occurring insecticides are known as pyrethriums. A synonym for the naturally occurring pyrethriums is pyrethin, and synthetic analogous of pyrethriums are known as pyrethoids. In fact, the human mite infestation is known as scabies. It is treated with a topical pyrethrium cream. We suspect that the bees of commercial bee colonies which are fed monocrops are nutritionally deficient. In particular, we postulate that the problem is a diet deficient in anti-mite toxins, pyrethriums, and possibly other nutrients which are inherent in such plants. Without at least intermittent feeding on the pyrethrum-producing plants, bee colonies are susceptible to mite infestations which can become fatal either directly or due to a secondary infection of immunocompromised or nutritionally deficient bees. This secondary infection can be viral, bacterial, or fungal and may be due to one or more pathogens. In addition, immunocompromised or nutritionally deficient bees may be further weakened when commercially produced insecticides are introduced into their hives by beekeepers in an effort to fight mite infestation. We further postulate that the proper dosage necessary to prevent mite infestation may be better left to the bees who may seek out or avoid pyrethrum-containing plants depending on the amount necessary to defend against mites and the amount already consumed by the bees, which in higher doses could be potentially toxic to them. This hypothesis can be tested by a trial wherein a small number of commercial honey bee colonies are offered a number of pyrethrum-producing plants as well as a typical bee food source such as clover, which controls are offered only the clover. Mites could be then introduced to each hive with note made as to the choice of the bees and the effects of the mite parasites on the experimental colonies versus control colonies. It might be beneficial to test wild-type honeybee colonies in this manner as well, in case there should be any genetic difference between them that affects the bee's preferences for pyrethrum-producing flowers. Okay, and then we have a table of pathogen occurrence in honeybee colonies with and without colony collapse disorder. All right, now let's get into our questions. So we got 42. How do the words can, may, and could in the third paragraph, lines 19 through 41, help establish the tone of the paragraph? All right, well, what they're really doing in that paragraph, if we go there, the words were can, may, I think the other one was could, but we see which can become fatal either directly or due to a secondary infection. We suspect that the bees of commercial bee colonies, which are fed monocrops, are nutritionally deficient. We're postulating. We had can, we had may. Really, the use of the words such as postulate, can, may, might, things like that, all of those are really serving to show that they aren't sure yet, right? They think and they have their hypothesis, but they're not totally sure. These words like could, may, can, they're showing that they're not totally sure, and they're establishing that tone that they don't know for sure, but they suspect that their claims are correct. So we have option A, they create an optimistic tone that makes clear the authors are hopeful about the effects of their research on colony collapse disorder. No, it's not creating a tone of optimism, and it's not making it clear that the authors are hopeful about the effects of their research. Okay, what about B? They're creating a dubious tone? No, they're not creating a dubious tone, and it doesn't make clear that the authors don't have confidence in the usefulness of the research described. Them postulating and suspecting and being fairly confident in their hypothesis, that's not showing that they don't have confidence in their usefulness. That's showing that they do have confidence in it. C, they create a tentative tone. Yes, it is creating a tentative tone that makes clear the authors suspect but do not know that their hypothesis is correct. Yes, they're postulating and they're suspecting that they're correct with their hypothesis, but the words such as can, may, and could are showing that they don't know for sure whether or not it's correct. Yes, so C is our best answer for 42. D, they create a critical tone that makes clear the authors are skeptical of claims that pyrethriums are inherent in monocrops. That is not really our main focus. We're not really focused on the inherent pyrethriums in monocrops. It's also not creating a critical tone, so that's why D is incorrect as well. All right, 43. In line 42, authors state that a certain hypothesis can be tested by a trial. Based on the passage, which of the following is a hypothesis the authors suggest be tested in a trial? Well, really what they're talking about in line 42 when they say it can be tested by a trial is the trial being those pyrethriums, right, and whether those pyrethriums can help fight off those mite infections, right? So it's about whether pyrethrium-producing plants are able to help fight off those mites. So let's see if we have an option that really touches on that. So let's go ahead and roll through our options A through D. So we've got A, honeybees that are exposed to both pyrethriums and mites are likely to develop a secondary infection. That's not what they want to test in the trial. They're not suggesting they test whether or not they're more likely to develop secondary infections. So A is wrong. B, beekeepers who feed their bee colonies a diet of single crop need to increase the use of insecticides. Okay, us saying that they need to increase the use of insecticides to prevent mite infestations, that's not something that can be tested. That's just us making a claim. So B is definitely wrong. C, a honeybee diet that includes pyrethriums results in honeybee colonies that are more resistant to mite infestations. Yes, that can be tested. That's something that that's a claim that we say should be tested, right? Whereas with B, we never make the claim that a diet of single crop needs to increase their use of insecticides to prevent mite infestations. We don't suggest that. In fact, we suggest that insecticides can actually be harming bees further. Okay, so that would be wrong for sure. C, a honeybee diet that includes pyrethriums result in honeybee colonies that are more resistant to mite infestations. Yes, we say that towards the beginning. We talk about how pyrethriums can reduce those mite infestations. All right, so that's going to be our answer there, and we do suggest we test that in a trial as well. D, humans are more susceptible to voromites. We don't really touch on humans in this section, so D is definitely incorrect as well. So now we're asked for evidence. So that's, like I said, going to be more towards the beginning, where we talk about how they need to be at least have intermittent feeding on these pyrethrum-producing plants, because bee colonies are more susceptible to mite infestations if they're not feeding on those plants, and those can become fatal directly or indirectly through immunocompromisation or nutritionally deficient bees, right? So that's lines 24 to 28, where we're really talking about how that intermittent feeding on pyrethrum-producing plants can help prevent those mite infestations or help combat them. So that's going to be lines 24 to 28 if we have that as an answer choice, and we see that we do. So that's going to be answer choice D for 44. All right, so let's move on to question 45. So we've got 45 is asking us, the passage most strongly suggests that beekeepers' attempts to fight mite infestations with commercially produced insecticides may have what unintentional effect? Well, that's going to be further harming the health of some bees. So how did I know that? Well, I remember if I go back up to where I talked about right here, 31, line 31. In addition, immunocompromised or nutritionally deficient bees may be further weakened when commercially produced insecticides are introduced into their hives by beekeepers in an effort to fight mite infestation. Okay, so we see that some bees are going to be further weakened and more likely to die as a result of these insecticides. Okay, so that's 31 to 35, and that's showing that it's going to further harm the health of some bees. Any nutritionally deficient or immunocompromised bees, they're going to be further harmed by the use of those insecticides. So that's what we know our answer there is going to be. As far as evidence, like I just said, I believe it was lines 31 through 35. I see it was. That's going to be my evidence there. So that'll be answer choice C. I'll go ahead and cover why for 45, A, B, and C are wrong as well. Them saying that insecticides increase certain mite populations, they don't. They actually decrease mite populations. They just kill bees as well, which is why we don't want to use them. B, they kill some beneficial forms of bacteria. We never make that claim. C, they destroy the bee's primary food source. We never make that claim either. All right, now we got 47. As used in line 35, postulate most nearly means. Well, we're going to go through, go to line 35 and come up with our own answer choice first for what postulate would mean. All right, so we further postulate that the proper dosage necessary to prevent mite infestation may be better left to bees. Okay, so that's really them hypothesizing or speculating or putting forth an idea or claim, right? They're claiming something, speculating it, hypothesizing it. Those would all be good answer choices there. So let's see if we have any of those. We have make an unfounded assumption. No, because it is founded. B, put forth an idea or claim. Yes, that's a great answer choice, and that is the correct answer choice. C, questioning a belief. No. And D, concluding based on firm evidence. They don't have that evidence yet, and they can't also conclude it. Postulating means we haven't concluded yet. We're more hypothesizing, so we're not at the conclusion stage yet for that. So that's why D is wrong and B is correct. 48, the main purpose of the fourth paragraph, lines 42 to 50 is to what? Well, let's go take a look. 42 to 50, we see we're really describing what our experiment's going to be. So we're giving the experimental design. We talk about our control being clover. We talk about how our non-control is going to be our pyrethrum-producing plants and them eating that. We talk about the bees making a choice and measuring the effect of that. So really our experimental design is what that's going to be talking about. So that right there is 48. And we see that 48, the only one that talks about proposing an experiment is answer choice B, proposing an experiment to investigate how different diets, clover versus pyrethrum, affect commercial bee colonies susceptible to mite infestations. Right there, B is going to be our correct answer for the main purpose of that fourth paragraph. All right, question 49, an unstated assumption made by the authors about clover plants is what? Well, that's going to be A, that they don't produce pyrethrum. So how did I know that so fast? Well, we know that we're using clovers as a control, so I'll go ahead and show you up here. We talk about how we are going to have them be offered a number of pyrethrum producing plants, and then we talk about how we want to give them a control, which is a typical bee food source. Well, if we're going to do a control to compare those with pyrethrum, that control cannot contain pyrethrum. So those clover plants cannot have pyrethrum in them. So they, A, do not produce pyrethrum. All right, 50, based on the data in the table and what percent of colonies with colony collapse disorder. Okay, based on the data in the table and what percent of colonies with colony collapse disorder were the honeybees infected by all four pathogens. Okay, so we're going to go to our table, find the one with colonies with colony collapse disorder, and find what percent have all four pathogens. We see that's right here, so that'll be 77%. So I go down here, find 77%. I see that's going to be answer choice B for 50. So 50 will be B. All right, moving on, we got question 51. Based on the data in the table, which of the four pathogens infected the highest percent of honeybee colonies without colony collapse disorder? Okay, so we're going to go to our column that says colonies without colony collapse disorder. That's our right column here. And we were asked for the one that infects the most, or the highest percentage. That's 81. That's Nosema ceranae. So Nosema ceranae will be my answer there. So that's answer choice D. So D for 51. Now we got 52. Does the data in the table provide support for the author's claim that infection with veromites increases a honeybee's susceptibility to secondary infections? Our table never says if they have veromites or do not, so we cannot make any claim on that. So we can get rid of A and B because they say yes. C, we have C, no, because the data does not provide evidence about bacteria as a cause. No. We can't make a claim because the data doesn't indicate whether or not the honeybees have been infected with mites. They could be infected, they could not be. We don't know, the data doesn't tell us, therefore we can't make a claim about that. So D is our answer there. So as always, thanks. Questions 22 to 31 are based on the following passage. This passage is adopted from Emily Anthas. Frankenstein's Cat is the title. Copyright 2013 by Emily Anthas. When scientists first learned how to edit the genomes of animals, they began to imagine all the ways they could use this new power. Creating brightly colored novelty was not a priority. Instead, most researchers envisioned far more consequential applications, hoping to create genetically engineered animals that saved human lives. Warner Bros. Is now delivering on this dream. Welcome to the world of farming, in which simple genetic tweaks turn animals into living pharmaceutical factories. Many of the proteins that our cells crank out naturally make for good medicine. Our body's own enzymes, hormones, clotting factors, and antibodies are commonly used to treat cancer, diabetes, autoimmune disease, and more. The trouble is that it's difficult and expensive to make these compounds on an industrial scale, and as a result, patients can face shortages of the medicines that they need. Dairy animals, on the other hand, are expert protein producers, their udders swollen with milk, so the creation of the first transgenic animals, first mice, then other species, in the 1980s gave scientists an idea. What if they put the gene for a human antibody or enzyme into a cow, goat, or sheep? If they put the gene in just the right place, under the control of the right molecular switch, maybe they could engineer animals that produced healing human proteins in the milk. Then doctors could collect medicine by the bucketful. Throughout the 1980s and 90s, studies provided proof of this principle, as scientists created transgenic mice, sheep, goats, pigs, cattle, and rabbits that did in fact make therapeutic compounds in their milk. At first, this work was merely gee whiz, scientific laboratory lab-bound thought experiments come true. That all changed with Atrin, a drug produced by the Massachusetts firm GTC Biotherapeutics. Atrin is antithrombin, an anticoagulant that can be used to prevent life-threatening blood clots. The compound made by our liver cells plays a key role in keeping our bodies clot-free. It acts as a molecular bouncer, sliding up to clot-forming compounds and escorting them out of the bloodstream. But as many as one in 2,000 Americans are born with a genetic mutation that prevents them from making antithrombin. These patients are prone to clots, especially in their lungs and legs, and they are at elevated risk of suffering from fatal complications during surgery and childbirth. Supplemental antithrombin can reduce this risk, and GTC decided to try to manufacture this compound using genetically engineered goats. To create its special herd of goats, GTC used microinjection, the same technique that produced glowfish and aqua advantage salmon. The company's scientists took the gene from human antithrombin and injected it directly into fertilized goat eggs. Then they implanted the eggs in the wombs of female goats. When the kids were born, some of them proved to be transgenic. The human gene nestled safely in their cells. The researchers paired the antithrombin gene with a promoter, which is a sequence of DNA that controls gene activity. That is normally active in the goat's mammary glands during milk production. When the transgenic females lactated, the promoter turned the transgene on, and the goat's udders filled with milk containing antithrombin. All that was left to do was collect the milk and extract and purify the protein, and voila, human medicine. And for GTC, liquid gold. Atrin hit the market in 2006, becoming the world's first transgenic animal drug. Over the course of the year, the milking parlors on GTC's 300-acre farm in Massachusetts can collect more than a kilogram of medicine from a single animal. All right, so now let's go ahead and get into our questions. Okay, so we've got question 22, the primary purpose of the passage. All right, well, if we think about this passage as a whole, what we really do is we're talking about the whole development of this phenomenon, right? So we provide background really throughout most of this passage. We're providing the background, and then at the end, what we're doing is we're getting into that medical breakthrough. So our correct answer there would be A. We present the medical background, talking about things in the 1980s and 90s, and then eventually we get to that breakthrough in that GTC company's drug that is preventing those blood clots. So our answer there would be A for the primary purpose. Now the author's attitude towards farming is best described as one of what? Well, the author is obviously he does appreciate what farming has brought. He describes farming as something that is obviously good. Now he's not ambivalent for it because he thinks that it's a very, very good thing. He's also not apprehensive towards it. Okay, he's not someone who is saying that it's a bad thing or something that needs caution. He's also not someone who's saying, so that's why it's not apprehension. He's also not someone who's saying that it's good or bad, or he's not neutral on it, right? He's someone who's saying, hey, this is a good thing, right? He's not neutral. He is saying that it is good. He's saying that he appreciates it. He's saying it's a good development in technology and in medicine, but he is not astonished, right? He talks about how this is something that's been going on for 30 years, so he's not astonished by it, but he's definitely appreciative of it as an advancement in technology. All right, 24. As used in line 20, expert most nearly means what? Well, let's go take a look at line 20 and see what we think expert would mean, because we want to understand that that's a words in context question. So we have dairy animals, on the other hand, are expert protein producers. Well, a good word there would be excellent protein producers. Let's see if we have anything like that. It has to show something that they are able to produce proteins. Knowledgeable doesn't show they're able to produce proteins. Professional doesn't show they're able to produce proteins. Capable, that does show that they are able to produce those proteins. Not trained either. So our answer for 24 there would be C. All right, 25. What does the author suggest about the transgenic studies done in the 1980s and the 1990s? Okay, well, let's just run through our answers here because this one's going to be a little bit tough. We know in the 1980s and 90s, I do see I have evidence for my next line. So actually, instead of running through the answers, I'm going to go take a look at the text because I'm going to need evidence anyways. So I want to know what this author is really saying about these studies that are about these transgenic studies in the 1980s and 90s. So let's go take a look at what he's saying about them. Okay, so I'm going to look at my highlighted portions first. I see that I have 1980s and 90s in my middle left of my screen. So if I go down to my highlighted portion on that paragraph, I see the compound plays a key role in keeping our bodies clot-free. Okay, that's not really talking about the research in the 1990s at that point, though. That's talking about atrin. So I want to go back up, and I want to read more about this 1980s and 90s I read here. So I have studies provided proof of principle as scientists created transgenic mice, sheep, goats, pigs, cattle, and rabbits that did in fact make therapeutic compounds in their milk. At first, this was merely gee whiz, scientific geekery, lab-bound, thought experiment come true. Okay, so that's telling me that it's not really applicable to humans at that point, so it was really just in the lab. Okay, so my answer there would be B then. They were not expected to yield products ready for human use. It was really just lab and geekery, things dealing with chemistry, dealing in the lab, but not ready for human use at that point in time. So answer for 25 there would have to be B. All right, now we got 26. It says, which provides the best evidence? Okay, I want to find the spot that talks about scientific geekery like I just talked about. So I see that that's 35 down to 36. So let's see if we have evidence as that. 35 to 36. I see I do, so my answer for 26 then would be C. All right, now we got question 27. Let's take a look at question 27. According to the passage, which of the following is true of antithrombin? Antithrombin. Okay, well, I know that that's the same as that atrin, right? And I know that I talk about how atrin is able to reduce those blood clots, so it's able to help promote blood flow by stopping those blood clots. So let's take a look at what our options are for 27 there. So we have option A, it reduces compounds that lead to blood clots. Yes, right? It's stopping those blood clots. Option B, it stems from a genetic mutation. No. Option C, it's a sequence of DNA known as a promoter. Also incorrect. C or D, it occurs naturally in goats' mammary glands. Also incorrect. So our answer for 27 is going to be A. 28, which choice provides the best evidence that it can stop those blood clots? Okay, that's going to be in the bottom left of this paragraph here where we start talking about how it acts as a molecular bouncer. I'll go ahead and circle this in green so you can see it better. It's the bottom left of your screen. It says it acts as a molecular bouncer, sliding up to clot-forming compounds and escorting them out of the bloodstream. So it would end right there. So that's talking about how it's getting rid of those compounds that cause blood clots and getting them out of the bloodstream. So that would be from 42 to 44 would be my best answer there. 42 to 44. So let's find our answer for that one. We see that that's going to be answer choice B for number 28. All right, so now we got question 29. Which of the following does the author suggest about the female goats mentioned in line 59? Well, let's go to line 59 and see what he's suggesting about these female goats. So we have in line 59, we see that we have then they, which are these female goats, implanted that, or then they, not the female goats. They is referring to these researchers, these scientists. Okay, they implanted the eggs in the wombs of female goats. Okay, now what? What happens to these? We have the kids are born. Some of them prove to be transgenic. Okay, the human gene nestled safely in their cells. Okay, that means that these goats then, their offspring of these female goats, so their children, have human DNA, so they do not carry the DNA of that goat. Okay, so let's go down and find an answer choice that says that. We have option A, they secreted antithrombin in their milk after giving birth. That is not correct. We have option B, some of their kids were not born with the antithrombin gene. Yes, right, they were not born with that antithrombin gene, right, because they were transgenic. So our answer there would be B. They were transgenic, therefore they did not have that antithrombin gene. So we have B for number 29. Now we can take a look at option 30. So 30 says the most likely purpose of the parenthetical information in lines 63 to 64 is to do what? Let's take a look. So we have 63 to 64. We have which is a sequence of DNA that controls gene activity. Okay, I see that that's describing my promoter, so it's defining what a promoter is. It's a sequence of DNA that controls gene activity. So since we are defining a promoter there, we are defining a term. So our answer there would be D. So D would be our answer for 30. All right, 31. Let's take a look at that. So we have the phrase liquid gold in line 71. It most directly suggests what? Well, let's go to line 71. Let's take a look at what liquid gold is referring to. Okay, we have we've got, and voila, human medicine, and for GTC, which is that company that produces Atrin, liquid gold. So it's saying that milk containing antithrombin, that I'm circling in green up top, that is the liquid gold. Okay, so that's the liquid gold. So that Atrin is the liquid, or that milk containing Atrin is that liquid gold. So let's go down. We see we have option A, GTC has invested a great deal of money in the technique. No. B, GTC's milking parlors have significantly increased milk production. No. C, transgenic goats will soon be a valuable asset. No. D, Atrin has proven to be a financially beneficial product for GTC. Yes, right? It's a gold mine for them, or liquid gold. So our answer there for 31 would be D. Questions 42 to 52 are based on the following passage in supplementary material. This passage is adopted from Caroline Gramlin, source of mysterious medieval eruption identified, copyright 2013 by the American Association for the Advancement of Science. About 750 years ago, a powerful volcano erupted somewhere on Earth, kicking off a centuries-long cold snap known as the Little Ice Age. Identifying the volcano responsible has been tricky. That a powerful volcano erupted somewhere in the world sometime in the Middle Ages is written in the polar ice cores in the forms of layers of sulfate deposits and tiny shards of volcanic glass. These cores suggest that the amount of sulfur the mystery volcano sent into the stratosphere put it firmly among the ranks of the strongest climate-perturbing eruptions of the current geological epoch, the Holocene, a period that stretches from 10,000 years ago to the present. A haze of stratospheric sulfur cools the climate by reflecting solar energy back into space. In 2012, a team of scientists led by geochemist Gifford Miller strengthened the link between the mystery eruption and the onset of the Little Ice Age by using radiocarbon dating of dead plant material from beneath ice caps on Baffin Island, Iceland, as well as ice and sediment core data to determine that the cold summers and ice growth began abruptly between 1275 and 1300 CE and became intensified between 1430 and 1445 CE. Such a sudden onset pointed to a huge volcanic eruption, injecting sulfur into the stratosphere and starting the cooling. Subsequent unusually large and frequent eruptions of other volcanoes, as well as sea ice, ocean feedbacks, persisting long after the aerosols have been removed from the atmosphere, may have prolonged the cooling through the 1700s. Volcanologist Frank Levine and colleagues now think they've identified the volcano in question, Indonesia's Samalas. One line of evidence they note is historical records. According to the Babad Lombok, records of the island written on palm leaves and old Javanese Samalas erupted catastrophically before the end of the 13th century, devastating surrounding villages, including Lombok's capital at the time, Pamatan, with ash and fast-moving sweeps of hot rock and glass called pyroclastic flows. The researchers then began to reconstruct the formation of the large 800-meter deep caldera, a basin-shaped volcanic crater that now sits atop a volcano. They examined 130 outcrops on the flanks of the volcano, exposing sequences of pumice ash hardened into rock and other pyroclastic material. The volume of the ash deposited and the estimated height of the eruption plume, 43 kilometers above sea level, put the eruption's magnitude at a minimum of 7 on the volcanic explosivity index, which has a scale of 1 to 8, making it one of the largest known in the Holocene. The team also performed radiocarbon analysis on the carbonized tree trunks and branches buried within the pyroclastic deposits to confirm the date of the eruption. It could not, they concluded, have happened before 1257 and certainly happened in the 13th century. It's not a total surprise that an Indonesian volcano might be the source of the eruption, Miller says. An equatorial eruption is more consistent with the apparent climate impacts, and he adds, with sulfate appearing in both polar ice caps, Arctic and Antarctic, there is strong consensus that this also supports an equatorial source. Another possible candidate, both in terms of timing and geographic location, is Ecuador's Quilotila, estimated to have last erupted between 1147 and 1320 CE. But when Levine's team examined shards of volcanic glass from this volcano, they found that they didn't match the chemical composition of the glass found in polar ice cores, whereas Samala glass is a much closer match. That, they suggest, further strengthens the case that Samala was responsible for the medieval year without summer in 1258 CE. All right, at this point we can go ahead and get into our questions. So we've got a figure, which will probably be asked at the end because they almost always are. We have the main purpose of the passage is to do what? Okay, well, we know that we start out our passage by discussing this sort of little ice age, and then we get into the cause of that after. Okay, so the main purpose in this is really to describe the evidence that is linking the volcano Somalis to the little ice age, right? The little ice age is what we introduce, but then at the end we really start talking about the cause of it, which we know is the volcano Somalis, or at least that's what the evidence is pointing to. We aren't describing periods in Earth's recent geological history. That's not the whole point of this. We want to keep in mind we're looking for the main purpose. Explaining the methods scientists use in radiocarbon analysis, we aren't explaining those methods. Explaining how volcanic glass forms during volcanic eruptions, we do not do that either. So our answer is C for 42. All right, 43, over the course of the passage, the focus shifts from what? Well, as I said in part 1, we shift from describing this record event, right, this little ice age, to its likely cause. So our answer there would be B. Okay, we start by introducing this little ice age period, and then we get into its cause being those Somalis volcanoes. Okay, we're not starting with a criticism, so that's wrong. We're not starting with the use of ice core samples to a new method. We're not doing that. We're not starting with the use of radiocarbon dating either. We're starting with that description of the little ice age and then moving on to its cause. All right, now we got 44, so we have which choice is providing the best evidence for that previous answer. So we're going to look for where we start to make that transition from description of the little ice age to its cause. I believe that it's going to be right around here. Let me take a look. So we have in 2012, this is kind of where we started to make this transition. I'm going to put it in green. So in 2012, a team of scientists led by geochemist Gifford Miller strengthened the link between the mystery eruption. Okay, so we're linking the mystery eruption and the onset of the little ice age. So that's its cause, right? The mystery eruption is its cause, and our event is the little ice age. So our evidence then should be from, looks like 17 to right around wherever the sentence ends, which is in 24, but we might not end up going all the way there. So anything that's really got 17 to 19 for sure in it would be what I'm looking at for my evidence there. So I see I do go all the way to 25 because that's the end of my sentence. My answer there would be A for number 44. All right, now we got question 45. So we've got the author uses the phrase is written in line 6, most likely to do what? Well, let's go take a look at the word in written in line 6. So we have, I believe it was talking about the answers are written in, right? We have that a powerful volcano erupted somewhere in the world sometime in the Middle Ages is written in polar ice cores, okay, or is evident in polar ice cores is what I'm looking at there. It's showing that the evidence there is in those polar ice cores. So let's look for an answer that has that. So we have option C underscores the sense of importance that they have regarding their work. That's incorrect. D, reinforcing the idea that the evidence is there and can be interpreted by scientists. That will for sure be our answer, right? Us saying that the evidence is written in something is telling us that the evidence is both there and that it can be interpreted by scientists to come to a conclusion. So our answer there would have to be D. All right, now we got 45. We have, where does the author indicate the medieval volcanic eruption was probably located? Okay, we say this one pretty explicitly. We say that it's near the equator in Indonesia. I see my next question is evidence, so I can also go ahead and get the evidence for you on that one. Okay, we know that our evidence for where it says near the equator in Indonesia, we're just going to look for where it says that because it pretty much explicitly says that. We see that it's not a total surprise an Indonesian volcano might be the source of the eruption, and equatorial eruption is more consistent with the apparent climate impacts. So I see that that's going to be from 61 then to 64. Okay, so I'm going to find evidence, see if that's an option. Okay, I see that that is a choice, so my answer there would be D because that would be showing that it happened near the equator in Indonesia. That one right there is pretty explicit. All right, now we have, as used in line 68, the phrase another possible candidate implies what? Well, let's go take a look at line 68, find some context. So we have appearing in both polar ice caps, Arctic and Antarctic. There's a strong consensus that this also supports an equatorial source. Another possible candidate, both in terms of timing and geographic location, is Ecuador's Kilo Tias. This is another possible candidate for the cause of the little ice age. So it's really showing that there are, it's not for sure known which one caused it, what I would say we're really looking at here. So let's take a look through our options. We have A, powerful volcanic eruptions occur frequently. No, that's not really the main point. The main point is that we know that there's other options for what caused this. We have B, the effects of volcanic eruptions can last for centuries, also incorrect. C, scientists know of other volcanoes that erupted during the Middle Ages. Yes, those other volcanoes erupting during the Middle Ages, like we talk about as in that other possible candidate, is showing that there's some other volcano that could have caused this little ice age. So it's showing that there are others that erupted during those Middle Ages. Other volcanoes have calderas that are very large. No, that would be if you were to focus too narrow on the calderas part of this passage. All right, now we got which choice best supports the claim that Kiotia was not responsible for the ice age. Okay, the big thing that sticks out to me right here is the word closer match, so I'm going to start there in 71 to 75 because that's probably telling me that there's another volcano that is at a closer match, which I believe is what it says. We have, but when Levine's team examined shards of volcanic glass from this volcano, they found they didn't match the chemical composition of the glass found in polar ice cores, whereas the Somalis glass is a much closer match. I see that that's from, it looks like 71 down to 70. 5, it looks like right here. So down 71 to 75. Find an answer choice that has that. So we got 71 to 75. That's going to be D for 49. All right, so now at this point we've got question 50. According to the data in the figure, the greatest below average temperature variation occurred around what year? Well, let's go take a look for that greatest below average temperature variation. I see that occurs here. That's my greatest decrease, or the lowest point. That's going to be at 16, it looks like 16, just before 1700, so right around 1670-ish is what I'd be looking at as an answer choice there. I see that I got 1675, so my answer would be C for number 50. All right, at this point, we go and move on to number 51. 51 says, the passage and the figure are in agreement that the onset of the Little Ice Age began when? Okay, well, let's take a look at this figure. So we have the onset of the Little Ice Age. We see that that's going to really start right around here, right? If we go down, that's where we move from that medieval warm period into this Little Ice Age over here. So that's going to be right around just before 1400. It's right around 1350 to 1400 is what I'd be looking at there. So let's take a look. We've got option A around 1150, no, just before 1300. I mean, it looks like according to the figure that it would be a little bit closer to that 1350 mark, but also, you know, we see that we do start that decline just before 1300 as well. So starting that decline just before 1300, that also would work. So our answer there should be B, just before 1300. That's a better choice than just before 1500 and around 1650. So our answer would be B for 51. All right, now we got 52, which statement's best supported by the data in the figure. At this point, we just got to go through our statements, starting with A. So we have the greatest cooling during the Little Ice Age occurred hundreds of years after the temperature peaks of the medieval warm period. Well, let's take a look. We see that our peaks in the medieval warm period occur right around 1200. So we go from right around 1200 to our greatest trough, or our greatest decline, which is right around 1650. So that is hundreds of years after, so therefore my answer would have to be A for number 52, because that is a true statement that's supported by the data presented in the figure. So my answer would be A for 52. All right, let's get started with passage 3. This passage is adopted from Brian Walsh, and it's titled The Whole Food Blues, Why Organic Agriculture May Not Be Sustainable. Copyright 2012 by Time Inc. When it comes to energy, everyone loves efficiency. Cutting energy waste is one of those goals that both sides of the political divide can agree on, even if they sometimes diverge on how best to get there. Energy efficiency allows us to get more out of our given resources, which is good for the economy and mostly good for the environment as well. In an increasingly hot and crowded world, the only sustainable way to live is to get way more out of less. Every environmentalist would agree, but change the conversation to food and suddenly efficiency doesn't look so good. Conventional industrial agriculture has become incredibly efficient on a simple land-to-food basis. Thanks to fertilizers, mechanization, and irrigation, each American farmer feeds over 155 people worldwide. Conventional farming gets more and more crop per square foot of cultivated land. Over 170 bushels of corn per acre in Iowa, for example, which can mean less territory needs to be converted from wilderness to farmland. And since a third of the planet is already used for agriculture, destroying forests and other wild habitats along the way, anything that could help us produce more food on less land would seem to be good for the environment. Of course, that's not how most environmentalists regard their arugula, a leafy green. They have embraced organic food as better for the planet and healthier and tastier too than the stuff produced by our agricultural corporations. Environmentalists disdain the enormous amounts of energy needed and waste created by conventional farming, while organic practices foregoing artificial fertilizers and chemical pesticides are considered far more sustainable. Sales of organic food rose 7.7% in 2010, up to $26.7 billion, and people are making those purchases for their consciences as much as their taste buds. Yet a new meta-analysis in Nature does the math and comes to a hard conclusion. Organic farming yields 25% fewer crops on average than conventional agriculture. More land is therefore needed to produce fewer crops, and that means that organic farming may not be as good for the planet as we think. In the Nature analysis, scientists from McGill University in Montreal and the University of Minnesota performed an analysis of 66 studies comparing conventional and organic methods across 34 different crop species, from fruits to grains to legumes. They found that organic farming delivered a lower yield for every type of crop, though the disparity varied widely. For rainwatered legume crops like beans or perennial crops like fruit trees, organic trailed conventional agriculture by just 5%. Yet for major cereal crops like corn or wheat, as well as most vegetables, all of which provide the bulk of the world's calories, conventional agriculture outperformed organics by more than 25%. The main difference here is nitrogen, the chemical key to plant growth. Conventional agriculture makes use of 171 million metric tons of synthetic fertilizer each year, and all that nitrogen enables much faster plant growth than the slower release of nitrogen from the compost or cover crops used in organic farming. When we talk about a green revolution, we really mean a nitrogen revolution, along with a lot of water. But not all the nitrogen used in conventional fertilizer ends up in crops. Much of it ends up running off the soil and into the oceans, creating vast polluted dead zones. We're already putting more nitrogen into the soil than the planet can stand over the long term, and conventional agriculture also depends heavily on chemical pesticides, which can have unintended side effects. What this means is that while conventional agriculture is more efficient, sometimes much more efficient than organic farming, there are trade-offs with each. So an ideal global agricultural system, in views of the study's authors, may borrow from the best of both systems, as Jonathan Foley from the University of Minnesota explained. The bottom line, today organic farming practices are probably best deployed in fruit and vegetable farms where growing nutrition, not just bulk calories, is the primary goal, but for delivering sheer calories, especially in our staple crops of wheat, rice, maize, soybeans, and so on, conventional farms have the advantage right now. Looking forward, I think we will need to deploy different kinds of practices, especially new, mixed approaches that take the best of organic and conventional farming systems where they are best suited, geographically, economically, socially, etc. All right, and then we have a figure, and now we have our questions. All right, question 22, as used in line 14, simple most nearly means. Well, we're going to go to line 14, look at simple, and come up with our own answer first so we're not swayed by other answer choices. So we see we have the only sustainable way to live is to get more out of less. Every environmentalist would agree. Right here, conventional industrial agriculture has become incredibly efficient on a simple land to food basis. Right here, simple basically means straightforward, right? Just looking at land to food basis solely, right? Only that. So straightforward land to food basis is what I'm guessing our correct answer will be. And we see we do have straightforward, right? We're not going to say an easy land to food basis because that's not describing it. Unadorned, also not describing it. And modest, also not describing it. We're just looking straightforward land to food basis. So A will be our correct answer there. All right, 23. 23. According to the passage, a significant attribute of conventional agriculture is its ability to what? Well, in the passage, we really talk about how conventional agriculture is unique in its ability to maximize the output of the cultivated land, right? We really talk about how, I'm guessing our next question might be evidence. It is not, okay. But when we talk about how on land to food basis, right, that conventional agriculture wins by more than 25% in some cases, right? So just maximizing that output of that cultivated land, not producing a wide variety of fruits and vegetables, that has nothing to do with that. Satisfying dietary needs of the world's population, that is only partly true, right? That's not the significant attribute of conventional agriculture, because organic agriculture could also do that, but in this case, what we're really talking about with conventional agriculture is maximizing that cultivated land. So we can't say it is C because organic agriculture is also used for the dietary needs of the world's population. D, lessening the necessity of nitrogen in plant growth. We actually need more nitrogen in conventional agriculture. So we can get rid of D. All right, now we've got question 24. Which choice best reflects the perspective of environmentalists in line 27 on conventional agriculture? Well, let's go to line 27. Come up with our own answer first. We got line 27. Of course, that's not how most environmentalists regard their agurula, a leafy green. They have embraced organic food as better for the environment and healthier and tastier than the stuff produced by agricultural corporations. All right, so that's telling us that these environmentalists believe that conventional agriculture is producing inferior fruits and vegetables and is also detrimental to the environment. So our answer for 24 there is going to be A, right? They believe that it's producing inferior fruits and vegetables to the organics and it's also detrimental. And our support for that, we actually read it when we were up there. That was 28 to 31. And I'll go ahead and show you why that's going to be our support. If we go back up, we look in 28 to 31, they have embraced organic food as better for the planet, okay, and also healthier and tastier. So they're really saying that it's better for the planet, so inferring that the standard agriculture or the modern one that's not organic is causing environmental damage and is also worse tasting, right? So we've got our answer there. Now we got question 26. Which statement best expresses a relationship between organic farming and conventional farming that is presented in the passage? Well, we don't say that both are equally sustainable, so we can get rid of A. Now, as far as the other options, what we're looking at is B, both rely on artificial chemicals for pest control. No, organic does not rely on artificial chemicals. C, both use nitrogen for plant growth, but the nitrogen used in conventional farming comes from synthetic sources. That is accurate, right? That is an accurate relationship between organic farming and conventional farming that is stated in the passage. D, both create substantial amount of nitrogen runoff. We don't talk about nitrogen runoff, so we can get rid of D. 27, which choice provides the best evidence for the previous question? All right, so that one right there, that's going to be where we talk about the nitrogen use of each one, which if I remember correctly is towards the end. It's about middle to the end, right around, I believe, Let's see, right here, around line 60, we have the main differences is nitrogen, the chemical key to plant growth, and then we start talking about conventional agriculture making use of 171 million tons of synthetic fertilizer, so I'm looking at about 61 to right about 65 here as my answer for my evidence. We got that in answer choice D, so D will be our answer there. All right, question 28. According to Foley, an ideal global agriculture system, what? It's line 80. So let's go to line 80, see what he's arguing. Okay. An ideal global agricultural system may borrow the best from both systems. Okay, so we're going to borrow from each. Let's go ahead and look down and see our answer choices here. We've got focuses primarily on yield percentages in global markets. No, considers multiple factors in the selection of farming techniques. Yes. C, weighs the economic interests of farmers against the needs of consumers. No. Puts the nutritional value produce first. No. We're really considering the multiple factors is what he's arguing for. He's saying that the ideal global agricultural system will consider both using conventional farming as well as organic based on the needs of each plant. So that multiple factors in farming techniques. As well as we also say towards the end here, where it's best suited geographically, economically, and socially for that farming system. So multiple factors there. All right, now we've got question 28 or 29. In line 88, shear most nearly means what? All right, well, let's go back to line 88 then, and let's find what shear most nearly means. Line 88. All right, but for delivering sheer calories, especially in our staple crops of wheat, rice, maize, and so on, conventional farms have the advantage right now. Okay, so in this case, we're just really, this is once again kind of looking at straightforward, just basic calories, just delivering or large amounts of calories, sheer calories, only calories, and pure calories. That's it right there. That's perfect. Right, not steep calories, they're not abrupt, and they're not transparent. Transparent would mean see-through, can't see through them. Abrupt, you can't have an abrupt calorie, and you can't have a steep calorie either. You can have a pure calorie though, and that would just be talking about only calories. So right there, 29, our answer is going to be D, and we can move on to question 30 now. So which statement is best supported by the information in figure 1? Well, let's go to figure 1 and take a quick look at it just before we start getting into the question. And let's just see what we've got. All right, so let's go to figure 1. Okay, we see that we have an upward trend here with whatever this is. We see we've got a circle to a square, then to a triangle, then to a circle. So we start with vegetables. Vegetables, their organic yield is a percentage of a conventional yield. So we see vegetables here, they grow a lot less when they're grown organically than when they're grown conventionally. Whereas we see with this circle here, this fruits are very close with organic and when they're conventional. So there's not much of a difference there, but there is a large difference in vegetables and in cereals and in these triangles a little bit, so oilseed crops. So if we go down and we look at our answer choices, let's take a look at what we've got. We've got the organic yield as a percentage of conventional yield is greater for vegetables than fruits. No, it's greater for fruits than vegetables. The organic yield as percentage of conventional yield is similar for cereals and all crops. Well, if we really think about this, it being similar for cereals and all crops, let's go look at our figure and also think back to our passage. So in our figure, we see that we've got all crops is this circle here, which is right here, and then we have cereals right here. We see that those are about the same, so yes, B will be correct. All crops and cereals will be about the same. So B will be our correct answer based on that graph. All right, now we've got which of the following claims is supported by figure 2. Let's go to figure 2 and take a quick look at it, see if we can find any trends or anything like that. All right, figure 2, I see a bit of a shape like this. As far as what that means, we've got soybeans have a high yield as a percentage of its conventional. We see that this wheat has very low, and then we have a triangle up here, which is maize has a high as well. So wheat is looking at our lowest yield. So we've got 32 or 31, which of the following claims is supported by figure 2 of the organically grown species represented. Soybeans have the lowest yield. No, I believe that they had one of the highest. Of the organic grown maize and barley represented are comparable in their yields to conventionally grown maize and barley. Well, let's go take a look at maize and barley. All right, we've got maize and barley. Maize and barley are going to be these two, and no, they are not close to their conventional grown, so that's going to be incorrect as well. So now we are on to 31. We are on to C for our option that we have to check. Of the organically grown species represented, tomatoes have the highest yield. I remember tomatoes do not, and I'll go show you that real quick. The highest yield, we see tomatoes is here. We have higher yields here, and we have a higher yield up there as well. So our answer by default is going to have to be D. and we can go ahead and show that that's correct anyways. The organically grown species represented have lower yields than their conventionally grown counterparts do. Yes, every single species up there has a lower yield than 100%, which means that the organically grown is yielding less than the conventionally grown. So that will take our answer for 31, and now we're on. All right, let's get started with passage 5. This passage is adopted from Joshua 4, Moonwalking with Einstein, the Art and Science of Remembering Everything. Copyright 2011 by Joshua 4. In 2000, a neuroscientist at University College London named Eleanor Maguire wanted to find out what effect, if any, all that driving around the labyrinth streets of London might have on cabbies' brains. When she brought 16 taxi drivers into her lab and examined their brains in an MRI scanner, she found one surprising and important difference. The right posterior hippocampus, a part of the brain known to be involved in spatial navigation, was 7% larger than normal in the cabbies, a small but very significant difference. Maguire concluded that all of that wayfinding around London had physically altered the gross structure of their brains. The more years a cabbie had been on the road, the more pronounced the effect. The brain is a mutable organ capable within limits of reorganizing itself and readapting to new kinds of sensory input, a phenomenon known as neuroplasticity. It had long been thought that the adult brain was incapable of spawning new neurons, that while learning caused synapses to rearrange themselves and new links between brain cells to form, the brain's basic anatomical structure was more or less static. Maguire's study suggested the old inherited wisdom was simply not true. After her groundbreaking study of London cabbies, Maguire decided to turn her attention to mental athletes. She teamed with Elizabeth Valentine and John Wilding, the authors of the academic monograph Superior Memory, to study 10 individuals who had finished near the top of the World Memory Championship. They wanted to find out if the memorizers' brains were like the London cabbies, structurally different from the rest of ours, or if they were somehow just better at making use of the memory abilities we all possess. The researchers put both the mental athletes and a group of matched control subjects into MRI scanners and asked them to memorize 3-digit numbers, black and white photographs of people's faces, and magnified images of snowflakes. While their brains were being scanned, Maguire and her team thought it was possible that they might discover anatomical differences in the brains of the memory champs. Evidence that their brains had somehow reorganized themselves in the process of doing all that intensive remembering. But when the researchers reviewed the imaging data, not a single significant structural difference turned up. The brains of the mental athletes appeared to be indistinguishable from those of the control subjects. What's more, on every single test of general cognitive ability, the mental athlete scores came back well within the normal range. The memory champs were smarter, and they didn't have special brains. But there was one telling difference between the brains of the mental athletes and the control subjects. When the researchers looked at which parts of the brain were lighting up when the mental athletes were memorizing, they found that they were activating entirely different circuitry. According to the functional MRIs, regions of the brain that were less active in the control subjects seemed to be working in overdrive for the mental athletes. Surprisingly, when the mental athletes were learning new information, they were engaging several regions of the brain known to be involved in 2 specific tasks, visual memory and spatial navigation, including the same right posterior hippocampal region that the London cabbies had enlarged with all their daily wayfinding. At first glance, this wouldn't seem to make any sense. Why would mental athletes be conjuring images in their mind's eye when they were trying to learn 3-digit numbers? Why would they be navigating like London cabbies when they're supposed to be remembering the shapes of snowflakes? Maguire and her team asked the mental athletes to describe exactly what was going through their minds as they memorized. The mental athletes said they were consciously converting the information they were being asked to memorize into images and distributing those images along familiar spatial journeys. They weren't doing this automatically or because it was inborn talent they nurtured since childhood. Rather, the unexpected patterns of neural activity that Maguire's functional MRIs turned up were the result of training and practice. All right, now we can get into our questions. So according to the passage, Maguire's findings regarding taxi drivers are significant because what? Well, they're significant because they're calling into question that earlier consensus, right? Now, where is that earlier consensus? Well, we're asked for evidence in our next question, so we can go ahead and find that to prove our answer correct. So if we go through and we go back up and we look at the evidence, right, this earlier consensus we talk about is that it had long been thought that the adult brain was incapable of spawning new neurons, that while learning caused synapses to rearrange themselves and new links between brain cells to form, the brain's basic structure was more or less static, right? This is calling that into question because now they're seeing that the brains of these taxi drivers, they're functioning differently, right? They're differing from this basic anatomical structure and that they have changed over time as a result of training and practice. So it's really calling that into question, and we saw that that was in lines 20 to 26. So that'll be our answer for our evidence to that question. Right, they're not demonstrating the validity of a new method, nor are they providing evidence for a popular viewpoint. We don't know if any viewpoint discussed was popular or not, nor are they challenging the authenticity of previous data. All right, question 44, as used in line 24, basic most nearly means what? Well, as usual, with a question where we are asked to go to a line and determine what a word means, that's what we're going to do. We're going to come up with our own answer first. So we have the brain's basic anatomical structure, but I'm going to need more context behind that. So we have while learning caused synapses to rearrange themselves and new links between brain cells to form, the brain's basic anatomical structure was more or less static. So here basic basically means fundamental, or yeah, really just fundamental. So the brain's fundamental anatomical structure, right? It's basic anatomical structure, what it is from birth. So that's going to be fundamental, right? It's what it was from birth, right? Not its simple anatomical structure, but it's fundamental, what it was from birth before it changed as a result of training. We're looking for a word here that's showing that it did not change, that it the basic there is insinuating that it hasn't changed yet from training. So fundamental would be the best answer there. Necessary doesn't tell us that this is before it changed. Neither does simple. Initial sort of does, but not as much as fundamental. Fundamental is really talking about that state from birth before it results in these changes. So we have D, fundamental. All right, question 45. Which question was McGuire's study of mental athletes primarily intended to answer? Well, if we really think about what he was trying to answer by studying these mental athletes, it's really whether they have an abnormal brain structure or whether they're using their brain abnormally. So whether they are, as a result of training, they're trained their brains in a different way so that their brain's functioning differently, or whether they have a completely different structure of their brain. That was what he was really trying to answer there. And our next question might ask us for evidence. It does. So we can go back through and we can find our evidence to that one pretty easily. So what we're going to do is we're going to go look for where they talk about, let's see where it's at, where they talk about this right here. They wanted to find out if the memorizers' brains were, like the London cabbies, structurally different from the rest of ours, or if they were just making better use of those memory abilities that we all possess. So whether it's use or whether it's structural from when they were born. So whether it's a different structure or they're just using it differently. So that's going to be lines 33 to 37, it looks like. So our answer there will be B. Right, and that's supporting our answer of whether heightened memorization ability stems from brain structure or using the brain differently. All right, as used in line 39, matched most nearly means what? Well, let's go to line 39 and come up with what matched most nearly means. So the researchers put both the mental athletes and a group of matched control subjects into MRI scanners and asked them to memorize 3-digit numbers. So matched really here is meaning similar, right? They're similar control subjects, because that's what you need for control subjects, is you need similar control subjects to those you're using. So matched there means similar if we have that as an answer choice. We do not. So what we're looking at then is comparable, right? Similar or comparable. Comparable would also work. They can't be identical because they will have different genes or different genetics. We do not want them to be distinguishable. We want them to be as close as possible or as comparable as possible, and they're not competing either. So 47 there, our answer is going to be A. All right, question 48. The main purpose of the fifth paragraph in lines 57 to 65 is what? Well, let's go to our fifth paragraph, 67 to, hang on, 67 to what did it say? 67 to 57 to 65. Okay, 57 to 65, what is the purpose? All right, but there was one telling difference between the brains of the mental athletes and the control subjects. When the researchers looked at which parts of the brain were lighting up when the mental athletes were memorizing, they found they were activating entirely different circuitry. According to the functional MRIs, regions of the brain that were less active in controls seemed to be working in overdrive for the mental athletes. So they're using different parts of their brain is what the big point there is. So the main purpose, as far as question 48, we're really talking about the main purpose being identifying that important finding of the different use of different parts of the brain. So the controls were using different parts of the brain than were the mental athletes is really what we're looking at there. We aren't speculating on the reason for McGuire's unexpected results there, nor are we relating the study of mental athletes to the study of taxi drivers. We're also not transitioning from any summary of findings. We are just identifying that important difference in the use of the areas of the brain. All right, question 49. According to the passage, when compared to mental athletes, the individuals in the control group in McGuire's second study did what? Well, what they were doing is they were exhibiting those different brain activity, right? I'm sorry, I cannot speak today. They exhibited different patterns of brain activity, right? They talk about how the individuals in the control group for the second study, different areas of their brain lighted up than the memorization masters, right? So we had differences in brain activity between the control group and those that were professional memorizers. So our answer there is going to be C. They didn't show less brain activity, they just showed different, demonstrating a wider range of cognitive ability. No, they demonstrated different areas but not a wider range. D, displaying noticeably smaller hippocampal regions. We didn't talk specifically about that, so we can get rid of that as well. All right, question 50. The passage most strongly suggests that mental athletes are successful at memorization because they what? Well, really here they talk about how they're successful because they're exploiting parts of the brain, such as imagery, right? They memorize things as images, which normal people don't do, right? So they're exploiting parts of the brain that aren't normally used in routine memorization. And we saw that because the control group, their brains weren't lighting up like these people's were, like the professional memorizers were. All right, and then B, converting information they're trying to memorize into abstract symbols. Well, it didn't really say abstract symbols. It was actually specific, right? It was talking about images that could help them remember. C, organizing information into numerical lists. They didn't do that. They talked about them looking at that as images. Exercising their brains regularly through puzzles and other mental challenges. No. It had to do with differences in the way, the pathways that they memorize things and things like that. 51, which choice provides the best evidence to our previous answer choice? So right here, that's going to be, let's go ahead and find it. So evidence that they are doing, okay, right here. They were engaging several known regions of the brain to be involved in specific tasks, visual memory, so that images I was talking about, as well as spatial navigation, including the same posterior hippocampal region that the London cabbies had enlarged in their daily wayfinding. So they're really using that visual memory and that spatial memory. All right, so that's going to be lines. Let's see where that was. That's about 66 to about 73, just about there. Let's see if that's an option for our evidence. 66 to 73, 66 to 72. Yep, that's good enough. We don't need that 73 there. That one works fine. So 51 there will be A, and then 52, the questions in lines 74 to 78 primarily serve to do what? Well, let's go take a look. We've got 74 to 78. Why would mental athletes, by conjuring images in their mind's eye when they were trying to remember to learn 3-digit numbers, why would they be navigating like London cabbies when they're supposed to be remembering the shapes of snowflakes? So that's really introducing then what we are going to talk about for our explanation, right? So we're introducing our explanation there is what we're really kind of doing there. So what I would say for 52 is I would say that we're not introducing and explaining that connection because we're not really explaining it, right? Between his two, especially not between his two studies. That's really the big part with D that makes D wrong. We're not connecting the two studies really at all from her earlier work, so we can get rid of D. C, implying his findings undermine earlier studies. We don't do that, but what we are doing is we are emphasizing and elaborating on an initially puzzling result of his study of mental athletes. So we're kind of emphasizing the fact that it doesn't necessarily at first glance make sense that their minds are operating like the London cabbies and using imagery and using spatial learning to study these 3 numbers in a row, right? That's kind of puzzling at first, and we're emphasizing that part by using those questions. We're not raising doubts about the reliability of any conclusions either there. So that's going to be B. We're really just emphasizing that it's puzzling, and we can go back and I can show you that as well. We've got that right. We say, why would mental athletes' images be conjuring images in their mind when they were trying to learn 3-digit numbers, right? That's puzzling at first because we're not really sure why they're navigating like London cabbies when they're supposed to be remembering shapes of snowflakes. So that's what really makes that one be emphasizing the puzzling nature of why they do that. So B will be our answer for 52. All right, so for passage 3, questions 22 to 32 are based on the following. This passage is adopted from Elsa Youngstead, titled Decoding a Flower's Message, copyright 2012 by Sigma G, the Scientific Research Society. All right, so Texas gourd vines unfurl their large, flared blossoms in the dim hours before sunrise. Until they close at noon, their yellow petals and mild, squashy aroma attracts bees that gather nectar and shuttle pollen from flower to flower. But when you advertise to pollinators, you advertise in an open communication network, says chemical ecologist Ian Baldwin of the Max Planck Institute for Chemical Ecology in Germany. You attract not just the good guys, but you also attract the bad guys. For a Texas gourd plant, striped cucumber beetles are among the very bad guys. They chew up pollen and petals, defecate in the flowers, and transmit the dreaded bacterial wilt disease, an infection that can reduce an entire plant to a heap of collapsed tissue in mere days. In one recent study, Nina Thies and Lynn Adler took on the specific problem of the Texas gourd: how to attract enough pollinators but not too many beetles. The Texas gourd's main pollinators are honeybees and specialized squash bees, which respond to its floral scent. The aroma includes 10 compounds, but the most abundant and the only one that lures squash bees into traps is 1,4-dimethylhexylbenzene. Intuition suggests that more of that aroma should be more appealing to bees. We have this assumption that a really fragrant flower is going to attract a lot of pollinators, says Thies, a chemical ecologist at Elms College in Chicopee, Massachusetts. But she adds that idea hasn't really been tested, and extra scent could well call in more beetles too. To find out, she and Adler planted 168 Texas gourd vines in an Iowa field, and throughout the August flowering season made half the plants more fragrant by tucking dimethoxybenzene treated swabs deep inside their flowers. Each treated flower emitted about 45 times more fragrance than a normal one. The other half of the plants got swabs without fragrance. The researchers also wanted to know whether extra beetles would impose a double cost by both damaging flowers and deterring bees, which might not bother to visit and pollinate a flower laden with other insects and their feces. So every half hour throughout the experiment, the team plucked all the beetles off of half the fragrance enhanced flowers and half the control flowers, allowing bees to respond to the blossoms with and without interference by beetles. Finally, they pollinated by hand half of the female flowers in each of the 4 combinations of fragrance and beetles. Hand-pollinated flowers should develop into fruits with the maximum number of seeds, providing a benchmark to see whether the fragrance-related activities of bees and beetles resulted in reduced pollination. It was very labor-intensive, says Thies. We would be out there at 4 in the morning, 3 in the morning to try and set up before these flowers open. As soon as they did, the team spent the next several hours walking from flower to flower, observing each for 2-minute intervals and writing down everything we saw. What they saw was double the normal number of beetles on fragrance-enhanced blossoms. Pollinators, to their surprise, did not prefer the highly scented flowers. Squash bees were indifferent, and honeybees visited enhanced flowers less often than the normal ones. Thies thinks the bees were repelled not by the fragrance itself, but by that abundance of beetles. The data showed that the more beetles on a flower, the less likely a honeybee was to visit it. That added up to less reproduction for fragrant-enhanced flowers. Gourds that developed from those blossoms weighed 9% less and had on average 20 fewer seeds than those from normal flowers. Hand pollination didn't rescue the seed set, indicating that beetles damaged flowers directly regardless of whether they also repelled pollinators. Hand pollination did rescue fruit weight, a hard to interpret result that suggests that lost bee visits did somehow harm fruit development. These new results provide a reason that Texas gourd plants never evolved to produce a stronger scent. If you really ramp up the odor, you don't get more pollinators, but you can really get ripped apart by your enemies, says Rob Raguso, a chemical ecologist at Cornell University who is not involved in the Texas gourd study. All right, so at this point, we can go ahead and get into our questions now that we've read the passage. So question 22, the primary purpose of the passage is to what? Well, this is a big picture question determining the purpose of the passage as a whole. So what's the purpose of the passage as a whole? Well, the purpose of the passage as a whole is to describe the aim, method, and results of an experiment. Okay, this whole passage is really about that experiment dealing with those beetles and those pollinating bees and those Texas gourds. So we describe the aim. So what are we aiming to do with this experiment? We talk about that in the first couple paragraphs. Then we describe our experimental design. Okay, we discuss how our experiment is set up, what we do, the waking up at 3 a.m. to go out there and record the observations of those plants. And then after that, we describe the results, right? Showing that those beetles were attracted to that extra scent, and that even though there was more scent, those increased beetles actually caused the Texas gourds to not survive as much because of how many beetles there were, even though you would expect that more aroma would attract more pollinators. Okay, so the results of the experiment were described in the end. Okay, so that's really what that primary purpose of that passage is, so B will be our answer there. As far as why A, C, and D are wrong, A says discuss the assumptions and reasoning behind a theory. We don't discuss those assumptions and reasoning behind the theory, and if we do, even if we did a little bit, that's not the primary purpose of the passage, right? We want to look at the big picture when we're asked for the purpose of a whole passage. We want to look big picture. C, present and analyze conflicting data about a phenomenon. There is no conflicting data about the phenomenon. C is incorrect. D, show the innovative nature of a procedure in a study. That is not, that's not the big picture here, okay? That is definitely not the big picture. Even if it was true, it would be too narrow, even if it was true. All right, question 23. As presented in the passage, Thies and Adler's research primarily relied on which type of evidence? Okay, well, if we think back to what it said, it talked about how they had to wake up at 3 and 4 in the morning and look at each flower for 2 minutes, and then after looking at the flower for 2 minutes, they had to write down everything that they saw in that flower in that 2-minute period for 168 flowers, I think was the number. It was something like that. It was in the hundreds of flowers. But they're really relying on that direct observation, that writing down of what they see on those flowers. So that was their main evidence that they used there. Okay, they're not using historical data. They're doing an experiment in which they collect data in the present. They're not using expert testimony. Once again, they're conducting that experiment with that direct observation. Also not random sampling. We would expect random sampling more in a social science passage than a science passage like this. 24, which statement about striped cucumber beetles can be most reasonably inferred from the passage? All right, well, if we think about those striped cucumber beetles, what we really think about is how they are attracted to that same compound that those Texas gourds release for those squash bees. So those squash bees and those cucumber beetles are both attracted to that scent that those Texas gourds are giving off. Okay, so D would be our answer there. We strongly suggest that throughout the passage, so that would definitely be what can be inferred from the passage. As far as why A through C are wrong, A says they feed primarily on Texas gourd plants. We never make that claim, so we cannot put that as A. There's no evidence to support that. B, they are less attracted to dimethoxybenzene than honeybees are. We don't say which one is more attracted, so we have to get rid of B as well. That would also be unsupported by the text. C, they experience only minor negative effects as a result of carrying bacterial wilt disease. Once again, we have no evidence to support that, so that could not be our answer. 25. The author indicates that it seems initially plausible that Texas gourd plants could attract more pollinators if they what? Well, that's going to be increasing their floral scent, right? 25 there, answer is going to have to be C. So how did I know that so quickly? Well, we know that in the beginning we talk about how Texas gourd plants, we're confused as to why they don't just increase their floral scent if we know that that attracts pollinators, because if we attract more pollinators, we're going to get more Texas gourd plants, which feeds into fitness and how plants want to produce more, like they want to reproduce at higher rates if they can. So as far as why they can't just increase their floral scent to do that, that's what we go on throughout the passage to talk about. But we have to start that by making that claim. Why don't they just increase their floral scent? So that's the answer for 25. The author does not indicate that it seems initially plausible that the Texas gourd plants could attract more pollinators if they didn't have aromatic flowers. He's saying they actually want more aroma, so that's really a reversed relationship. A has to be wrong. B, targeted insects other than bees. That suggests that they're targeting insects like they would prey, and they're not predators in this case, so B is incorrect. D, emitted more fragrant compounds, or I'm sorry, more varied fragrant compounds. Key part that's wrong with this is varied, okay? He's arguing for them to increase the amount of aroma that they're producing, but he doesn't argue for them to produce a diverse set of fragrances. So that's why D is wrong. All right, 26, as used in line 38, treated most nearly means. Okay, this is a words in context question. We can go to line 38, figure out what it means, and then figure out our own answer choice so we're not swayed between two. So we have each treated flower emitted about 45 times more fragrance than a normal one. Okay, we know this is in context to him talking about how he's putting those fragrances behind those flowers or in those flowers to add that extra scent, right? So he's really altering the flowers, okay? So another word there would be a changed flower or an altered flower. Those would both be good options, okay? Each changed flower, each altered flower. Altered would be my number 1 choice. Changed would be my number 2 choice. So let's see if we have either of those. I'm guessing we're going to have at least one. We see we do have altered, okay? We wouldn't say restored because that would imply that something fails and then we fix it up, and that's not what's occurring here. We're not providing the flowers, okay? We're altering them or treated the flowers. We're not preserving them either. We are changing them. So altered is going to be our answer for 26. 27. What did Theis and Adler do as part of their study that most directly allowed Theis to reason that bees were repelled not by the fragrance itself? Okay, well, what did they do? They took the beetles off, okay? By taking those beetles off, right, and I think that that's answer choice D, I do believe. Let me take a quick look and read it, and it is answer choice D. They gave bees a chance to choose between beetle-free enhanced and beetle-free normal. Okay, by doing that, they're able to tell if it's the fragrance itself, that increased fragrance that's repelling them, or it's the beetles, because there's no beetles on those beetle-free enhanced flowers. Okay, so that's what's really causing that to be, allowing them to determine that they're not repelled by that fragrance itself. So D is going to have to be our correct answer there. As far as 28, which choice provides that best evidence? Okay, that's going to be, I believe it's right around the middle of the passage. Let me find it real quick. Right here where they talk about taking those beetles off. So every half hour throughout the experiments, the team plucked all the beetles off of half the fragrance-enhanced flowers and half the control, allowing bees to respond to the blossoms with and without interference by beetles. Okay, so that's showing that they're able to determine if it's the beetles or that enhanced fragrance that is causing the variables to change. So answer there, 45 to 50 would be our correct answer. Let's go find that. That's answer choice A for 28. All right, question 29. We've got the primary function of the 7th and 8th paragraphs is to do what? Well, our 7th and 8th paragraphs, we really talk about summarizing our findings, right? We talk right here, we say, let me find where it is. 7th and 8th paragraphs. Let me go down and quick check what lines it said again. Lines 65 to 84. Okay. So I see in line 64, we start talking about how squash bees are indifferent, honeybees visited enhanced flowers left us than the normal ones. So at this point, we're really describing our results. So we start describing our results right around here. And then down here, once again, we get into more of the specifics of our results, right? We have quantitative results, so our specifics of our results. We start diving into quantitative measurements of our results. So really summarizing up our findings. And then in the end here, we answer our driving question saying the new results provided a reason the Texas gourd never evolved to produce a stronger scent. So really summarizing our findings and then applying them. So let's look at our answer choices. We have option A, summarizing their findings. That's perfect. So 29 answer there is going to be A. As far as why B, C, and D are incorrect, describing their hypotheses, no, those last ones are summarizing findings. Hypotheses was found in the beginning. Illustrating their methods, that came before it. That was that experimental design. That was before these lines. D, explaining their reasoning. That was also before those lines. Okay, these lines are focusing on their findings. So 29 is going to be A. 30. In describing squash bees as indifferent, line 68, the author most likely means what? Well, let's go to line 68, figure out our own answer choice first, so we're not stuck between two. Okay, so we've got what they saw was double the number of beetles on fragrance-enhanced blossoms. Pollinators did not prefer the highly scented flowers. Squash bees were indifferent. Honeybees visited enhanced flowers less often than normal ones. Okay, so the squash bees being indifferent is contrasted by the honeybees preferring one over the other. So squash bees being indifferent would mean they don't prefer one over the other. Okay, so they're not preferring one over the other. Okay, they are neutral. They don't pick one over the other. They have no indicated preference. So we're going to look for an answer choice that says that. We have option A, could not distinguish between enhanced and normal. We don't say they can't distinguish, so A is wrong. B, visited enhanced and normal at an equal rate. Yes, that's showing they're indifferent or do not have a preference, right? C is wrong because it says they prefer one, and then B is wrong because it says that we're talking there about beetle infested versus beetle free, and we're talking about normal versus enhanced. So D is going to be wrong as well. So 30 is going to have to be answer choice B. All right, question 31. According to the passage, Thies and Adler's research offers an answer to which of the following questions? Well, I just touched on that with my driving question I found at the end there. I'll go ahead and pull that up real quick. The new results provide a reason that the Texas gourd plants never evolved to produce a stronger scent. So this is answering why they don't have an increased aroma to attract pollinators. So we'll look for an answer choice that says that. A, how can Texas gourd plants increase the number of visits they receive from pollinators? No, that's not what we're answering. B, why is there an upper limit on the intensity of the aroma emitted by Texas gourd plants? Yes. Okay, we are answering why they don't produce more aroma in order to increase the amount of pollinators they attract. And the answer is they have an upper limit on that intensity because it attracts beetles, which ultimately decreases the amount of pollinators that they receive. So 31 is going to have to be B. As far as 32, best evidence, that would be what I found before, which was 85 to 86, I believe, right, where I said that it answered my driving question. I see that that's right there, 85 to 86, so that's going to be my evidence for that question. So that's going to be D for 32. All right, so now let's go ahead and move on to. All right, let's get going through passage 5 here. So questions 40 through 52 are based on the following. The passage is adopted from Kevin Bullis, What Tech is Next for the Solar Industry, copyright 2013 by MIT Technology Review. Solar panel installations continue to grow quickly, but the solar panel manufacturing industry is in the doldrums because supply far exceeds demand. The poor market may be slowing innovation, but advances continue. Judging by the mood this week at the IEEE Photovoltaics Specialist Conference in Tampa, Florida, people in the industry remain optimistic about its long-term prospects. The technology that surprised almost everyone is conventional crystalline silicon. A few years ago, silicon solar panels cost $4 per watt, and Martin Green, professor at the University of New South Wales and one of the leading silicon solar panel researchers, declared that they'd never go below $1 a watt. Now it's down to something like 50 cents a watt, and there's talk of hitting 36 cents per watt, he says. The U.S. Department of Energy has set a goal of reaching less than $1 per watt, not just for the solar panels, but for complete installed systems by 2020. Green thinks that the solar industry will hit that target even sooner than that. If so, that would bring the direct cost of solar power to 6 cents per kilowatt hour, which is cheaper than the average cost expected for power from new natural gas power plants. All parts of the silicon solar panel industry have been looking for ways to cut costs and improve the power output of solar panels, and that's led to steady cost reductions. Green points to something as mundane as the paste used to screen print some of the features of solar panels. Green's lab built a solar cell in the 1990s that set a record efficiency for silicon solar cells, a record that stands to this day. To achieve that record, he had to use expensive lithography techniques to make fine wires for collecting current from the solar cell. But gradual improvements have made it possible to use screen printing to produce ever finer lines. Recent research suggests that screen printing techniques can produce lines as thin as 30 micrometers, about the width of the lines Green used for his record solar cells, but at cost far lower than his lithography techniques. Meanwhile, researchers at the National Renewable Energy Laboratory have made flexible solar cells on a new type of glass from Corning called willow glass, which is thin and can be rolled up. This type of solar cell they made is the only current challenger to silicon in terms of large-scale production. Thin film, cadmium, telluride, flexible solar cells could lower the cost of installing solar cells, making solar power cheaper. One of Green's former students and colleagues, Juana Zhao, co-founder of solar panel manufacturer China Sunergy, announced this week that he is building a pilot manufacturing line for a two-sided solar cell that can absorb light from both the front and back. The basic idea, which isn't new, is that during some parts of the day, sunlight falls on the land between rows of solar panels in a solar power plant. That light reflects onto the back of those panels and can be harvested to increase the power output. This works particularly well when the solar panels are built on sand, which is highly reflective. where a one-sided solar panel might generate 340 watts and a two-sided one might generate up to 400 watts. He expects the panels to generate 10 to 20% more electricity over the course of a year. Even longer term, Green is betting on silicon, aiming to take advantage of huge reductions in cost already seen with the technology. He hopes to greatly increase the efficiency of silicon solar panels by combining silicon with one or two other semiconductors, each selected to efficiently convert a part of the solar spectrum that silicon doesn't convert efficiently. Adding one semiconductor could boost efficiencies from the 20 to 25% range to around 40%. Adding another could make efficiencies as high as 50% feasible, which would cut in half the number of solar panels needed for a given installation. The challenge is to produce good connections between these semiconductors, something made challenging by the arrangement of silicon atoms in crystalline silicon. Okay, then I have two graphs, and now we're going to go ahead and get into our questions. So the passage is written from the point of view of what? Well, let's just run through A through D and let's see. We obviously know it's written from the point of view of someone who's really talking about the changes that are going on in the solar industry. Okay, so we're really looking for that. It's kind of tough to tell who exactly is writing it. I would say that's going to be either the perspective, not of a scientist, so I can get rid of B, right? It's not from the scientist. It's really from the perspective of a journalist who's enumerating these changes in a field, okay? They're talking about how solar used to be very expensive and have low power output. Now we are increasing our power output and decreasing our cost, okay? Where it's not from a hobbyist, because a hobbyist wouldn't be writing like this, right? A hobbyist would be using more slang, more casual terms, not explaining as much. He's not explaining necessarily the new capabilities of technology either. We're really talking about those changes in that field, that lowering of cost, increasing of power output. Also, definitely not a consumer writing this. Question 44, as used in line 4, poor most nearly means what? Well, let's go take a look at what it says. So we've got the poor market may be slowing innovation, but advances continue. And I see before that I have because supply far exceeds demand. Okay, if supply far exceeds demand in a market, we would describe that market as poor or as a weak market. Okay, the demand is weak, the market is weak for that product. Okay, so I'm really looking for weak there. That would be my best answer choice if I have that. I see I do have that, right? We would not describe a market as humble. A market cannot be humble. A market can't really be pitiable either. As far as obsolete, the market is not obsolete because there is still demand there. Okay, it's not completely gone. 45, it can be most reasonably inferred from the passage that many people in the solar industry believe what? Okay, well, many people in the solar industry are believing that the cost of these solar panels is too high and their power output is too low, right? They talk about how they need to have cost reductions before this really is viable as an alternative to natural gas and other forms of energy use. So they're really talking about how they need to drop that cost if they want this to really work out. All right, so that's 45. 45, we know our answer there is going to be C. As far as why A, B, and D are wrong, let's quick cover that. Consumers don't understand how solar panels work. We never make that claim. B, two-sided cells have weaknesses not yet discovered. We also never make that claim. D, willow glass is too inefficient to be marketable. Once again, never make that claim. 46, we're asked for evidence. Okay, so that's going to be where we talk about how the cost is too high, right, and power output too low. I see that that's going to be right here. All parts of the silicon solar panel industry have been looking for ways to cut costs and improve power output of solar panels, and that's led to steady cost reductions. So I see that's from 27 to 30, so that's going to be my evidence there. Okay, so with evidence questions, always try to remember where that best evidence is. I see my answer then for 46 is going to be D. All right, question 47. According to the passage, two-sided solar panels will likely raise efficiency by doing what? Well, we talk about how those two-sided solar panels, right, and we're asked for evidence, so I'll go and show you where this is as well. We talk about how those two-sided solar panels will collect that light that reflects off the ground or off that sand it talked about. So right here, okay, the light reflects onto the back of the panels and could be harvested to increase power output, okay? So increasing power output, increasing efficiency by capturing that light. So that's 61 to 62 would be my evidence there. So 61 to 62, so that's going to be B for 48. Okay, as far as what 47 is going to be, they're raising that efficiency by absorbing that reflected light. So 47 there, that's going to be B. Right, we're absorbing that reflected light off the ground. We're not requiring little energy to operate or being reasonably inexpensive to manufacture, and preventing light from reaching the ground. That is not what we're doing. So D is also incorrect. 48 already answered that one. Now we're down to 49. As used in line 69, betting on is most nearly means what? Well, let's go take a look at betting on, come up with what it most nearly means. We know it was line 69. I'll go ahead and make sure I box that term up so you can see it. It's right here. Okay, so we have even longer term. Green is betting on silicon, aiming to take advantage of the huge reductions in cost already seen with the technology. Okay, Green betting on silicon here basically means he's counting on silicon or relying on silicon or thinks it's going to be a positive thing, right? He's very optimistic about it. So anything like that. So anything where it says he's optimistic about it or he's relying on silicon, counting on silicon, anything like that would be a great option. I see I don't have anything as counting on or relying on silicon, but I do have optimistic about, which is what he is. He's optimistic about it. He's betting on it. He is counting on it, relying on it. He thinks it's going to work. He's not saying switch from it. He's not gambling with it, and he's not dabbling in it either. He's very, very all in with this. He's not dabbling. He's betting on it, right? He's optimistic about it. 50, the last sentence of the passage mainly serves to do what? Let's go take a look at what that sentence is. Come up with our own answer first so we don't get stuck between two. Okay, I have recent research, or I'm sorry, that's the wrong part, right here on the right side. The challenge is to produce good connections between these semiconductors. Okay, a challenge, which means we have an obstacle we're going to have to overcome. Something made challenging by the arrangement of silicon atoms in a crystalline silicone. Okay, we're really describing a challenge that the solar industry still faces, so we're looking for something that describes an obstacle that must be overcome for the industry. So let's go through A through D, see what has that. A, express concerns about the limitation of material, no. B, identify a hurdle that must be overcome, yes, right? We talked about identifying an obstacle or a challenge. We talked about it has to be overcome, that challenge of converting that energy, right? So that challenge we talked about at the end, that is a hurdle that has to be overcome for the solar industry to be improved. So B would be our correct answer for 50. 51, according to figure 1, in 2017, the cost of which of the following fuels is projected to be close to the 2009 average. All right, in figure 2 it says. So 2009 average cost was $120 per megawatt hour. Let's take a look at which one crosses that or is closest to that. I see 120 is going to be right around here, and I see that that's advanced nuclear. So advanced nuclear would be my answer for 51. I see that that's going to be answer choice D. 52, according to figure 2, in what year is the average cost of solar photovoltaic power projected to equal the 2009 cost? Okay, so this is figure 2. We find where that 2009 is going to intersect our projection. We see that that's in year 2020. So answer there is going to be 2020. All right, so that takes us through this section. This passage is adopted from Patricia Waldron, Why Birds Fly in a V Formation, published in 2014 by American Association for the Advancement of Science. Anyone watching the autumn sky knows that migrating birds fly in a V formation, but scientists have long debated why. A new study of ibises found that these big-winged birds carefully position their fingertips and sync their flapping, presumably to catch the preceding bird's updraft and save energy during flight. There are two reasons birds might fly in a V formation. It may make flight easier, or they're simply following the leader. Squadrons of planes can save fuel by flying in a V formation, and many scientists suspect that migrating birds do the same. Models that treated flapping birds like fixed-wing airplanes estimate that they save energy by drafting off each other, but currents created by airplanes are far more stable than the oscillating eddies coming off of a bird. Air gets pretty unpredictable behind a flapping wing, says James Usherwood, a locomotor biomechanist at the Royal Veterinary College at the University of London in Hatfield, where the research took place. The study, published in Nature, took advantage of an existing project to reintroduce endangered north bald ibises to Europe. Scientists used a microlight plane to show hand-raised birds their ancestral migration route from Austria to Italy. A flock of 14 juveniles carried data loggers specially built by Usherwood and his lab. The device's GPS determined each bird's flight position within 30 centimeters, and an accelerometer showed the timing of the wing flaps. Just as aerodynamic estimates would predict, the birds positioned themselves to fly just behind and to the side of the bird in front, timing their wing beats to catch the uplifting eddies. When a bird flew directly behind another, the timing of the flapping reversed so that it could minimize the effects of the downdraft coming off the back of the bird's body. We didn't think this was possible, Usherwood says, considering that the feat requires careful flight and incredible awareness of one's neighbors. Perhaps these big V-formation birds can be thought of quite like an airplane with wings that go up and down. The findings likely apply to other long-winged birds such as pelicans, storks, and geese. Usherwood says, smaller birds create more complex wakes that would make drafting too difficult. The researchers did not attempt to calculate the bird's energy savings because the necessary physiological measurements would be too invasive for an endangered species. Previous studies estimate that birds can use 20% to 30% less energy while flying in a V. From a behavioral perspective, it's really a breakthrough, says David Lentink, a mechanical engineer at Stanford University in Palo Alto, California, who was not involved in the work. Showing that birds care about syncing their wing beats is definitely an important insight that we didn't have before. Scientists do not know how the birds find that aerodynamic sweet spot, but they suspect that the animals align themselves either by sight or by sensing air currents through their feathers. Alternatively, they may move around until they find the location with the least resistance. In future studies, the researchers will switch to a more common bird, such as pigeons or geese. They plan to investigate how the animals decide who sets the course and the pace, and whether a mistake by the leader can ripple through the rest of the flock to cause traffic jams. It's a pretty impressive piece of work as it is, but it does suggest there's a lot more to learn, says Ty Hendrick, a biologist at the University of North Carolina, Chapel Hill, who studies flight aerodynamics in birds and insects. However they do it, he says, birds are awfully good hang glider pilots. All right, the main purpose of the passage is what? Well, if we think about the main purpose, what we're doing here is we're explaining research, right? We're explaining research about why these birds are flying in that V formation, right? So that will be answer choice C, right? We're explaining research conducted to study why some birds fly in a V formation. If we look at our other answer choices, we have A, describe how squadrons of planes can save fuel by flying in a V formation. We're not talking about squadrons of planes, so we can just get rid of A altogether. B, discuss the effects of downdrafts on birds and airplanes. Once again, you'd be focusing too narrow on this airplanes if you answered B, right? We're focused on birds. The airplanes was really just to explain it using a commonplace example. Right, now we have D, illustrate how birds sense air currents through their feathers. Once again, you'd be focusing too narrowly on that last paragraph where we talk about how birds may be sensing where to go in that V formation, right? We don't want to be too narrow. We want to look at the big picture, which is choice C. Question 23, the author includes the quotation, air gets pretty unpredictable behind a flapping wing in lines 17 to 18 to do what? Well, guys, when you're given lines 17 to 18 or any lines and you have to answer a question on it, it's always helpful to go back, so we're going to go ahead and do that, right? So if we go back to lines 17 and 18, we see air gets pretty unpredictable behind a flapping wing. But what comes before it? Because we need context. We have, starting in 13, models that treated flapping birds like fixed-wing airplanes estimate that they save energy by drafting off each other, but currents created by airplanes are far more stable than the oscillating eddies coming off of a bird. Air is pretty unpredictable behind a flapping wing. Well, what we're doing from 13 all the way to 18 is we're comparing the airplanes, right, the drafting behind airplanes to the drafting behind these birds, right? So what we're doing when we say that it's unpredictable, let me find, where are we at? Right here, okay. So what we're doing when we say that the air gets pretty unpredictable behind that flapping wing is we're explaining that that current created by that bird differs from that uniform air predictability that comes behind that airplane, right? We're explaining that difference. So our answer there will be A, right? We're not stressing the amount of control the birds have in that V formation or indicating wind movement or emphasizing that there's power in the flapping of the bird's wings, right? Our answer is A. Question 24. What can be reasonably inferred about the reason Usher would use northern bald ibises as the subjects of his study? Well, if we remember back to the passage, and I'm guessing we do have evidence as our next question, so I'll go and find that as I do it. If we remember back in the passage, it talks about how they were using these other ones that they pretty much, they were close to, right? And that they just had easy access to. It wasn't anything in particular about why they wanted to use that species. It was just they had good access to them. So I'll go ahead and show you guys where that was. We see that it is in this paragraph here, right? Or it looks like it. Yep. Okay, the study published in Nature took advantage of an existing project to reintroduce endangered northern bald ibises to Europe, right? So they just wanted to make use of that existing project. It was just easily accessible, and that's lines 22 to 24. So we'll go ahead and find that answer, 22 to 24, C. And then for 24, we've got the ibises were well acquainted. No. Usherwood knew the ibises were familiar. No. The ibises have a body design similar to an airplane. No. D, the ibises were easily accessible for Usherwood and his team to track and observe. Absolutely. We already got evidence in 25. Question 26, what's the most likely reason the author includes the 30 centimeter measurement? Once again, we want to go back to that text, use that line 30 it's telling us, right? We go back to line 30, we see that it says the device's GPS determined each bird's flight position to within 30 centimeters. That is going to be telling us that sort of margin of error, right? Telling us how accurately data is being collected. So look at our answer choices. A, to demonstrate the accuracy with which the data loggers collected the data, and that is the correct answer. B, to present recorded data. No, it's presenting that margin of error, right? That accuracy, the level of accuracy of that data that's being collected. C, provide the wingspan. No. D, show how far behind the plane they flew. No. All right. 27, what does the author imply about pelicans, storks, and geese flying in a V formation? And we're asked for evidence, so I'll go ahead and take you guys back to what I'm looking at right off the bat. So when we talk about those pelicans and storks, I remember that was right around here, right? The findings likely apply to other long-winged birds, such as pelicans, storks, and geese, Usherwood says, right? So basically his claim then, right, if we go down here, his claim then is that no, they don't expend more energy than ibises, but they create that similar wake, right? All these long-winged birds is what he's talking about, the long-winged birds. They create that similar wake so that they can draft off of each other, right? So our answer there will be C. And then for our evidence for that, what jumped out to me as I was reading it for evidence for that, right, was right here when he says the findings apply to other long-winged birds, right? So that would be from 45 to 47. But what I see in my answer choices for evidence is I don't have that, right? I'm not given that. But what I am given is I am given 47 to 48. Now here's why 47 to 48 works. Because it says smaller birds create more complex wakes that would make drafting too difficult. We are talking about large birds, right? So when we say that these smaller birds, their wakes are more complex and make drafting too difficult, we're kind of doing addition by subtraction. And here's what I mean by that. We're insinuating when we say this, we're insinuating that those larger birds then, their wakes are less complex and they are able to draft. So our answer then is going to be from 47 to 48, right? Go ahead and find that, right? I'll go and show you why the other ones are wrong real quick. We got 35 to 38. When a bird flew directly behind one another, the timing of the flapping reversed so it can minimize the effects of downdraft coming off the back of the bird's body. We haven't started talking about those other animals though, those other birds, so we can get rid of that one. It's too early in the passage. And then we got 52 to 54. Go take a quick look at that. That says previous studies estimate that birds can use 20 to 30% less energy while flying in a V. Once again, that's not specific to those species we were talking about, right? Those storks and pelicans, I think is what it was. But either way, right? That's not specific to the one we were talking about. So you can get rid of that. And then 66 to 67, I believe, is also not specific to the birds we were talking about. Alternatively, they may move around until they find the location of least resistance. That is also not specific, right? So we know our answer then will be B. 29. What is the main idea of the 7th paragraph in lines 62 to 73? We'll go find that. We always want to reference those lines as we're answering. We see we've got it right here. Right? So we got scientists do not know how the birds find that aerodynamic sweet spot, but they suspect that animals align themselves either by sight or sensing air currents through feathers. Alternatively, they may move around until they find the location of least resistance. In the future studies, the researchers will switch to more common birds. They plan to investigate how the animals decide who sets the course and pace and whether a mistake made by the leader can ripple through the rest of the flock. What that's doing is talking about future studies that they want to do. So I'm going to look for an answer that focuses in on that aspect of the writing. So we've got A, different types of hierarchies exist. No. Mistakes can happen when long-winged birds create a V formation. No. They're going to investigate whether that happens, but they're not making that claim. C, future research will help scientists better understand V formations. Absolutely. It's all about those future experiments they want to do to learn more about the V formations. D, long-winged birds watch the lead bird closely. Once again, that's what they want to test, right? That's not making a claim there. That would be focusing too much on that one sentence in that paragraph. 30, the author uses the phrase aerodynamic sweet spot in line 63 to most likely what? Like we said, if we're given a line to go to, we want to go to that line, even if we're confident, because you never know, you could be making a mistake. Scientists do not know how the birds find that aerodynamic sweet spot, but they suspect they align themselves either by sight or sensing currents through their feathers. All right, what he means when he's saying this aerodynamic sweet spot is where there's the least resistance, right? There's less air that they have to work through. So the spot with the least resistance, I see it's most likely to what? Describe how the proper structural design of an airplane. Once again, we're not talking about airplanes. B, show that the flying can be an exhilarating experience. No, that's a value judgment. This is a scientific essay. C, describe the bird's synchronized wing movement. All right, that's still not our answer, right? When we're talking about synchronized wing movement, that's not talking about that aerodynamic sweet spot. And D, suggests a certain position in a V formation has the least amount of wind resistance. Absolutely. Our answer there is going to be D for 30. All right, 31, as used in line 72, ripple most nearly means what? Well, let's go to 72. We're going to underline the word ripple. We've got ripple is right here, right? So we're going to go through, read that sentence, and come up with our own answer first. So they plan to investigate how the animals decide who sets the course and the pace, and whether a mistake by the leader can ripple through the rest of the flock and cause traffic jams, right? Ripple here means spread, right? Whether a mistake made by the leader can spread through the rest of the flock. So that would be what I'm looking for in my answer choices. So I go down, I see we have spread B, and that'll be my answer. We wouldn't say that it fluctuates. We wouldn't say that it's a wave or undulates, right? It spreads, right? All right, so now we can go and move on to passage 4. Question. This passage is adopted from Brian Greene, How the Higgs Boson Was Found, published in 2013 by the Smithsonian Institution. The Higgs boson is an elementary particle associated with the Higgs field. Experiments conducted in 2012 to 2013 tentatively confirmed the existence of the Higgs boson and thus of the Higgs field. All right, I'm going to read the passage. If you've already read the passage, you can go ahead and skip about 3 minutes ahead to where I'll be getting into the answer explanations and tips and tricks. All right, nearly half a century ago, Peter Higgs and a handful of other physicists were trying to understand the origin of a basic physical feature, mass. You can think of mass as an object's heft, or a little more precisely as the resistance it offers to having its motion changed. Push on a freight train or a feather to increase its speed, and the resistance you feel reflects its mass. At a microscopic level, the freight train's mass comes from its constituent molecules and atoms, which are themselves built from fundamental particles, electrons and quarks. But where do the masses of these and other fundamental particles come from? When physicists in the 1960s modeled the behavior of these particles using equations rooted in quantum physics, they encountered a puzzle. If they imagined that the particles were all massless, then each term in the equation clicked into a perfectly symmetric pattern, like the tips of a perfect snowflake. And this symmetry was not just mathematically elegant, it explained patterns evident in the experimental data. And here's the puzzle, physicists knew that the particles did have the mass, and when they modified the equations to account for this fact, the mathematical harmony was spoiled. The equations became complex and unwieldy, and worse, still inconsistent. What to do? Here's the idea put forward by Higgs. Don't shove the particles' masses down the throat of the beautiful equations. Instead, keep the equations pristine and symmetric, but consider them operating within a peculiar environment. Imagine that all of the space is uniformly filled with an invisible substance, now called the Higgs field, that exerts a drag force on particles when they accelerate through it. Push on a fundamental particle in an effort to increase its speed, and according to Higgs, you would feel this drag force as a resistance. Justifiably, you would interpret the resistance as the particle's mass. For a mental toehold, I think of a ping pong ball submerged in water. When you push on the ping pong ball, it feels much more massive than it does outside of water. Its interaction with the watery environment has the effect of endowing it with mass. So with particles submerged in the Higgs field, in 1964, Higgs submitted a paper to a prominent physics journal in which he formulated this idea mathematically. The paper was rejected, not because it contained a technical error, but because the premise of an invisible something permeating space, interacting with particles to provide their mass, well, it all just seemed like heaps of overwrought speculation. The editors of the journal deemed it of no obvious relevance to physics, but Higgs persevered, and his revised paper appeared later that year in another journal, and physicists who took the time to study the proposal gradually realized that this idea was a stroke of genius, one that allowed them to have their cake and eat it too. In Higgs' scheme, the fundamental equations can retain their pristine form because the dirty work of providing the particle's mass is relegated to the environment. While I wasn't around to witness the initial rejection of Higgs' proposal in 1964, well, I was around, but only barely, I can attest that by the mid-1980s the assessment had changed. The physics community had, for the most part, fully bought into the idea that there was a Higgs field permeating space. In fact, in a graduate course I took that covered what's known as the standard model of particle physics, the quantum equations physicists have assembled to describe the particles of matter and the dominant forces by which they influence each other, the professor presented the Higgs field with such certainty that for a long while I had no idea it had yet to be established experimentally. On occasion that happens in physics. Mathematical equations can sometimes tell such a convincing tale that they can seemingly radiate reality so strongly that they become entrenched in the vernacular of working physicists, even before there's data to confirm them. All right, let's go ahead and get into question 42. Over the course of the passage, the main focus shifts from what? All right, well, if we think about it, in the beginning of the passage, right, and I'll show you this as well, we talk about the Higgs field, right? It's all about the origins of the Higgs field, what he was studying, and then it gives an explanation of what the Higgs field is. But then as we move on, we talk more about the discipline in physics where it takes a while, like it takes some time, right, for an idea, or not an idea, but I guess kind of an idea, or a hypothesis, right, to be fully established, right, and how the reaction by the scientific community can take time. So if we go ahead and look at our choices for 42, we have A, a technical account of the Higgs field to a description of it aimed at a broad audience. No, because that doesn't take account for our last couple paragraphs. B, a review of Higgs' works to a contextualization of that work within Higgs' era. Also no, because we're not taking into account that last couple paragraphs. C, an explanation. Also, it's not a review of Higgs' work, right? Really, that's the big issue with B, is it's not a review of his work. It's just we're explaining it, right? We're analyzing it. We're not reviewing it. So we can get rid of B. C, an explanation of the Higgs field to a discussion of the response to Higgs theory. Absolutely, right? We're explaining what the Higgs field is and its origins. Then we move on to discuss how it was received by the public with the author's anecdote from his physics class, right? So our answer there is going to be C. And it's not going to be D, an analysis of the Higgs field to suggestion of future discoveries, because we don't suggest any future discoveries. 43, the main purpose of the analogy of the ping pong ball is to what? Okay, whenever you have a scientific essay like this and you're on the reading section and there's a commonplace thing like that, like with this ping pong ball, Understand that it's likely there to explain a more abstract concept in simpler terms, right? So that the average reader can understand that. So that's one big idea that you should really take away from the reading sections, right? You want to make sure you understand that, especially on the science passages. The science passages, that's kind of prevalent. So we're going to say in line 40 is to not popularize a little known fact, but to clarify that abstract scientific concept, right? That's a big theme on the science reading sections that I think you guys should really pay attention to. So make sure that you understand that, right? If you're asked to what the purpose of is an analogy on a science section, and it's describing something in commonplace terms that a normal, commonplace, not a science nerd would understand, right? That's going to be clarifying an abstract concept, right? Or simplifying it for the average person. All right, 44. The author most strongly suggests that the reason the scientific community initially rejected Higgs' idea was that the idea, what? Well, it was not because the math was wrong. The math was correct, but it just didn't have experimental evidence, right? So it appeared to have little empirical basis. We know it's not A because A says addressed a problem unnoticed by other physicists. He was working with other physicists and they all noticed it. B, only worked if the equations were flawless. Well, it did work, right? So we can't say that, right? And then C, it rendered accepted theories in physics obsolete. It did not, right? It was trying to make a solution to these. They didn't even have the theories, right? It was pretty much proposing that theory, right? All right, so now we know that that's D. We're asked for evidence. All right, well, that evidence, right, it's going to be up here. I'll go ahead and find it for you. We've got, but Higgs persevered in his, let's see. It is, okay, right here. All right, so we've got the paper was rejected, right? Not because it contained a technical error, so that's showing it's not because the math had to be flawless or anything, but because the premise of an invisible something permeating space interacting with particles to provide their mass, well, it all just seemed like heaps of overwrought speculation, right? There wasn't that experimental evidence yet. So that's going to be my answer, and that is from 48 to 53. So that's going to be my lines. So I'll go find that in my answer choices. I see that that's answer choice C. All right, 46. The author notes one reason Higgs' theory gained acceptance was what? Well, if you think back to the passage, it said it let scientists have their cake and eat it too. What does that mean? It means it let scientists accept two conditions that had previously seemed irreconcilable. That's what that phrase is doing, right? And our next question asks for evidence. So I'm actually going to find where it says that because I'm confident that that's going to be my answer, right? Unless it doesn't even have those lines. If it doesn't have those lines in one of those A through D answer choices, I would be shocked, right? So I'm going to look at it. I see I have their cake and eat it too, right? Going to 60. So I'd be looking for something from lines, let's see, probably like 55, but Higgs persevered and his revised paper appeared later in a journal, and physicists who took the time to study the proposal gradually realized it was a stroke of genius, one allowed them to have their cake and eat it too. In Higgs' scheme, the fundamental equations can retain their pristine form because the dirty work of providing the particles mass is relegated to the environment, right? So something like 55 to 63, but I would want to make sure it contained this right here, have their cake and eat it too. I want to make sure it has that 59 to 60 for sure, but I'm guessing it's probably 55 to 63. All right, so I'm going to go down, I'm going to look, and I see, yep, it's 55 to 63, so my answer there will be C. Which statement best describes the technique the author uses to advance the main point of the last paragraph? All right, the technique he uses to advance that main point of that last paragraph, let's go find it. Our last paragraph's here. So what technique does he use? Well, he's using his personal anecdote, right? His personal experience. And what is his goal with doing that? Well, his goal with doing that is to explain how mathematical equations sometimes can tell such a convincing tale that they become essentially entrenched in physics, right? So he's describing that discipline in physics where if the math works, eventually it can become accepted, right? And he's doing that through that personal anecdote. And that anecdote, if you don't know what an anecdote is, it's just kind of a personal story or experience, right? So we have A, he accounts personal experience to illustrate a characteristic of the discipline of physics. Yes, right? That discipline is that they will accept that mathematical equation as long as it works, right? But it may take time. And then also, he's using that personal experience, that personal anecdote. So our answer for 48 is A. All right, 49 is using line 77, establish most nearly means. I'm going to go to line 77, underline establish, and come up with my own answer, so I'm not swayed by the answer choices. So we have, the professor presented the Higgs field with such certainty that for a long while I had no idea it had yet to be established experimentally. Established here is meaning proven experimentally, right? So anything like proven experimentally, right? Or confirmed, right? Or validated, right? That's another great one. Validated will be our answer there, right? Validated experimentally is the same as proven experimentally or established experimentally, right? Not founded, not introduced, or enacted, right? Question 50, what purpose does the graph serve in relation to the passage as a whole? Let's look at the graph. All right, we've got years from introduction of concept of particle to experimental confirmation. We've got our years on our x-axis, and we have our names of different particles on our y-axis. So what this is doing is it's showing how the Higgs boson, right, it took so much longer from when it was introduced to get confirmed than all these others. So that's what it's really doing. It's putting that length of time in context, right? It indicates, we'll read through our answer choices. A, it indicates the scientific community's quick acceptance of the Higgs boson was typical. Absolutely not. It wasn't a quick acceptance. B, it places the discussion of the reception of the Higgs boson into a broader scientific context. Absolutely, right? It's showing how long it took these other similar particles to get confirmed, right? So our answer there is going to be B. All right, question 51. Which statement is best supported by the data presented in the graph? We're just going to have to go through these A through D, right? So you got W boson and Z boson were proposed and experimentally confirmed at about the same time. Go ahead and look at that, and we see that they are, right? They're each proposed right there, and they're each confirmed right there. So that'll be our answer. And just in my personal experience, going through these practice tests, one thing I've noticed is when we're asked for statements supported by the data presented in the graph like this, and you're just given 4 statements and you don't have anything to go on in the prompt, I've noticed that it seems, and I haven't done the math, but it seems that most of the time the answer choices are in the beginning, right? So they're closer to A or B or C than they are to D. Just an observation, right? I'm not saying that that's mathematically true on all the practice tests because I haven't done the math, but it just seems like that to me. 52, based on the graph, the author's depiction of Higgs theory in the mid-1980s is most analogous to which hypothetical situation? All right, well, if we look at his description of it in the mid-1980s, let's see where we are. All right, right here. It talks about how in the mid-1980s, right, the assessment had changed. The physics community had, for the most part, fully bought into that idea of the Higgs field, right? But if we look at our graph, it's showing us that in the mid-80s, right, it still hadn't been confirmed. So we'd be looking for a situation where something is accepted but hasn't been confirmed yet, but it's accepted and used by scientists. So we got A, the muon neutral was widely disputed until being confirmed. No, we're looking for where it's accepted before confirmation. B, few scientists in 2012 doubted the reality of the tau neutrino. That doesn't fit. C, no physicists prior to 1960 considered the possibility of W or Z boson. No. D, most physicists in 1940 believed in the existence of the electron neutrino. We know that'll be answered by default, but I'll go ahead and support that by showing you. So it says in 1940 they believed in the existence of electron neutrino. We see that's before confirmation, right? Just like in the Higgs boson. So that supports D as our answer, right? If you just wanted me to show you why, right? So that'll be D right there. This passage is adapted from Rachel Ehrenberg, Salt Stretches in Nanoworld, published in 2009 by Society for Science and the Public. The nanoworld is the world observed on a scale 1/1000th that of ordinary human experience. All right, now I'm going to read the passage. If you've already read the passage, you can go ahead and skip about 3 minutes ahead to where I get into the answers. All right, inflexible old salt becomes a softie in the nanoworld, stretching like taffy to more than twice its length, researchers report. The findings may lead to new approaches for making nanowires that could end up in solar cells or electronic circuits. The work also suggests that these ultra-tiny salt wires may already exist in sea spray and large underground salt deposits. We think nanowires are special and go to great lengths to make them, says study co-author Nathan Moore of Sandia National Laboratories in Albuquerque. Maybe they are more common than we think. Metals such as gold or lead, in which bonding angles are loosey-goosey, can stretch out at temperatures well below their melting points. But scientists don't expect the superplasticity in a rigid, crystalline material like salt, Moore says. This unusual behavior highlights that different forces rule the nano world, says theoretical physicist Krzysztof Kempa of Boston College. Forget about gravity, it plays no role, he says. Surface tension and electrostatic forces are much more important at this scale. Moore and his colleagues discovered salt stretchiness accidentally. They were investigating how water sticks to a surface such as salt and created a super dry salt sample for testing. After cleaving a chunk of salt about the size of a sugar cube with a razor, the scientists guided a microscope that detects forces toward the surface. When the tip was far away, there was no measured force, but within about 7 nanometers, a very strong attraction rapidly developed between the diamond tip of the microscope and the salt. The salt was actually stretched out to glom on the microscope tip. Using an electron microscope to see what was happening, the researchers observed the nanowires. The initial attraction between the tip and the salt might be due to electrostatic forces, perhaps good old van der Waals interactions. The researchers speculate several mechanisms might lead to the elasticity, including the excess surface tension that found in the nanoworld, the same surface tension that allows a water strider to skim the surface of a pond. The surface tension is so strong that as the microscope pulls away from the salt stretches, Kempa says. The inside has no choice but to rearrange the atoms, rather than break. He says, this bizarre behavior is actually mirrored in the macro world, the researchers say. Huge underground deposits of salt can bend like plastic, but water is believed to play a role at these scales. Perhaps salty nanowires are present in these deposits as well. Sodium chloride is everywhere, in the air and our bodies, Moore says. This may change our view of things, of what's happening at the nanoscale. The work also suggests new techniques for making nanowires, which are often created through nanoimprinting techniques, Kempa says. We invoke the intuition of the macro world, he says. Maybe instead of stamping nanowires, we should be nanopulling them. All right, we can go ahead and get into the questions. I see I have a little graph there, so I'll probably have to refer to that on one of the last questions for this passage. So question 22. One central idea of the passage is what? All right, well, let's go ahead and go through our answer choices, or we'll come up with our own answer real quick. So a central idea of this passage, right, is about how this material, right, the salt, is now being able to stretch so far more than was ever expected, or than was initially expected. And it was kind of discovered accidentally, so it's not like they set out to do this, but it's kind of a surprise of how this material, this salt, can stretch out so far, and it's a big shock to this nano world, right? So we look at our answer choices. We have A, sometimes materials behave contrary to expectations. Yes, right, that salt, they didn't expect it to be able to do that because it was a crystalline, right? And crystallines generally don't stretch like that at the nano level. So they did not expect that to happen, right? But it did. So sometimes that material, that salt, behaves contrary to expectations, yes. We know B is incorrect because it says systems can be described in terms of inputs and outputs, and we don't describe inputs and outputs. C is incorrect because it says models of materials have both strengths and weaknesses. We don't discuss the strengths or weaknesses of the materials. And then D, or of the models of materials, all right, of their models that, would display their chemical elements and all of that. D is incorrect because it says properties of systems differ from the properties of their parts. Now here's why this is wrong. You may be initially tempted to pick this, but no, it's not correct because here's why. You may think, oh, well, at the nano level salt can stretch, but at the macro level it can't. But we actually say in the passage, at the macro level, we have observed salt stretching like that. So that's why D is incorrect as well. Question 23. Which choice best describes the overall structure of the passage? All right, well, we see in our passage, right, we begin, right, by describing this salt, or we'll go back and we'll go ahead and take a look at it. So in the beginning, we talk about how inflexible old salt becomes a softy in the nano world. So how we get a change in expectations, right? At the nano level, we didn't think that it'd be able to be flexible, right? But it is. It stretches to more than twice its length, right? So we begin with that. Then we get into how it was discovered, right? That accidental discovery with that diamond tip microscope. And then after that, we get into potential applications of it, right? And like what the meaning of all this is, or what the meaning of this discovery is, and how it can be used. So we got A, a list of several ways in which salt properties differ from researchers' expectations. No, we don't make a list of several ways. Also, that doesn't include how it was discovered. A presentation of a hypothesis. We don't start with a hypothesis, right? So we can go ahead and get rid of B. C, a description of two salt crystal experiments, the apparent disagreement. We don't have a disagreement, and we don't have two salt crystal experiments. D, an introduction to an interesting salt property, right? That is stretchy. And then a description of its discovery, that it was an accidental discovery, and then speculation about its application for use in electronic components and such. So our answer is D. Which choice provides the best evidence for the claim that Moore's group was surprised to observe salt stretching? That's going to be when they talk about it as a crystallite, right? When it talks about it as a crystallite, so they wouldn't expect this to occur. So we're going to find right here, or a crystalline material, right? But scientists don't expect this superplasticity in a rigid crystalline material like salt, Moore says. So we see that that is going to be from 17 to 18. That's going to be my evidence lines. Find that, and I see that that's an answer choice A. So A will be my answer for 24. As used in line 20, rule most nearly means. I'm going to go find line 20. I'm going to underline the word rule, and then I'm going to try and find what it most nearly means. This unusual behavior highlights that different forces rule the nano world, says theoretical physicist. All right, well, this means that different forces control the nano world, right? Or govern, right? They control the nano world is going to be the best choice. Govern, I mean, I wouldn't really make that my first choice, but it could be a backup choice. I would strongly say control here. So now I'm going to go look at my answer choices, see what we got. We do have control, so that'll be my answer. We're not going to say that these forces mark the nano world or declare the nano world or restrain the nano world, right? But they do control the nano world. All right. 26. According to the passage, researchers have identified which mechanism as potentially responsible for the initial attraction between the microscope tip and the salt. All right, well, if we remember back, it suggests that it was van der Waals interactions. The surface tension is talking about a different thing, right? And I'll go show you that real quick. When we go back up here, we see the initial attraction between the tip and salt might be due to electrostatic forces, perhaps good old van der Waals interactions, right? So it's suggesting that could be responsible for our attraction there. Right, where you would mess up is if you took this surface tension from this sentence here when we talk about how the several mechanisms might lead to the elasticity, right? All right, now we can go and move on to our next question. We see that we are on, where are we? We've got question 27. As used in line 42, lead to most nearly means. Go find lead to. We've got it right here, okay. Several mechanisms might lead to the elasticity, including the excessive surface tension found in the nano world. All right, well, several mechanisms then, right, might result in this elasticity or might cause it. So my two answers here, my backup's going to be cause, first one's going to be result in, right? So I'm looking for really result in. If that's not there, cause would be my second choice here, right? Because we have several mechanisms might result in this elasticity or cause this elasticity, right? But preferably result in would be a better choice in my opinion. So I'm going to go look for those. I see I do have result in, I don't have cause, right? We're not going to say that these several mechanisms might guide to or point toward or start with, right? They're going to result in that surface tension or whatever it was talking about. Let's see. That will result in the elasticity. Yep. Okay. Yep. So we've got question 28 now. Based on the passage, which choice best describes the relationship between salt behavior in the nano world and in the macro world? Well, if we remember in the macro world, do we have to provide evidence? Yes, we do. Okay. So I can go ahead and give that to you anyways. All right, well, I know, I'll go ahead and answer the claim real quick first. We know that in both the nano world and the macro world, salt is flexible, so our answer is going to be A, right? And I'll go ahead and show you my evidence for that. All right, it's where they talk about the big salt things, right, and then the water, and it makes them flexible. Try to find where that is real quick. All right, let's see. Perhaps salty nanowires, more nano. Let's see here. It is going to be... Okay, here it is. Huge underground deposits of salt can bend like plastic, but water is believed to play a role at these scales, right? That's talking about how in the macro world, it also can bend like plastic. And that's from 51 then to that 53. That's going to be my answer there. All right, let's see. There it is. Answer choice D for 29. All right, now we are on question 30. According to the information in the graph, when the microscope tip is moving away, so we're looking at the graph, it's moving away from the salt surface and is 15 nanometers from the surface. What's the approximate force on the microscope tip in micronewtons? All right, I'm going to go to my graph. I have to use the one where it's moving away and then look at 15 nanometers. We see I'm moving away from the salt surface. I'm asked for the force on the tip in micronewtons at that point. I see that's about 0.75. So my answer there will be choice C. All right, question 31. Based on the passage and graph, which label on the graph indicates the point at which a salt nanowire breaks? All right, well, when it breaks, there's going to be no more force, right? And it's only going to break after it's connected. So that's going to be when it's moving away from the graph, or when it's moving away from the salt, right? So the tip's moving away from the salt. It's going to break. There will no longer be that force on that tip, which is where it's going to equal 0, right? So that's going to tell me my answer there is going to be T. So I'm going to go find T. I see that that is answer choice D, so my answer choice will be D. All right, we have answered all of them for that section, or that passage. This passage is adopted from Daniel Kamovitz' What a Plant Knows, A Field Guide to the Senses, published in 2012 by Daniel Kamovitz. The Venus flytrap, Dianae muscipula, needs to know when an ideal meal is crawling across its leaves. Closing its trap requires a huge expense of energy, and reopening the trap can take several hours. So Dione A only wants to spring closed when it's sure that the dawdling insect visiting its surface is large enough to be worth its time. The large black hairs on their lobes allow the Venus flytraps to literally feel their prey, and they act as triggers that spring the trap closed when the proper prey makes its way across the trap. If the insect touches just one hair, the trap will not spring shut, but a large enough bug will likely touch 2 hairs within about 20 seconds. And that signal springs the Venus flytrap into action. We can look at this system as analogous to short-term memory. First, the flytrap encodes the information, forms the memory. that something it doesn't know what has touched one of its hairs. Then it stores this information for a number of seconds, retains the memory, and finally retrieves this information, recalls the memory, once a second hair is touched. If a small ant takes a while to get from one hair to the next, the trap will have forgotten the first touch by the time the ant brushes up against the next hair. In other words, it loses the storage of the information, doesn't close, and the ant happily meanders on. How does the plant encode and store the information from the unassuming bug's encounter with the first hair? How does it remember the first touch in order to react upon the second? Scientists have been puzzled by these questions ever since John Burton Sanderson's early report on the physiology of the Venus flytrap in 1882. A century later, Dieter Hodek and Andreas Sievers at the University of Bonn in Germany proposed that the flytrap stored information regarding how many hairs have been touched in the electric charge of its leaf. Their model is quite elegant in its simplicity. In their studies, they discovered that touching a trigger hair on the Venus flytrap causes an electric action potential, a temporary reversal in the electrical polarity of a cell membrane. That induces calcium channels to open in the trap. This coupling of action potentials and the opening of calcium channels is similar to the process that occurred during communications between human neurons, thus causing a rapid increase in the concentration of calcium ions. They propose that the trap requires a relatively high concentration of calcium in order to close, and that a single action potential from just one trigger hair being touched does not reach this level. Therefore, a second hair needs to be stimulated to push the calcium concentration over this threshold and spring the trap. The encoding of the information requires maintaining a high enough level of calcium so that a second increase triggered by touching the second hair pushes the total concentration of calcium over the threshold. As the calcium ion concentrations dissipate over time, if the second touch and potential don't happen quickly, the final concentration after the second trigger won't be high enough to close the trap, and the memory is lost. Subsequent research supports this model. Alexander Volkoff and his colleagues at Oakwood University in Alabama first demonstrated that it is indeed electricity that causes the Venus flytrap to close. To test the model, they rigged up very fine electrodes and applied electrical current to the open lobes of the trap. This made the trap close without any direct without any direct touch to its trigger hairs. While they didn't measure calcium levels, the current likely led to increases. When they modified this experiment by altering the amount of electrical current, Volkov could determine the exact electrical charge needed for a trap to close. As long as 14 microcoulombs, a tiny bit more than the static electricity generated by rubbing two balloons together, flowed between the two electrodes, the trap closed. This could come as one large burst or as a series of smaller charges within 20 seconds. If it took longer than 20 seconds to accumulate the total charge, the trap would remain open. All right, now we can get into the questions. We have question 42. The primary purpose of the passage is to what? All right, well, the primary purpose here is to discuss the Venus flytrap, right, and its closing action, giving all the scientific explanation behind it, right? So if we look at 42, we have choice A, discuss findings that offer a scientific explanation for the Venus flytrap's closing action. Yes, right, that's what our findings are all about. It's all about discussing the scientific explanation for why the Venus flytrap closes the way it does. We look at B, present research that suggests the Venus flytrap's predatory behavior is both complex and unique among plants. We don't discuss whether it's unique among plants. We don't know if other plants have it, right? I mean, I'm sure scientifically we do, but it's never discussed, so we can't pick that as an answer. C, identify the process by which the Venus flytrap's closing action has evolved. Okay, this is the key part as to why this is wrong. We don't discuss the evolution of the flytrap's mechanism for closing. So we can get rid of C. D, provide a brief overview of the Venus flytrap and its predatory behavior. We don't discuss its predatory behavior outside of it being, right, it just closing its thing, right? It's all about offering our scientific explanation for the closing action. 43, based on the passage, a significant advantage of the Venus flytrap's requirements for multiple triggers is what? Well, the reason it has multiple triggers is so that it doesn't close too early and waste its energy, right? So it's going to safeguard that plant's energy supply, because if it didn't have that multiple triggers, it could close and miss the insect or whatever, and it has to wait another 6 hours, and it wasted all that energy, right, and it's closing. So our answer there is going to be C, safeguard this plant's energy supply. We're asked for evidence, right? I know that was in the beginning, so I'm going to go look there. It specifically talks about the energy that it takes. We see in line 3, closing its trap requires a huge expense of energy, and reopening the trap can take several hours. So Dionaea only wants to spring close when it's sure the dawdling insect visiting the surface is large enough to be worth its time. So we see that that's 3 to 7, and that's explaining why it doesn't want to waste that energy. So our answer will be A for question 44. 45, the use of the phrases dawdling insect in line 6 happily meanders in line 27 and unassuming bugs encounter in 28 to 29. And the first two paragraphs establishes a tone that is what? Well, I'll go ahead and go there, right, just to show you guys. So we got line 6, dawdling insect. It only wants to spring clothes when it's sure the dawdling insect, right, visiting its surface is large enough to be worth its time. Well, this is kind of informal, right? Let's think about this. This is a scientific article, right? Science. So we should be using formal words, but this is not, right? Saying a dawdling insect, we don't really describe insects as dawdling if we're writing a scientific paper, if that makes sense. We don't have to describe, right? Like, you don't have to use adjectives like that, right? So that's kind of informal for this type of piece. I know we had another one from right here, line 28 and 27, right? So how does the plant encode and store the information from the unassuming bug's encounter with the first hair? We don't need to know that it's an unassuming bug, right? That's kind of informal again. We don't need that. It's not really scientific. So that's creating that informal tone, right? And then our last one, I think, was in line 10. Trap closed when the proper, no, it wasn't in line 10. Let's see. Line 27 and 28 and 29. Okay, so happily meanders, right? And the ant happily meanders on. We would never say an ant happily meanders on if we were trying to establish a formal tone, really. So that's kind of, once again, going back to that informal tone. We know it's not melodramatic because that just means overdramatic if you didn't know what that means, and it's not overdramatic. Academic, right? That's not academic, it's informal. Mocking, no, we're not mocking anything. That's kind of a terrible answer choice. So don't pick D, pick C. C is correct. All right, question 46. In the second paragraph, lines 15 to 31, the discussion of short-term memory primarily functions to what? Well, if we think back, it was in probably line 15 or 16, right? It said that it was analogous to the short-term memory, right? When we say something's analogous to something and then we explain the comparison between the two, what we're doing is we're kind of clarifying our term, right? So we're using that analogy of it to the short-term memory to clarify an explanation of what prompts the Venus flytrap to close. So our answer is going to be A, right? And I'll just go quick show you guys that where it says that it's analogous. Well, right here, we can look at the system as analogous to short-term memory, right? And then we describe the two things alongside each other. So our answer for 46 is going to be A. It's not going to be B, advance a controversial hypothesis, because we don't have one. C, stress the distinction between the strategies of the Venus flytrap and the strategies of human beings. That's too vague. Strategies of what, right? And also, it's just not even accurate as far as what happened in the text. D, emphasize the Venus flytrap's capacity for retaining detailed information about its prey. No, that's not why we did that. We did that to help clarify the explanation of what prompts the Venus flytrap to close. Question 47. According to the passage, which statement best explains why the Venus flytrap requires a second trigger hair to be touched within a short amount of time in order for its trap to close? That's so it doesn't waste its energy, right? It needs that second trigger hair, so that way it knows its prey is large enough and not moving fast enough, so it won't miss it and it will get a big meal. So we have the choices: A, the second trigger. Okay, so it looks like we're talking more about the scientific part here. What it said back there, and I'm guessing we have evidence for 48 as well. We don't? Okay. So 47, what it was saying back there is it was saying that that second trigger hair, right, releases that second part of that calcium concentration that puts it above the threshold for it to close. So our answer for 47 is going to be D. That second trigger provides a necessary supplement to the calcium concentration released by that first trigger. And I'll quickly go show you guys the evidence for that. Let me find it. All right, right here. The encoding of the information requires a high enough level of calcium so that a second increase triggered by touching the second hair pushes the total concentration of calcium over the threshold. So that would be evidence if they asked for it, but they don't. So I was just showing you that to prove my point. 48, which choice describes a scenario in which Rhodea and Saver's model predicts that a Venus flytrap will not close around an insect? All right, will not close. So I'm giving examples. I'm just going to read through them. A large insect's second contact with the plant's trigger hair results in a total calcium ion concentration above the plant's threshold. That means that it will close, right? And we're asked for will not, so we can get rid of A because it will close. B, a large insect makes contact with a second trigger hair after a period of inactivity during which calcium ion concentrations have diminished appreciably. This means since it was inactive, calcium ion concentrations have gone down, which means that second trigger hair won't push it above that threshold. So we know B will be our answer and it will not close. In that situation, we can get rid of C and D. As used in line 67, demonstrated most nearly means. I'm going to go to 67. I'm going to underline it, come up with my own answer before I look at my answer choices so I'm not swayed. Subsequent research supports this model. Alexander Volkov and his colleagues at Oakwood University in Alabama first demonstrated that it is indeed electricity that causes Venus flytrap to close. All right, another word we could use here would be established or first showed or proved. Primarily, though, I'm looking for first proved or established would be my two top choices there. So I'm going to go down, I'm going to look at my answer choices. I don't have proved, but I do have established, right? It's not going to be protested because this demonstrated here is pretty much saying that they proved that this happens, right? They established it happens, right? Not performed and not argued. It's not an opinion, so it's not going to be argued, and it's not performed, so not performing anything. Definitely not protested. All right, so B is going to be the answer for 49. Question 50. Based on the passage, what potential criticism might be made of Volkov's testing of Hodek and Siever's model? All right, what jumped out to me as I read it was that it said, I'll go ahead and show you guys, and it might be asking for evidence, I don't know. So just in case it is, I'll find the lines as well. Let's see where it is. So it was right here, right? So an important part of, let's see what their names were. An important part of Hodek and Siever's model, right, was about the, let's see where it is, the calcium channels, right, and the calcium concentration, calcium levels right here, right? So while they didn't measure calcium levels, the current likely led to increases in calcium levels, but they didn't measure them. So that would be my big thing I'm looking at there. I see that that's going to be lines 71 to 74. So that would be my evidence if they ask for it, which I'm guessing they will. Let's see here. Okay, they do ask for evidence, and now I'm going to go ahead and circle my answer, right? So my answer here is, the main criticism here is that they didn't do anything with the calcium levels. So we have A, Volkov's understanding of Hodek and Siever's model was incorrect. No. B, Volkov's measurement did not corroborate a central element of Hodek and Siever's model. Yes, that calcium level. It didn't measure that. So that's going to be B, right? And then we already answered C for 51. 52, based on the passage in studying the Venus flytrap, Volkov and his colleagues made the most extensive use of which type of evidence? That's going to be the data that they got, right? The data by using all those electric currents and then measuring the Venus flytrap's response. So choice A says mathematical models to predict the electrical charge. Required to close the Venus flytrap? No, they didn't really use mathematical models, right? It was just kind of taking that data and analyzing it from the work where they use the different electrical currents, right? So we have B, analysis of data collected from previous researchers' work involving the flytrap's response to electricity. That is also incorrect because it was their research, right? Not previous researchers. We can get rid of that. C, information obtained from monitoring the Venus flytrap's response to varying amounts of electrical current. Yes, right? It was their own little experiment, their own data, right? And it was all about the flytrap's response to the varying amounts of electrical current to find what was the threshold current. So our answer there is going to be C. This passage is adopted from Marlene Zuk, Paleo Fantasy, What Evolution Really Tells Us About Sex, Diet, and How We Live, written in 2013 by Marlene Zuk. A female guppy can be sexually mature at 2 months of age and have her first babies just a month later. This unstinting rate of reproduction makes guppies ideally suited for studying the rate of evolution, and David Resnick, a biologist at UC Riverside, has been doing exactly that for the last few decades. People usually think of guppies as colorful aquarium fish, but they also have a life in the real world, inhabiting streams and rivers in tropical places like Trinidad, where Resnick has done his fieldwork. Guppies can experience different kinds of conditions depending on the luck of the draw. A lucky guppy is born above a waterfall or a set of rapids which keep out the predatory fish called pike cichlid, found in calmer downstream waters. As you might expect, the guppy mortality rate, that is, the proportion of individuals that die, is much higher in sites with rapacious cichlids than in those without them. Resnick has shown that if you bring the fish into the lab and let them breed there, the guppies from the sites with many predators become sexually mature when they are younger and smaller than do guppies from the predator-free sites. In addition, the litters of baby guppies produced by mothers from the high-risk streams are larger, but each individual baby is smaller than those produced by their counterparts. The disparity makes sense because if you are at risk of being eaten, being able to have babies sooner and spreading your energy reserves over a lot of them makes it more likely that you will manage to pass on some of your genes before you meet your fate. Resnick and other scientists also demonstrated that these traits are controlled by the guppy's genes, not by the environment in which they grow up. How quickly, though, could these differences and how the two kinds of guppies lived their lives have evolved? Because there are numerous tributaries of the streams in Trinidad, with guppies living in some but not all of them, Resnick realized that he could, as he put it in a 2008 paper, treat streams like giant test tubes by introducing guppies or predators to places they had not originally occurred, and then watch as natural selection acted on the guppies. This kind of real-world manipulation of nature is called experimental evolution, and it is growing increasingly popular among scientists working with organisms that reproduce quickly enough for humans to be able to see the outcome within our lifetimes. Along with his students and colleagues, Resnick removed groups of guppies from their predator-ridden lives below the waterfall and released them into previously guppy-free streams above the falls. Although small predatory killfish occurred in these new sites, these fish do not pose anything close to the danger of the kitchlids. Then the scientists waited for nature to do its work, and they brought the descendants of the transplanted fish back to the lab to examine their reproduction. After just 11 years, the guppies released and the new streams had evolved to mature later and have fewer, bigger offspring in each litter, just like the guppies that naturally occurred in the kitchlid-free streams. Other studies of guppies in Trinidad have shown evolutionary change in as few as 2.5 years, or a little over 4 generations, with more time required for genetic shifts and traits such as the ability to form schools and less time for changes in the colorful spots and stripes on a male's body. All right, now we've got 2 graphs, but we can go ahead and get into question 21. The first paragraph mainly serves to what? Well, if we go back to the first paragraph, we see that it says a female guppy can be sexually mature at 2 months of age and have their babies just a month later. This rate of reproduction makes guppies ideally suited for studying the rate of evolution, right? So we're describing why that organism is useful in the study. So we've got A, establish the reason why a certain species was selected for scientific observation, and that right there is going to be our answer. So our answer for 21 will be A. All right, and we can see B is incorrect because illustrate the value of studying the offspring of a particular animal shortly after birth. We're not studying an offspring shortly after birth. Introduce a theory at the center of an ongoing debate. That's not what it talks about. And then D, offer a rationale for the prevalence of a new field of scientific inquiry. There's no new field that we're talking about, so we can get rid of D. All right, question 22. In describing the living conditions of guppies, the author indicates that a lucky guppy in line 14 is one that is what? Well, that's one that has no natural predators, right? It doesn't have any in its environment. So it's going to be B, it inhabits an environment that provides natural protection from its predators, right? Those that live above the falls have natural protection from those kitchlids, which are the major predators. So our answer for 22 will be B, right? And then we can get rid of C, D, and A, right? And then question 23, which choice provides the best evidence for the conclusion that the streams used by Resnick's team in their real-world study were not entirely free of predators? So that means that there are predators there. And if we go back, we remember in lines 57 to 59, and I'll take you there, that there are other predators. They just don't pose anything close to the danger of the kitchlids. So we see that we have that here. We have, although small predatory killfish occurred in these new sites, so there were predators, these fish do not pose anything close to the danger of the kitchlids. So we know our answer then will be lines 57 to lines 59, lines 59. So we'll go down, we'll find our answer choice there. We see that that's D. All right, next we got question 24. In lines 43 to 44, Resnick uses the phrase giant test tubes to suggest what? Well, that's going to be to suggest that certain streams can what? All right, well, giant test tubes to suggest certain streams can provide suitable environmental conditions, promote cooperative behaviors in specimens. No, the streams aren't providing cooperative behaviors in specimens, right? And then C, expedite the rate of genetic changes. He never says that. Solve widespread environmental problems. Nope. Get rid of C and D. We know it's A, right? It provides suitable experimental conditions, right? Those natural test tubes are providing the suitable experimental conditions for his experiment. And then we have 25, as used in line 49, popular most nearly means. Well, we're going to go to line 49. We're going to circle popular, and then we're going to read the sentence and find what word it most nearly means. So we have this kind of real-world manipulation of a nature is called experimental evolution, and it is growing increasingly popular among scientists working with organisms that reproduce quickly enough for humans to be able to see the outcome within our lifetimes. All right, well, it's growing increasingly popular, right? Growing increasingly widespread. More scientists are using it, right? So it's growing increasingly widespread among scientists. As we go down, we see we do have widespread. Let's say we didn't come up with widespread when we were coming up with our own answer. We came up with something else. Well, then we'd see we have A, right? It's becoming increasingly accessible. No, it was always accessible, right? There was no change in geography that caused it to be now accessible when it wasn't. Suitable? Well, there's nothing that, once again, there's nothing that would have changed, right, that would make it now increasingly more suitable, right? There's no geographical changes where it's now more suitable. And then it's grown increasingly more likable among scientists. That would be a terrible word to use, right? This is an academic paper. We're not going to use likable. Honestly, I'm not even sure. I mean, likable probably is a word, but I mean, it's really not one that we'd use in a scientific setting like this, right? It doesn't, when he says that it's growing increasingly popular, he's talking about the quantity that it's used, right? It's used more often, it's more widespread. It's increasingly widespread. Question 26. Which finding, if accurate, would undermine his findings? A. Guppies examined in other parts of the globe exhibit genetic shifts and traits at a different rate from that exhibited by the guppies Resnick examined. That would not undermine his findings, right? If guppies examined in other parts of the globe, those could have some different genetics, right? Some slightly different genetic changes that could cause their shifts, right? That could cause their genetic shifts and traits to happen at a slightly different rate. Also, depending on the amount of predators, right? If there's way more in one versus another, right? There's a lot of different things, right? And then we have B, the new site into which Resnick released the guppies is inhabited by fish that are found to be as predatory as the cichlids in the original sites. That would, right? That would undermine his findings because then there would be no difference between those two sites, right? So that would most certainly undermine his findings. We know our answer there will be B. All right, now we got question 27. It can most reasonably be inferred from the passage that the experiments in Trinidad have shown which of the following about guppies. Some genetic traits will evolve more readily than others. Yes, and we have to find evidence for that in 28 anyway, so I'll go ahead and show you guys why this is correct. Well, if we look at the end, what we remember is that it said in our last couple sentences, other studies in Trinidad have shown evolutionary change in as few as 2.5 years, over as little as 4 generations, with more time required for genetic shifts and traits such as the ability to form schools and less time for changes in colorful spots and stripes on a male's body. So that's showing that those genetic shifts can occur at different rates for different traits. Right, so we know our answer there is going to be D for our evidence, 67 to 62, and we know that our answer for 27 will be A. All right, so now we can go and move on to question 29. According to figure 1, guppies living in the south slope high predation environment produced a mean number of offspring between what? So we go to figure 1, south slope high predation. South slope high predation is going to be this graph here. They produced a mean number of offspring between 6 and 7 is what we see there. So our answer will be D for that one. Now we got question 30. Which conclusion about the mean mass of guppy embryos is best supported by figure 2? So we go find figure 2. All right, what's the best conclusion? Well, I see that in my low predation environments, I have a higher mean embryo mass, right? See this higher mean embryo mass than those in high predation environments. All right, so we know that our mean embryo mass is going to be higher in our low predation environments. So we can go find that answer. We've got the slope was a better indication of mean embryo mass than predation level. No. The mean embryo mass born in the north slope exceeded the mean in the south slope. No, those weren't really what we were looking for. C, the predation level observed in each environment had more of an effect on mean embryo mass than did slope location. Yes, the predation level was what caused those big differences in the graph, right? This versus this, right? That had to do with predation level, not which slope they were found in. All right, now we've got question 31. The data presented in the figures 1 and 2 best support the conclusion that compared with guppies from high predation environments, guppies from low predation environments were more likely to what? Well, guppies in the low predation environments, we remember, they were more likely, and I'll go ahead and show you in the data too. So low predation environments, we have here and here, right? So these ones right here, we see that they have a lower number of offspring, but then we also see that they have higher mean embryo mass, right? So they're likely to be larger, but have a lower number of offspring. So those from the low predation environment are likely to have fewer offspring and reach full maturity sooner. No, we don't talk about full maturity. B, be part of a smaller litter, yes, and have a greater mean embryo mass, yes. So our answer for 31 will be B. All right. Passage 1 is adopted from Brian Handwork, a new antibiotic found in dirt can kill drug-resistant bacteria, written in 2015 by the Smithsonian Institute, or that's where it was published. Passage 2 is adopted from David Livermore. This new antibiotic is cause for celebration and caution, and it was published in 2015 by Telegraph Media Group Limited. All right, passage 1. Pathogens are acquiring resistance faster than we can introduce new antibiotics, and this is causing a human health crisis, says biochemist Kim Lewis of Northeastern University. Lewis is part of a team that recently unveiled a promising antibiotic born from a new way to tap the powers of soil microorganisms. In animal tests, Tioxobactin proved effective at killing off a wide variety of disease-causing bacteria, even those that had developed immunity to other drugs. The scientists' best efforts to create mutant bacteria with resistance to the drug failed, meaning Tioxobactin could function effectively for decades before pathogens naturally evolved to resist it. Natural microbial substances from soil bacteria and fungi have been at the root of most antibiotic drug development during the past century. Not only about 1% of these organisms can be grown in a lab, The rest, in staggering numbers, have remained uncultured and of limited use to medical science until now. Instead of trying to figure out the ideal conditions for each and every one of the millions of microorganisms out there in the environment, or millions of organisms out there in the environment, to allow them to grow in the lab, we simply grow them in their natural environments where they already have the conditions they need for growth, Lewis says. To do this, the team designed a gadget that sandwiches a soil sample between two membranes, each perforated with pores that allow molecules like nutrients to diffuse through but don't allow the passage of cells. We just use it to trick the bacteria into thinking that they are in their natural environment, Lewis says. The team isolated 10,000 strains of uncultured soil bacteria and prepared extracts from them that could be tested against nasty pathogenic bacteria. Tioxobactin emerged as the most promising drug. Mice infected with bacteria that cause upper respiratory tract infections, including Staphylococcus aureus and Streptococcus pneumoniae, were treated with tioxobactin, and the drug knocked out the infections with no noticeable toxic effects. It's likely that tioxobactin is effective because of the way it targets disease. The drug breaks down the bacterial cell walls by attacking the lipid molecules that the cells create organically. Many other antibiotics target the bacteria's proteins, and the genes that encode those proteins can mutate to produce different structures. All right, so I'm going to go ahead and answer the questions that are in the beginning on passage 1, and then I'll read passage 2 once I need to. All right, the first paragraph of passage 1 primarily serves to what? Well, if we go to the first paragraph of passage 1, we see that it says, pathogens are acquiring resistance faster than we can introduce new antibiotics, and this is causing a human health crisis, right? So if we go down and we look at our options, we have present a claim that's supported and developed over the course of a passage. Nope. Introduce a controversy. We're not introducing a controversy, right? What we are doing is we're identifying a problem, right? A human health crisis is what it says, right? The bacteria are evolving or mutating faster than we can find new bacteria to treat diseases, right? So that's going to be our identifying a problem. We say it's a human health crisis that the research discussed in the passage may help to address, right? This new research shows that we can now find new treatments faster, right? And these new treatments are going to work better. So our answer there is going to be C. The author of passage 1 suggests that an advantage of the method Lewis's team used to grow microorganisms is that what? Well, the big advantage, right? The big advantage of the way that they used to grow microorganisms is that they were now able to tap into all these other organisms, right? So we have A, identifies the requirements for soil bacteria to thrive and replicates those features in artificial soil, or B, enables soil bacteria to take in more nutrients. No, right? We are only taking in the same amount, it said, right? Through those pores that don't let cells go in, though. C, directly affect the cell walls of bacteria rather than the proteins those bacteria produce. Well, that's not the advantage used to grow them, right? That's not the advantage used to grow them. That's how it's attacking, right? It attacks the cell walls of bacteria rather than the proteins. And then D, allows researchers to make use of soil bacteria that they had been previously unable to exploit. Yep, they previously weren't able to take out a lot of those bacteria, right? Because it was just too hard to get them to grow. But now with this new method, they can make use of soil bacteria that they weren't able to before. And we know that A is wrong because it says identifies the requirements for soil bacteria to thrive and replicates those in artificial soil. But what they aren't doing actually is they're not identifying these requirements for soil bacteria. They're letting those requirements, quote unquote, that nature has already provided, right? Nature's already fulfilling those requirements. So they're not actually replicating those on themselves in artificial soil. They're taking the soil, right? So it's not artificial soil. They're taking that soil out from the ground. And that's allowing them to get the soil that they were previously unable to exploit. Now, where's our evidence for this? Well, right off the bat, when I see but only, and then I see now, I'm thinking, okay, we're contrasting what happened in the past by saying but only, and then now we're talking about what's happening in the future. Now we can harvest more samples, right? So I'm going to go ahead and look at 17 to 21. Starting at but only about 1% of these organisms can be grown in a lab. The rest, in staggering numbers, have remained uncultured and of limited use to medical science until now. So now they are of use, right? Now we can harvest them. So that's going to be my answer there. So that'll be choice A. All right, now we've got 46. I see I have passage 2, so I'm going to go read passage 2. Many good antibiotic families, penicillin, streptomycin, tetracycline, come from soil fungi and bacteria, and it has been long suspected that if we could grow more types of bacteria from soil or from exotic environments such as deep oceans, then we might find new natural antibiotics. In a recent study, researchers Kim Lewis and others found that they could isolate and grow individual soil bacteria, including types that can't normally be grown in the laboratory, and soil itself, which supplied critical nutrients and minerals. Once the bacteria reached a critical mass, they could be transferred to the lab and their cultivation continued. This simple and elegant methodology is their most important finding to my mind, for it opens a gateway to cultivating a wealth of potentially antibiotic-producing bacteria that have never been grown before. The first new antibiotic that they found by this approach, tioxobactin from a bacterium called Eleftheria terrae, is less exciting to my mind, though it doesn't look bad. Tioxobactin killed gram-positive bacteria such as S. aureus in the laboratory and cured experimental infection in mice. It also killed the tuberculosis bacterium, which is important because there is a real problem with resistant tuberculosis in the developing world. It was also difficult to select tioxobactin resistance. So what are my caveats? Well, I see three. First, tioxobactin isn't a potential panacea. It doesn't kill the gram-negative opportunists, as it's too big to cross their complex cell wall. Secondly, scaling to commercial manufacturing will be challenging since the bacteria making the antibiotic are so difficult to grow. And third, it's in its early days yet. As with any antibiotic, tioxobactin now faces the long haul of clinical trials. Phase 1 to see what you can safely give the patient, Phase 2 to see if it cures infections, and Phase 3 to compare its efficacy to that of standard care treatment. That's going to take 5 years and approximately 500 million pounds, and these are numbers we must find ways to reduce, while not compromising safety, if we're to keep ahead of bacteria, which can evolve far more swiftly and cheaply. Alright, question 46. The author of passage 2 would most likely agree with which statement about the development of tioxobactin? Alright, well, he would agree that it is, let's see, we have choice A, it reveals some antibiotics are effective against gram-negative. No, he explicitly said that it's not effective against gram-negative because it can't cross the complex cell wall. B, it shows conventional methods can still yield new types of antibiotics. Well, this is not a conventional method, right? This was a new method, right? It was a new way to harvest. And then C, it casts doubt on the practicality of searching for new antibiotics in exotic environments. We don't really talk about exotic environments, so we can get rid of C. D, it confirms a long-held belief about a potential source of new antibiotics. Now, how do we know that that's correct? Because when we go back up to passage 2, we see in the beginning, he says that it has long been suspected that if we could grow more types of bacteria from soil or from exotic environments, such as deep oceans, we might find new and natural antibiotics, right? So he's saying that what was discussed in passage 1 confirms that long-held belief about potential sources of new antibiotics. Now we're asked, 47, in line 79, caveats most nearly means. We go to line 79, square caveats, and then read the sentence and find what it means. So what are my caveats, right? And then he talks about 3 misgivings, right? 3 reasons that he doesn't see it as necessarily the most incredible thing of all time, right? So what are his 3 caveats? Caveats there is going to mean misgivings, right? Answer choice C. If we didn't come up with misgivings, right, we'd say we came up with a different word. Say we came up with a different word. Let's say we thought caveats meant something like, let me try to come up with something. Yeah, there's not really much else we could have came up with, to be honest. But let's say we came up with something else and it wasn't on here, right? We can get rid of exceptions, right? Because he says, so what are my 3 exceptions? But then he's not really saying anything's an exception to what, right? What's it an exception to, right? He doesn't state a rule, and these are exceptions to that rule, right? So we know it wouldn't be exceptions. Restrictions. So what are my 3 restrictions? Well, what he describes aren't restrictions, right? One of his reasons is that it would cost 500 million pounds to do it. Well, it doesn't mean it's not going to get done. It'll still get done. It's just going to be expensive. So restrictions would be incorrect there. And then explanations, he's not explaining anything, right? All he's doing is stating his misgivings, his caveats, right? The reasons that he thinks that this isn't necessarily the most incredible invention of all time, right? All right, 48. In the last sentence of passage 2, the author uses the phrase 5 years, 500 million pounds, primarily to what? Well, that's going to be to A, emphasize the scale of the effort needed to make tioxobactin available for consumer use, right? 500 million pounds is a lot of money, and 5 years is kind of a long time when you're talking about all these trials and all this time researchers have to spend in the lab, right? So he's emphasizing that scale of effort, that this isn't an immediate solution, right? And then we know B is incorrect because it says criticize the level of funding that the government has committed. We don't talk about government funding, so we can get rid of that. C, underscore the amount of time and money that has already been spent researching. No, right? That's about time and money that will be spent, not has already been spent. Not a whole lot has actually probably been spent on this, right? Because this is all kind of stemming from a Northeastern University study. And then D, compare the amount of money spent developing tioxobactin with the amount spent developing other antibiotics. He does not compare it to the amount spent on other antibiotics. All right, so now we got question 49. Which choice best describes the relationship between passage 1 and 2? All right, well, before I look at the answer choices, I'm going to try and come up with my answer choice. So passage 1 is presenting the findings, right? And passage 2 is evaluating those findings, evaluating their significance, both positive and potentially not necessarily negative, but what are his caveats, right? So kind of evaluating it. All right, so passage 1, introducing the topic, right? Introducing the scientific research, and then passage 2 is evaluating it. All right, so we have A, passage 2 offers an evaluation of the significance of the research discussed in passage 1. Yep, that's what we came up with. That'll be our answer. We can go ahead and show why B is wrong. Passage 2 suggests a modification to the methodology. It does not. It does not suggest a modification to the methodology discussed in passage 1. C, passage 2 uses concrete examples to illustrate concepts. We don't use concrete examples to illustrate concepts considered in passage 1. D, passage 2 takes a dismissive stance regarding the findings mentioned in passage 1. Okay, you may be tempted to pick this, but here's the thing. What makes this wrong is that he does not take a dismissive stance on it, right? He says that these findings are good, right? But he does say that they aren't necessarily the most, right, incredible thing, right? They can't use it immediately. It's going to take time, right? It can't kill gram-negative, but it can kill gram-positive. So he's not dismissing it. He still says it's important because it confirmed that we can do this, right? But he does say it's not necessarily going to be an immediate end-all, be-all solution. So that's why D would be wrong. All right, question 50. Both passages make the point that tioxobactin could be useful in what? Well, both passages make the point that tioxobactin could be useful in, let's see, we got A, standardizing the future development of antibiotics produced in laboratories. No, right? He doesn't talk about the future development of them produced in laboratories. In fact, we talk about how they're cultivated from the natural environments. B, combating infections no longer responding to treatment with other antibiotics. Yes, both of them say that this is important because treatments such as tuberculosis, right? They don't respond necessarily to other antibiotics, but they will to this potentially, right? So that's why our answer there will be B. It's not going to be C, controlling the spread of pathogenic soil fungi. We're not controlling the spread of pathogenic soil fungi. And then D, shaping a new method of studying the effectiveness of antibiotics. We're not really shaping a new method of studying it, right? But they do, or at least not in both, right? That's the important part here. Both passages, one of them might make point A, might make point C, might make point D, but both of them make B, and both of them do not make A, C, or D. All right, question 51. Information in passage 2 best supports which conclusion about the mice in the experiment described in passage 1? All right, information in passage 2 best supports which conclusion about the mice in the experiment described in passage 1? We've got A, exposure to tioxobactin made them less susceptible to subsequent upper respiratory tract infections. We never discuss subsequent upper respiratory tract infections. We only discuss the ones that they have and then that they are cured. We don't talk about ones that could potentially happen after that. So we can get rid of A. B, gram-positive bacteria enhanced the effectiveness of tioxobactin against their upper respiratory tract infections. No, right? Or, I'm sorry, yes, right? Gram-positive bacteria, right, that we discussed in passage 1, enhanced the effectiveness of tioxobactin against their upper respiratory infections. Or hang on, no, I'm sorry, B is incorrect. I read that wrong. Okay, yep, B is incorrect because it says gram-positive bacteria enhanced the effectiveness of it against their upper respiratory tract infections. No, this tioxobactin, it killed that gram-positive bacteria. It killed it, right? Gram-positive bacteria was the bad thing, so we know B is incorrect. I'm sorry about that mix-up, right? All right, now we got C. The respiratory tract infections were likely not caused by gram-negative bacteria. Yes, that is our answer, okay? How do we know that? Because in passage 2, it tells us that tioxobactin is not effective against gram-negative bacteria, but it is against positive. Therefore, we know those upper respiratory tract infections discussed in passage 1, they weren't caused by gram-negative bacteria because then tioxobactin would not have cured the upper respiratory tract infections. So we know our answer there is C. I'm so sorry about going down that wrong path on B. I misread the answer choice. Our answer is C here, right? And I just explained why. D, tioxobactin attacked the proteins rather than of the bacteria. No, right? We discussed how it attacks the lipids, not the proteins. So we can get rid of D. 52, what choice provides the best evidence to the previous question? We can go ahead and find it. It's in passage 2, right? It tells us that it's not effective against gram-negative. We see that that is, let's see. So it's in passage 2. We've got it right here. It doesn't kill the gram-negative opportunists, as it is too big to cross their complex cell wall. So I see that that ends at 82, and I see it starts at 80. So my answer for the evidence will be 80 to 82. So I'll go ahead and find that, and that will be answer choice D. All right, now we can go ahead and move on to passage 3. We've got questions 22 to 32. This passage is adapted from Sabrina Richards' Pleasant to the Touch. In the early 1990s, textbooks acknowledged that humans had slow conducting nerves, but asserted that those nerves only responded to 2 types of stimuli, pain and temperature. Sensations of pressure and vibration were believed to travel only along myelinated, fast-signaling nerve fibers, which also give information about location. Experiments blocking nerve fibers supported this notion. Preventing fast fibers from firing, either by clamping the relevant nerve or by injecting the local anesthetic lidocaine, seemed to eliminate the sensations of pressure altogether, but blocking slow fibers only seemed to reduce sensitivity to warmth or a small painful shock. Hakan Olasan and his Gothenburg University colleagues Ake Valbo and Johan Westberg wondered if slow fibers responsive to gentle pressure might be active in humans as well as in other mammals. In 1993, they corralled 28 young volunteers and recorded nerve signals while gently brushing the subject's arms with their fingertips, using a technique called microneurography, in which a fine filament is inserted into a single nerve to capture its electrical impulses. Scientists were able to measure how quickly or slowly the nerves fired. They showed that soft stroking prompted 2 different signals, one immediate and one delayed. The delay, Olason explains, means that the signal from a gentle touch on the forearm will reach the brain about half a second later. This delay identified nerve impulses traveling at speeds characteristic of slow, unmyelinated fibers, about 1 meter per second, confirming the presence of these fibers in human hairy skin. In contrast, fast-conducting fibers, already known to respond to the touch, signal at a rate between 35 and 75 meters per second. Then in 1999, so we have a second experiment, the group looked more closely at the characteristics of the slow fibers. They named these low-threshold nerves C-tactile or CT fibers, said Olazan, because of their exquisite sensitivity to slow, gentle, tactile stimulation, but unresponsiveness to noxious stimuli like pinpricks. But why exactly humans might have such fibers, which responded to only a narrow range of rather subtle stimuli, was initially mystifying. Unlike other types of sensory nerves, CT fibers could be found only in hairy human skin, such as the forearm and thigh. No amount of gentle stroking of hairless skin, such as the palms and soles of the feet, prompted similar activity signatures. Oluwasan and his colleagues decided that these fibers must be conveying a different dimension of sensory information than a fast-conducing fibers. Although microneurography can give information about how a single nerve responds to gentle brushing and pressure, it cannot tease out what aspect of sensation that fiber relays, says Olazan. He wanted to know if that same slow nerve can distinguish where the brush touches the arm and whether it can discern the difference between a goat hair brush and a feather. Most importantly, right, so this is important, could that same fiber convey a pleasant sensation? To address this question, Olazan's group sought out a patient known as GL who had an unusual nerve defect. More than 2 decades earlier, she had developed numbness across many parts of her body after taking penicillin to treat a cough and fever. Testing showed that she had lost responsiveness to pressure, and a nerve biopsy confirmed that GL's quick-conducting fibers were gone, resulting in an inability to sense any pokes, prods, or pinpricks below her nose. But she could still sense warmth, suggesting that her slow-conducting, unmyelinated fibers were intact. Upon recruiting GL, Olawazan tested her by brushing her arm gently at a speed between 2 to 10 centimeters per second. She had more trouble distinguishing the direction or pressure of the brush strokes than most subjects, but she reported feeling a pleasant sensation. When the researchers tried brushing her palm, where CT fibers are not found, she felt nothing. Olawazan used functional MRI studies to examine which areas of the brain lit up when GL's arm was gently brushed to activate CT fibers. In normal subjects, both the somatosensory and insular cortices were activated, but only the insular cortex, which processes emotion, was active when researchers brushed GL's arm. This solidified the notion that CT fibers convey a more emotional quality of touch, rather than the conscious aspect that helps us describe what we are sensing. CT fibers, it seems, specifically provide pleasurable sensations. All right, based on the passage, textbook authors in the early 1990s would most likely have expected which condition to result from blocking fast fibers? All right, well, if we go back up, right, and we need evidence anyways, so while we're up there, we're going to look for our evidence. So we're asked about what would have been expected to result from blocking fast fibers. All right, so we know that's going to be in the beginning. Well, it tells us sensations of pressure and vibration, right here, where this parenthesis starts. Sensations of pressure and vibration were believed to travel only along myelinated fast signaling nerve fibers, which also give information about location. All right, so that's basically telling us, hey, pressure and vibration were believed that they could only travel along fast signaling nerve fibers. So if those were blocked off, we wouldn't be able to sense pressure and vibration. All right, so that's also going to note that that's going to be from lines 4 to about 7, right? So lines 4 to 7 is going to be our evidence there. Lines 4 to 7, we can go and click on that. And then we've got, for our answer in 22, the rate at which other nerve fibers would increase. No, the test subject would perceive gentle stimuli as painful. No, the body would compensate by using slow fibers to sense pressure. No, the ability to perceive vibrations would be impaired, right? They wouldn't be able to perceive them because our fast fibers would be blocked. All right, question 24. As used in line 18, active most nearly means. So we find 18. 18 says, we're going to read the whole sentence, obviously, but we've got active right here. So we see what that means. We have Hakan Alwazan and his Gothenburg University colleagues Ake Valbo and Johan Westberg wondered if slow fibers response to gentle pressure might be active in humans as well as in other mammals, right? So whether that might be active in humans as well as other mammals, right? Whether that's present in humans or other mammals, right? That response, right? Whether that response is active, whether that response is present, right? If that response is there. Not if the response is attentive, not if it's movable, and not if it's restless. If it's present, right? If it's active in mammals and humans. All right, as used in line 24, capture most nearly means. Line 24, I look at my options here. We got capture is right here. So I'm going to go ahead and read that sentence. Using a technique called microneurography, in which a fine filament is inserted into a single nerve to capture its electrical impulses. Well, this is going to mean record, right? We have a fine filament is inserted in a single nerve to record or measure its electrical impulses, right? So we're looking for record there. So we're going to go down, see what our options are. We see we have record, C, and that's why I always recommend coming up with your answer for what it most nearly means before looking at your answer choices, because then you're not going to be swayed or caught between two because you have your own from the text, and that's really going to help you out so you don't get stuck between two or swayed by one of the first answer choices you read. All right, question 26. Which conclusion is best supported by the findings of Olawazan's 1993 experiment? Okay, keep in mind this is the 1993 one and not the 1999. So we're going to go ahead and we're going to look at our options here. We have stimulation at bodily extremities can be sensed as rapidly as stimulation closer to the brain. No, we weren't talking about distance to the brain or farther from the brain. B, the presence of hairs in human skin lessens the speed with which nerves conduct signals. No, it doesn't have to do with the presence of human hairs in the skin, right? What it has to do is with the fact of the kind of, here I'll go find it, the kind of nerves, right, that are in that, the type of skin with hairs versus without. It has to do with those nerves, right? Whether they're fast or whether they're slow. And then C, gentle pressure is sensed not only by fast fibers, but also by slow fibers. Or D, the speed at which a nerve fires is dependent on the strength of pressure applied. We never discuss strength of pressure, right? But we do talk about how gentle pressure is sensed not only by fast fibers, but also by slow fibers, right? And that's discussed above. I'm guessing we have to provide evidence for that. Yes, we do. So we're going to go find where it discusses gentle pressure being sensed by fast and slow fibers. We're going to look in the range between 22 and 30 primarily, because that's where our first three are. So we're going to go look at that. 22 to 30, we're going to look at that range, find where our evidence is. So we've got 22s here. Using a technique called microneurography, in which a fine filament is inserted into a single nerve to capture its electrical impulses, the scientists were able to measure how quickly or slowly the nerves fired. They showed that soft stroking prompted two different signals, one immediate and one delayed, right? So that's going to be evidence of one from the fast nerve signals, right, and one from the slow. So that's going to be our evidence there. We see that that's from 26 to 28. So that's where our evidence for that one's going to be. So that'll be answer choice B for 27. All right, now we can go ahead and move on to our next question. All right, our next question is going to be 28. The sentences in line 43 to 45, but to mystifying, serves mainly to do what? All right, let's go ahead and find our sentences. But mystifying serves mainly to do what? All right, well, we start here. We've got, but why exactly humans might have such fibers which respond only to a narrow range of rather subtle stimuli was initially mystifying, right? So they weren't quite sure why we would have these fibers, right, that are slow and only respond to a very small range of subtle stimuli, so not really anything crazy important at first glance, right? So now we're told in our question, what does it serve mainly to do? Well, it's not identifying factors that he had previously failed to consider. Is it proposing a solution to a dilemma encountered by Olazan? No, that doesn't propose a solution at all. It's more asking an intriguing question of why. Why is this like this, right? And then C, anticipated potential criticism. No, but what we are doing is we are showing a problem from the perspective of his team, right? The problem is they don't know why it would be there, right? Why would we need these if it's only giving us a narrow range, right? It's only giving us response to a narrow range of small stimuli. Then why would we need it, right? So that's the problem that they are facing in their perspective, right? So that's D. Question 29. It can be reasonably be inferred that one of the intended goals of the 1999 experiment was to determine what? Well, that's going to be the precise nature of sensations that CT fibers can convey. Or is it B, relationship between body hair and CT fiber function? No. Role played by CT fibers in the perception of pain? No. And then D, effect of microneurography on CT fiber signaling? No. If we go back up and we look at our, I believe we started as we read through it, right? It said most importantly, could that same fiber convey a pleasant sensation? That's what we were concerned with most importantly in that 1999 experiment, and that correlates with our answer choice A, determining the precise nature of the sensations CT fibers can convey. And then we have question 30, the main paragraph, the main purpose of the sixth paragraph, lines 64 to 75 is to what? Well, we're going to go find it, quickly brush over it. See, we start here. To address the question, they sought out a patient known as GL, and then we describe everything that makes GL the perfect patient for this experiment, right? So that's going to go down. We see we've got identify those of GL's neurological conditions that might be relieved by the experiment. No, it doesn't say anything about her conditions being relieved. B, contextualize the nerve function of GL by comparing it with other adults. No. C, detail procedures that GL had experienced during previous experiments. No. D, indicate why GL's medical condition was of value to the experiment, right? Why she was the perfect candidate for this experiment. According to the passage, GL differed from Olazan's other test subjects in terms of the what? A, number of cortices activated in the brain during gentle brushing. B, physical dimensions of the somatosensory cortex. We never talk about dimensions. C, intensity of nerve signals required to activate the insular context. No, we don't talk about the intensity of nerve signals. D, the effect of MRI scanning on the basic functions of brain cortex. No. If we remember back, right, we had the number of cortices activated in the brain during gentle brushing. It was about 3 for other people, and it was only 1 for GL, right? And I'm going to see, okay, we don't have to provide evidence, but I'm going to do it anyways just to show you. Right, we go ahead and we look at it. We've got brushing occurs here, right? And then we talk about the functional MRI studies in which areas of the brain lit up when GL's arm was gently brushed. We've got in normal subject, there was the somatosensory and the insular cortexes were activated, but only the insular cortex was active when they brushed GL's arm, right? So that's a different number of cortices activated. Question 32, according to the passage, humans experience an emotional aspect of touch when what? Well, that's going to be when CT fibers are exposed to a stimulus, right? That's what we talked about. That was the main goal to drive home in this passage. Not A, brain cortices are shielded from nerve signals. C, nerve fibers that sense pain are suppressed. No. And conscious aspects of sensation are ignored. No. It was all about CT fibers being exposed to stimulus. At least the back end was, right? So that's going to be our answer. Okay, we can go ahead and move on to questions 43 to the end, which will be 52. So 43 to 52 are based on the following. This passage is adapted from Peter A. Ensminger, Life Under the Sun, 2001, by Peter A. Ensminger. So I'll go ahead and read this. If you've already read it, you can go ahead and skip in to when I start getting into the answers and the answer explanations, but for now I'm going to go ahead and get started reading it. Many millennia before the invention of herbicides, farmers simply plowed their fields to control weeds. Even today, plowing can constitute a valuable part of an integrated weed management program. Although plowing kills standing weeds, farmers have long known that it often leads to the emergence of new weed seedlings in a few weeks. Ecologists have shown that a farmer's field can have 50,000 or more weeds per square meter buried beneath the soil surface. Plant physiologists have shown that seeds buried more than about 1 centimeter below the soil surface do not receive enough light to germinate. Do the blades of a plow, which can reach more than a foot beneath the soil of the surface, bring some of these buried seeds to the surface where their germination is induced by exposure to sunlight? All right, so that's what our question is. Two ecologists, Jonathan Sower and Gwendolyn Struik, began to study this question in the 1960s. In a relatively simple experiment, they went to 10 different habitats in Wisconsin during the night and collected pairs of soil samples. They stirred up the soil in one sample of each in the light and stirred up the other sample of each pair in the dark. They then exposed all 10 pairs to natural sunlight in a greenhouse. For 9 of the 10 pairs of soil samples, weed growth was greater in the samples stirred up in light. They concluded that soil disturbance gives weed seeds a light break, and this stimulates their germination. More recently, Karl Hartmann of Erlangen University in Germany reasoned that when farmers plowed their fields during the day, the buried weed seeds are briefly exposed to sunlight as the soil is turned over, and that this stimulates their germination. Although the light exposures from plowing may be less than 1 millisecond, that can be enough to induce seed germination. Thus, the germination of weed seeds would be minimized if farmers simply plowed their fields during the night. When the photon fluence rate, the rate at which photons hit the surface, is below 10 to the power 15 photons per square meter per second. Although even under these conditions, hundreds of millions of photons strike each square millimeter of ground each second. This illumination is below the threshold needed to stimulate the germination of most seeds. Hartmann says that he was very skeptical when he first came up with this idea because he assumed that such a simple method of weed control as plowing at nighttime must be ineffective or it would have been discovered long ago. But the subsequent experiments, first presented at a 1989 scientific meeting in Freiburg, Germany, clearly demonstrated that the method can be effective. Hartmann tested his idea by plowing 2 agricultural strips near Alterschassen, Germany. The farmer Karl Seidel cultivated one strip repeated threefold at around midday and the other strip at night. No crops were planted in these pilot experiments to avoid possible competition with the emerging weeds. The results were dramatic. More than 80% of the surface of the field plowed in daylight was covered by weeds, whereas only 2% of the field plowed at night was covered by weeds. This method of weed control is currently being used by several farmers in Germany. Because many of the same weed species that invade farmers' fields in Germany also invade fields elsewhere in the world, this method should be successful elsewhere. In fact, recent studies at universities in Nebraska, Oregon, Denmark, Sweden, Minnesota, and Argentina support this idea. All right, now we can go ahead and get into our questions. So we've got question 43 as our first question. I see we have a data table, so I'll probably have a question at the end on that. All right, so according to the passage, exposure to light allows seeds to do what? Begin to develop, right? Germinate, which means the seeds will begin to develop, not absorb necessary nutrients, not withstand extreme temperatures, not achieve maximum growth. All right, question 44. The question in the second paragraph, lines 13 to 17, primarily serves to what? Well, we can go back and look at it just so we, just as a, form the habit of using the text to make sure you're right. So we've got, do the blades of a plow, which can reach more than a foot beneath the soil, bring some of these buried seeds to the surface where their germination is induced by exposure to sunlight? Well, that's introducing our experiment, right? It's testing that question is what our experiment does. So that will be, we'll look at our answer choices. A, emphasize the provisional nature of the findings discussed in the passage. No. B, introduce the specific research topic addressed in the passage. C, suggest the hypothetical impact of the studies analyzed. Right, we're not discussing the hypothetical impact, right? We're discussing what happened in the study. And then D, indicate the level of disagreement about the methods. No, there isn't really a level of disagreement. What we're talking about, right, we're introducing that specific research topic of will those seeds germinate when they're exposed to light during the day, and should we plow at night instead, addressed in the passage. So our answer there is B. Now we got question 45. As used in line 16, induced most nearly means. We go up to line 16, find induced. We'll circle it, and now we'll read that sentence. Do the blades of a plow, which can reach more than a foot below the surface of the soil, bring some of these buried seeds to the surface where their germination is induced by exposure to sunlight? Well, here induced could mean stimulated, right? Their germination is stimulated by exposure to sunlight, caused by exposure to sunlight. So we'll go down, we'll look at our answer choices. It's not going to be lured, not going to be established, not going to be convinced. D, stimulated, right? Their germination is stimulated by exposure to sunlight. 46, which choice best supports the idea that seeds present in fields plowed at night are exposed to some amount of light, right? Well, if we go back up, we see, I remember where it was right here, right? Top of this second column here, it says, go ahead and read the first part of that sentence. Although even under these conditions being when farmers plowed their fields during the night, right? I'm circling it right here. During the night, even during the night, under these conditions, hundreds of millions of photons strike each square milliliter of ground each second, right? So I'm looking for my answer being, for evidence, being about 44 to about 47 here, right? 44 to about 47, 43, 47 if we're counting this part, right? So I'll go find that. 43 to 47 is going to be my answer. That would be C. 47. The passage suggests that if Seidel had planted wheat or corn on the 2 agricultural strips in Hartman's experiment, the percentage of the surface of each strip covered with weeds would likely have been lower than the percentage that Hartman found. Well, yes, right? The percentage of the surface of each strip covered with weeds would have been lower than the percentage Hartman found, and I'll go show you why, and I have to anyways because the next question's evidence, so I'll find that while I show you. So lower than the percentage Hartman found if he was planting crops there, because it says that there's competition between the weeds and the crops. So I'm going to find where it says that right here. No crops were planted in these pilot experiments to avoid possible competition with the emerging weeds, right? So if these weeds had to compete with the crops that were planted, the weeds would not have grown, right? There wouldn't have been as much weeds. There still might have been some, but there would have been less. Right? And I forgot, I got to get my line numbers to show you guys the evidence there. So that's going to be from 60 to 62, right? So that's going to be my evidence for that. So go down, and that is going to be answer choice B. All right, question 49. As used in line 62, dramatic most nearly means. I'm going to go find line 62, circle the word dramatic. Okay, what does it most nearly mean? Well, I read it, the results were dramatic. More than 80% of the surface of the field plowed in daylight was covered by weeds, but only 2% of the field plowed at night was covered by weeds. All right, so just coming up with possible answer choices for dramatic here. The results were staggering, anything along those lines, right? But yeah, we're not looking at like drama as in acting. We're looking at it was dramatic as in it was staggering, right? So theatrical is going to be out. The results were emotional. No, the results were not emotional. Were the results sudden? We're not giving a time frame, right? It's not like things grew in 5 seconds, right? I'm sure the weeds took time to grow, but the results were impressive, right? That was a big difference, that 80% versus 2%, right? All right, and then 50, according to the table, in which soil sample disturbed in darkness, so the soil sample disturbed in darkness, did the fewest number of seedlings emerge? I'm going to go find my table. I'm only considering my column that is disturbed in darkness, which is my right side column. And I'm asked for the one in which the fewest seedlings emerge, and that's going to be in sample A right there. So that'll be my answer there, sample A, and I see that sample A is choice A. So my answer for 50 will be A. I can go and move to 51. As presented in the table, which sample produced the most seedlings when the soil was disturbed in light? So my column is going to be now this left side, this light, and I'm asked for the one which had the most seeds emerge, which is sample I with 14. So my answer there will be sample I, which is C. Question 52. The data presented in the table most directly supports which claim from the passage? All right, so I've got the data presented in the table most directly supports which claim from the passage? All right, I'm going to go to lines 1, 3, 8, 10, 10, 13, and then 38, 43. So I'm going to look at the data real quick to get a synopsis of what's going on. All right, what I see is that I see the seedlings that are emerging in darkness is far less than those that emerged in light, right? So that's where I'm looking for my claim on that. Well, where my claim I don't believe it is right off the bat is going to be lines 1 to 3 and 8 to 10, because we don't, and 10 to 13 really, because we don't really get into a claim that early. Like all of that is really just introducing what our claim is. So I'm actually going to quick check and see if it's a D. So that's going to be 38 to 43, because I don't remember us talking about any claim along those lines here. So I'm going to go to lines 38 to 43 to start. So 38 to 43. All right, I see, thus the germination of weed seeds would be minimized if farmers simply plowed their fields during the night when the photon fluence rate is below 10 to the power 15 photons per square meter per second. Yes, that's what our data supported, right? It's supporting how the germination of these weed seeds is less when it's plowed during the night, which is what our data showed. So that's going to be my answer there, and that was answer choice D. So hopefully this video is helpful in preparing for the science passages on the SAT reading section and the SAT reading section as a whole. If you're looking for compilation videos on the literature passages from the SAT reading section, the social science passages, or the history passages, you will find those in a playlist at the end of this video, as well as in our channel if you go to our playlist there as well. Like I said, I also made a 90-day SAT prep course available for free on my channel. I scored 1590 on the SAT, so I believe that that would be very helpful to you as well. So you can find that in our channel under the playlist, or it'll probably pop up at the end of this video as well. As always, make sure to like, share, and subscribe for more videos to help you prepare for the SAT. Any private SAT tutoring I'm doing or college admissions consulting I'm doing will be found in the description if it is available. Also, there will be a donation link in the description, so you can donate to me if you find these videos helpful. They take a lot of time and effort and hard work, and I obviously am releasing them for free because I believe that releasing them for free is a very good thing to do. But I obviously would appreciate any donations you could send my way. So as always, make sure to like, share, subscribe, and have a great day.